Now let's see about definition of data structure. Data structure is an arrangement of data in the computer's memory. So data structure mainly specifies how the data will be stored in the computer's memory. Generally, the data may be stored either in contiguous memory locations. Contiguous means adjacent memory locations or some non-adjacent memory locations. If you take array is a data structure. Structure is a data structure. Okay. If you take array and structure, then the elements will be arranged in adjacent memory locations. So let an array is like this: int a of 5. Let the size of the integer is 2 bytes. Let the starting memory location is 1000. So int occupies 2 bytes of memory. So a of 0 will be stored at 1000 memory location. Next 1000 and 1001 occupied by a of 0, because we are assuming that the size of the integer is 2 bytes. So a of 1 will be stored at 1002 and 1003 memory locations. Next a of 2 will be stored at 1002 and 1003 is occupied by a of 1. So 1004. So likewise the data will be stored. So likewise if you take a structure, so struct some student, int roll number, char some name of 20. Here also the data will be stored in adjacent memory locations. Let the size of the integer is 2 bytes. So roll number is occupied by some 1000 and 1001. Next at 1002 memory location name will be stored. So here the point is data structure specifies how the data will be stored in the computer's memory. The data may be stored either in adjacent memory locations or non-adjacent memory locations. So arrays and structures, the elements of array as well as structure will be stored in adjacent memory locations. So the first element stored at 1000, next element at 1002, next element at 1004. Likewise, here also the first element at 1000, next 1002. So likewise the data will be stored. Whereas if you take non-contiguous memory locations, non-adjacent memory locations, linked list and trees, graphs are the examples for non-contiguous memory locations. In linked list means collection of nodes. Let the first node is stored at 1000 memory location. Then the second node may be stored at some 500 or 200 or 300 or any other memory locations. So here the data need not be stored in adjacent memory locations. So that is the first point here. These are various definitions. So this is the first definition. Now let's see the second definition for a data structure. Data structure is a collection of elements and the operations that are to be performed on those elements. So data structure can also be defined as a collection of elements and the operations that are to be performed on those elements. Stack is a data structure. It contains a collection of elements and we can perform operations like push pop operation on the stack. Queue is a data structure. It contains a collection of elements and we can perform operations like NQ and DQ operations. Likewise, array is a data structure. On array we can perform operations like insertion at beginning position, specified position, end position, deletion operations, reverse of the array. Likewise we can perform so many operations on the data structure. Now let's see the next definition for a data structure. Data structure is a way of organizing data in a computer so that we can perform operations on those data in an effective way. So data structure is nothing but how we are organizing the data in the computer's memory. Organizing is nothing but how we are storing the data in the computer's memory. So already we discussed that topic. Okay, the data may be stored either in adjacent memory locations or some non-adjacent memory locations. So here let's see the next definition. Data structure specifies not only the elements to be stored but also their relationship to each other. So data structure specifies not only the elements to be stored. So data structures not only specifies what are the elements to be stored, but also it specifies the relationship between those elements. So if we take arrays, then we can call these elements are some adjacent elements. If we take some tree, then the first node is called as root node. So root node can be called as grandparent node, and root node children are known as parent nodes, and parent node children are known as children nodes likewise. So if you take tree, then there is a relationship among all the nodes in the tree. Whereas if you take arrays or linked list, then we can call them as some adjacent elements. Okay. Now let's see the next point. So these are the various definitions for a data structure. So first definition, second definition, third one, fourth one. So we can write any one definition in the examination. To develop a program for an algorithm, we should select an appropriate data structure. So here our target is we need to solve a problem. So in order to solve a problem, we need to develop a program. But before developing the program, we have to write an algorithm. So that is the point here we are writing. To develop a program for an algorithm. So first we are writing the algorithm, and after that we have to write a program for the algorithm. So in order to develop a program for an algorithm, we should select an appropriate data structure. So in order to implement that algorithm, we need to select appropriate data structure. It may be either array or structure or some stack or queue or linked list or trees or graphs. So depends upon our problem. We need to select an appropriate data structure in order to implement that problem. Okay. So data structure is represented as algorithm plus data structure is nothing but program. Okay. So here our target is we have to solve a problem. So in order to solve a problem, first we need to write the algorithm, and after that in order to write the program, we should select an appropriate data structure. So algorithm plus data structure is nothing but program. So here DS means data structure. So this is the definition for a data structure. Now let's see about types of data structures. Data structures are mainly classified into two types. The first one is linear data structure. Second one is non-linear data structure. Now let's see the first one, linear data structure. In linear data structure, all the elements are stored in linear fashion. So linear means sequential manner. So in linear data structure, all the elements are stored in linear manner. That means sequential manner. The best examples for linear data structures are arrays. If you take structures, structures are also linear data structures. Arrays, structures, stacks, queues, linked list. So these are the best examples for linear data structures. So if you take arrays, then what will happen is, let this is nothing but an array. So the first element will be stored here. Let it be some 1000 memory location. Let the second element memory location is 1002. Next element memory location is 1004. Next element is 1006. So likewise all the elements are stored in sequential manner, one by one. So first element, after that second element, after that third element. So likewise all the elements will be stored. Likewise in stacks, queues and linked list also, all the elements will be stored in sequential manner, one by one. If you take linked list means a collection of nodes. Let the first node is this one. So let the address of this node is 1000. Next, let the second node address is 2000. Let the third node address is 3000. So likewise all the elements are organized, stored in sequential manner. So one by one. So we know what is array. Array means a collection of elements which are stored in contiguous memory locations. Structure is also linear data structure. So structure is also, it contains a collection of different data type elements which are stored in some adjacent memory locations. So the major difference between arrays and structure is array contains collection of similar data type elements, whereas structure contains collection of different data type elements. So in structure also all the elements will be stored in sequential manner, one by one. So let the first element is stored here, next element is stored here, next element is stored here. Likewise, all the elements will be stored. So stack is also a collection of elements, and we can perform operations like push operation, pop operations on the stack. Queue is also a collection of elements, and we can perform operations like NQ and DQ operations on the queue. Stack works on the principle of last in first out, whereas queue works on the principle of first in first out. Okay, so linked list means a collection of nodes. Okay, so this is about what is linear data structure. We will discuss more about what is stack, what is queue, what is linked list in the upcoming videos. Now let's see what is nonlinear data structure. In nonlinear data structure, all the elements are stored in non-linear manner. So non-linear manner means random manner. So the best examples for non-linear data structures are trees and graph. So a tree is nothing but a collection of nodes. Here the first node is called as root node. Next, let us assume that these two are nothing but some parent nodes. These two are nothing but children nodes, or we can call these as some leaf nodes. Okay. So first element is stored here, second element is stored here, next element is stored here. Likewise, the elements are stored. So this is nothing but non-linear manner. Non-linear manner. Okay. Whereas this arrangement is called as linear manner. Okay. So we can construct a graph is also like this. Some hierarchical information. If we want to represent some hierarchical information, then we can use this non-linear data structure. So hierarchical information means some grandparent level, parent level, children level, likewise. So this is a tree. So this is nothing but root node. Okay, and these two are nothing but children of the root node. Okay, and this parent node children are nothing but these two nodes. Okay, so these nodes are known as leaf nodes. Why? Because these nodes doesn't contain any children. Okay, so graph is also an example for non-linear data structure. So this is about types of data structures. So we have linear data structure as well as non-linear data structure. So in linear data structure, all the elements are stored in linear fashion, sequential manner, one by one. Whereas in non-linear data structure, the elements are stored in non-linear manner. So this is nothing but non-linear manner. So first level, second level, third level, like that. Okay. So if we want to represent some hierarchical information, so then we have to use this non-linear data structure. So we will discuss about trees and graphs, linked list, stacks and queues in the upcoming videos. So this is about different types of data structures. Now let's see about abstract data type. In short, we can call it as ADT. So we know what is a data type. By using data type, we can declare a variable which can store some value. If you take int data type, then it stores integer values. If you take float data type, it stores floating point values. Whereas abstract data type means this is not the built-in data type. So this is some user defined data type. Okay, so that's why we name this one as abstract data type. Okay, so abstract data type is nothing but an user defined data type. So the data type is defined by the user, that is not the built-in data type. Let's see the definition here. ADT is a set of operations. So any ADT is a set of operations. If you take array ADT, then on array we can perform operations like create operation, display operation, insertion operation, deletion operation, updation, reversing, sorting. Likewise, we can perform n number of operations. If you take structure, then we can perform operations like some insertion, deletions, similar operations. If you take stack, then we can perform operations like push operation, pop operation. So that is nothing but ADT. So ADT can be defined as a set of operations. ADT specifies what is to be done, but how it is done is not specified. That is, all the implementation details are hidden. So what is ADT here? It specifies what is to be done, but how it is done is not specified. That means the implementation details are hidden. Let us take the example of a bike. We can drive a bike, but we don't know the components like clutch, gear, all those components are implemented. Okay, so if you take this board. Okay, we can write something on the board, but we don't know how this board is internally designed. Okay, so that is nothing but ADT. So ADT means it specifies what is to be done, but how it is done is not specified. So that is nothing but all the implementation details are hidden. The best example is some bike. We can drive a bike, but we don't know how the components like clutch, gear, all the components are implemented. Okay, so without knowing those implementation details, we can drive the bike. So that is nothing but ADT, some abstraction. So abstraction means representing essential features and hiding the background details. So here, what is the essential feature? Driving the bike. So this bike is our essential feature, but it is not necessary to know how those components will work. Okay, so that is nothing but abstraction or abstract data type. So let's take this example. For example, stack ADT have operations like push, pop, but we don't know how those operations are implemented. That is, implementation details are hidden. So if you take stack, so the stack ADT may contain some operations like push operation. On stack we can perform operations like push operation, pop operations and peep operations. So stack ADT have these operations, but we don't know how these operations are implemented, because it is the duty of the developer or it is the duty of the programmer in order to implement that program. So as a user, it is not necessary to know the implementation details. So we can work with some banking software, but we don't know how it is internally implemented. So that is nothing but some banking ADT. So this is the definition for ADT. Now let's see about list ADT. List means a collection of elements. So we can define a list as a collection of elements. So let the list is of the form, let the list contain some elements like A1, A2, so on, AN, where A1 represents the first element of the list, A2 represents the second element of the list, likewise AN represents the last element of the list. So we can say that the size of the list is n. If the list size is 0, then we can say that it is an empty list. So this is nothing but the definition of a list. So list means it is basically a collection of elements. So let us assume that a list is of the form A1, A2, so on, AN, where A1 represents first element of the list, A2 represents second element, A3 represents third element, AN represent the last element of the list. Okay, so we can say that the size of the list is n. If the list size is 0, then we can say that it is an empty list. We can implement list in two ways. The first approach is list ADT, implementation of list using arrays, and the second approach is list ADT using pointers, or we can call as linked list. So list ADT is implemented in two ways. The first approach is implementation of list using arrays, and the second approach is implementation of list using pointers or linked list. So let's see the first one. So what is the first one? Implementation of list using arrays. So we know what is array. Array means a collection of similar data type elements, and all the elements are stored in adjacent memory locations. If you take integer array, it stores only integer elements. If you take floating point array, it stores only floating elements. If you take character array, then it stores only character elements. Okay. So let's see how we can implement list with the help of arrays. Here we are writing a simple program to read and display the array elements. So let it be some. Let me have some main function. So let name of the array is int a of 10 comma n comma I. So n represents number of elements. Here A means name of the array. So next, first printf enter. Printf enter. So first we have to enter size of the array. Enter size of array. Here the size of the array is denoted by n. So scanf %d comma %n. Next to printf enter. So after reading the size, we need to read the array elements. So printf enter array elements. Here the array contains more than one element. So for reading we have to use for loop or while loop or do while loop, any loop. So for I is equal to 0, I less than n, I plus plus, scanf %d comma %a5. So this is a simple program to read and display the array. So reading is over, now display the elements. So printf array elements are, so use a for loop for printing the elements. For I is equal to 0, I less than n, I plus plus, printf %d /t comma a of I. So in this way we can write a simple program to read and display array elements. And on array we can perform operations like inserting an array element at beginning position, inserting an array element at end position, inserting an array element at specified position, likewise deleting at begin position, specified position, end position, updating element, reversing the array, next sorting the array. So likewise we can perform so many operations. So we will discuss all those operations in the upcoming videos. As well as there are some drawbacks with arrays. In order to overcome those drawbacks, we can implement list using pointers or linked list. So the drawbacks of arrays will also be discussed in upcoming video. So in order to overcome the limitations of the arrays, we uses pointers or linked list. So in the examination, if this question is given for some 15 marks or some 16 marks, then we have to write the definition for the list, and after that implementation of list using arrays, write the definition for array and write a sample program in order to read and display the array, and after that write the operations. Only write the operations, array operations, insertion, deletion. There is no need to write any program. Next one, implementation of list using linked list. So we need to write the what is a linked list, and we have three types of linked list: single linked list, circular linked list, and double linked list. And we need to write a simple program in order to implement a single linked list. Whereas if this question is given for only 8 marks, so then there is no need of that much explanation. So write the definition for array and some small program, and write the definition for a linked list and some 1 or 2 operations like create and print operation. There is no need to write all the operations of the linked list. So in the upcoming videos we will see what are the various operations that we can perform on arrays, and what are the limitations of arrays, and in order to overcome those limitations we implement list with the help of linked list or pointers. In this class we are going to discuss about the list of array operations. So that means the operations which we can perform on arrays. So a list of array operations. So we can perform so many operations on the array. We know that array means a collection of similar data type elements. Here the first operation is inserting an element into the array at begin position. Second operation, inserting an element into the array at specified position. Third operation, inserting an element into the array at end position. Fourth operation, deleting an element from the array at begin position. Next, fifth operation, deleting an element from the array at specified position. Next, sixth operation, deleting an element from the array at end position. Next, seventh operation, updating an array element. Updating an array element. Next operation, reversing array elements. Next operation, sorting an array. Next operation, searching an array. Next operation, merging two arrays. So we can perform all these operations on the arrays. The first operation is inserting an element into the array at begin position. Second operation is inserting an element into the array at specified position. Third operation, inserting an element into the array at end position. So we have three insertion operations: begin position, specified position, next one end position. Likewise, we have three deletion operations. The first one here is deleting an element from the array at begin position. Next operation, deleting an element from the array at end position. Next operation, deleting an element from the array at end position. Seventh operation, updating an array element. Eighth operation, reversing array elements. Ninth operation, sorting an array. 10th operation, searching an array. 11th operation, merging two arrays. So these are the various operations which we can perform on arrays. So in the upcoming videos, we will discuss all these operations. In this class, we are going to discuss about a C program to insert an element into the array at begin position. C program to insert an element into the array at begin position. So we have to insert an element into the array at begin position. So now let's see how we can solve this problem. In this program, the input variables are size of the array n, array elements, and the element which we are inserting. So the first one is size of the array. So let n is equal to 5. So that means totally we can store 5 elements in the array. So we know that the index of an array starts from 0 and continues up to size minus 1. So and continues up to n minus 1, that is nothing but 4. So the elements of the array are a of 0, a of 1, a of 2, a of 3 and a of 4. So let elements of the array are 10, 20, 30, 40 and 50. So this is nothing but size of the array. These are nothing but elements of the array. So in this problem, our aim is we have to insert an element into the array at beginning position. So we require another input variable. That input variable is element. So which element we are inserting? So we require one more input variable, that is element. So let the element here is 100. So we have to insert 100 at beginning position. So initially the size of the array is 5, but after inserting this element into the array at beginning position, totally array contains 5 plus 1, 6 elements. So we have to increment the size of the array. So that is nothing but our first step, n plus plus, n plus plus. Initially the size of the array is 5. So after incrementation n becomes 6. So now we can have 6 elements from a of 0 to a of 5. A of 0 to a of 5. A of 5. So initially the size of the array is 5, but after incrementation the size becomes 6. So index starts from 0 and continues up to 5. Here the logic is very simple. We have to move all the elements of the array one position to its right. So a of 4 will be moved one position to its right. So a of 4 element will be stored in a of 5, 50. Next a of 3 element will be moved one position to its right. So a of 3 element will be stored in a of 4. Next a of 2 element will be moved one position to its right. So a of 2 element will be stored here. Next a of 1 element will be moved one position to its right. So a of 1 will be stored in a of 2. Next a of 0 element will be stored in a of 1. So in this example, what is our target? We have to insert the element at beginning position. So at the beginning position we have to insert 100. So after inserting the element into the array, the output is this one. So 100, 10, 20, 30, 40 and 50. Now let's write the program. So here the first statement is hash include stdio.h. Why? Because we are using printf and scanf functions. Those two functions are available in stdio.h. Execution of a program starts from main function. And what are the input variables here? N, ele and some array. And we require a for loop. So for repetition, let us declare a variable called I. So let us declare the variables int n comma. Let the size of the total number of elements of the array are a of 10 comma ele comma. To perform operations on the for loop, let us declare a variable called I. So first, what is the input variable? Size of the array. So printf enter size of the array. Printf enter size of the array. Next statement scanf %d comma %n. So size of the array is readed. Let n value is 5. Next we have to read array elements. So printf enter array elements. Array elements. Here the index of the array starts from 0 and continues up to n minus 1. So I less than or equal to n minus 1, or we can write as I less than n. So here the for loop is index starts from 0 and continues up to n minus 1, or we can write as I less than n. Next I plus plus. Here we are reading the elements. We are reading integer elements. So scan of %d comma m % a of 5. So let n value is 5. Then totally we have 5 elements. And what are its values? 10, 20, 30, 40 and 50. Next we have to read element. So printf enter element to be inserted. Enter element to be inserted. So here what is the element we are inserting? ele. So scanf %d comma m % ele. So in this example, what is ELE value? 100. In this program, we are inserting an element into the array at begin position. So initially the size of the array is 5, but after inserting the size becomes 6. So here the first statement here is n plus plus. So initially what is n value? 5. So now n becomes 6. So what is n value now? N is equal to 6. Next, in this program, so how many movements are needed here? So this is the first assignment, second assignment, third assignment, fourth assignment and fifth assignment. So totally 5 assignments are needed here. So what is the first assignment we have to perform? We have to store a of 4 value in a of 5. So that is the use of is equal to. What is the use of is equal to? It assigns a right hand side value to left hand side variable. Here what is the left hand side one? A of 5 is equal to a of 4. So this is the first statement. So what is a of 4 value? 50. So this 50 will be stored in a of 5. Next, what is the next assignment? A of 4 is equal to a of 3. Next one, a of 3 is equal to, so we have to store a of 2 value in a of 3. So a of 3 is equal to a of 2. Next we have to store, what is the next assignment? A of 2 value is stored in a of 3. So the next assignment is a of 2 is equal to a of 1. So store a of 1 value in a of 2. Next assignment, a of 1 is equal to a of 0. So totally we have to perform 3 assignments. So for this we have to write the logic. Let the initial value of the I is n here. So after incrementation, what is n value? 6. So what is I value now? For I is equal to 6. So then what is the body of the loop here? We here the left hand side one is 5, whereas the right hand side here the right hand side one is 4. So how to get 5 from 6? Then how to get 4 from 6? So how to get 5 from 6? Simply by subtracting from 1. So here the body is very simple. A of I minus 1 is equal to A of I minus 2. So what is I minus 1 here? I means 6. So 6 minus 1 means 5. So A of 5 is equal to A of 6 minus 2 means 4. So that is nothing but the first statement. Then how many assignments are needed here? First, second one, third one, fourth one, fifth one. So totally 5 assignments are needed. So what is the condition we have to write here? Here I value is 6. Let us take the condition as I greater than 1. So 6 greater than 1, first assignment, 5 greater than 1, 4 greater than 1, 3 greater than 1, 2 greater than 1. So totally 5 assignments. Next, 1 greater than 1, condition is false. So here the condition is I is greater than 1. Next, first we have to store 4 in 5, next 3 in 4, next 2 in 3. So what we have to do? Every time we have to perform decrementation. So I minus minus. So this is our logic here. Let's check whether our logic is correct or not. So we know that what is n value now? N value is 6, because after incrementation it has to store how many elements? Initially array contains only 5 elements, now array contains 6 elements. So now n is equal to 6. So for I is equal to 6. So I value is 6. Next, 6 is greater than 1. So 6 is greater than 1. Condition is true. So body will be executed. A of 5 is equal to A of 4. So this A of 4 value will be stored in A of 5. So first assignment is done. Next, I minus minus. Now I becomes 5. So 5 is greater than 1. Condition is true. So A of 5 minus 1. So A of 4 is equal to A of 3. So A of 3 value will be stored in A of 4. So second assignment is also over. Next, I minus minus. I becomes 4. 4 is greater than 1. Condition is true. So body will be executed. So A of 4 minus 1 is equal to A of 4 minus 2. So what is 4 minus 1? 3. So A of 3 is equal to A of 4 minus 2. So what is 4 minus 2? 2. So A of 3 is equal to A of 2. So A of 2 value will be stored in A of 3. Next, I minus minus. Now I becomes 3. 3 is greater than 1. Condition is true. So body will be executed. So what is I value now? 3. So A of 3 minus 1 is equal to A of 3 minus 2. So what is 3 minus 1? 2. So A of 2 is equal to A of 1. So what is A of 1 value here? 20. So 20 will be stored in A of 2. So this is also executed. Next, I minus minus. I becomes 2. So 2 is greater than 1. Condition is true. So body will be executed. So A of 2 minus 1. A of 1 is equal to A of 0. So A of 0 value will be stored in A of 1. Next, I minus minus. Now I becomes 1. So 1 is greater than 1. Condition is false. So control comes out from the for loop. So in 0 position, we have to store the corresponding element. So here the next statement is A of 0 is equal to ELE. So what is ELE value? 100. So 100 is stored in this A of 0. So now our output contains the proper statements. So initially these are the values, and after insertion 100, 10, 20, 30, 40 and 50 is the output. Now we have to display the output. So printf after insertion array elements are just use the for loop for printing the data. So for I is equal to 0, I less than n, I plus plus. So printf after percentage d use some slash d. So 3 or 4 spaces will be printed. Display the array elements. So in this way we can insert an element into the array at beginning position. In this class we are going to discuss about a C program to insert an element into the array at specified position. C program to insert an element into the array at specified position. So in this program we have to insert an element into the array at specified position. First let's solve this problem mathematically. Let the size of the array is 5. So n is equal to 5. So we can have 5 elements from A of 0 to A of 4. Why? Because index starts from 0 and continues up to n minus 1. A of 4. Let here the elements of the array are 10, 20, 30, 40 and 50. So in this program we have to insert an element into the array at specified position. So we require 2 more variables. The next variable here is position. So at which position we have to perform insertion operation. Let here the position value is let it be 3. Next input here is in element. So what is the element we have to insert? So in this program we have to insert an element called 333 at third position. So this is first position, this is second position, so this one is nothing but third position. So after inserting 333 into the array, the output is 10, 20. We have to insert the element at third position. So 333, 30, 40 and 50 will be the output. So initially the size of the array is 5. But after inserting an element into the array, the size will become 6. So the first operation which we have to perform is n plus plus. So initially n value is 5. Now n becomes 6. So we can have how many elements now? 6 elements from A of 0 to A of 5. Because index starts from 0 and continues up to n minus 1. Now n is 6. So 6 minus 1 means 5. So A of 2, next element A of 3, next element A of 4, next element A of 5. So in this program, we have to insert 333 at third position. So there is no change in first two elements because we are inserting the element at any position. It may be 0th position or first position or second position or third position or fourth position or fifth position, any position. But in this example, our target is we have to insert this element at third position. So there is no change in the first two elements. So keep the first two elements same as it is. So next what we have to do? We have to place this element 333 at third position. Now we have to shift each element one position to its right. So just like inserting at beginning position. So AR4 element is shifted to AR5, one position to its right. AR3 element will be shifted to, so one position to its right. So now what is AR3 value here? 40. So now AR4 will become 40. Next AR2 element will be shifted one position to its right. So now this 30 will be stored here. So we are shifting AR4 element one position to its right. So 50 is now stored in AR5. Next AR3 element is shifted one position to its right. So now AR4 becomes 40. Next AR2 element is shifting one position to its right. So now AR3 becomes 30. So this is the element which we are inserting. So we have to write the logic while writing the program. So first let us perform the readings. So here the first statement is hash include stdio.h because we are using printf and scanf functions in this program. C program execution starts from main function. So in this program the input variables are n comma a of 10 comma next position comma ele comma. So to perform operations on the for loop, let us declare a variable called I. So first read size of the array. So printf enter size of the array, enter size of the array. So size of the array is denoted by n. So scanf %d comma ampersand n. So next, so let n value is 5. Next we have to read array elements. So printf enter array elements. Printf enter array elements. Next, for I is equal to 0, I less than n, I plus plus. Why? Because here we are reading more than one element. So we have to use the for loop. I less than n, next scanf %d comma ampersand a5. So elements are also readed. Let elements of the array are 10, 20, 30, 40 and 50. And the next input variables are position and element. So printf enter the position at which element is inserted. At which element is inserted. So at which position we have to insert the element. So here for position the name of the variable is POS. So scanf %d comma ampersand POS. So in this program, in this problem, let us assume that position value is 3. Next we have to read the element. So printf enter the element. Enter the element to be inserted. So element is declared with the help of a variable called ele. So the next statement here is scanf %d comma ampersand ele. Now we have to write the logic. Here we are inserting the element at third position. So there is no need to change the first two elements. So let's see the logic here. So how many assignments are needed here? 3 assignments are needed. The first assignment is store AR4 value in AR5. So the first assignment here is AR5 is equal to AR4. So what is AR4? 50. So 50 will be stored in A of 5. And the next assignment is A of 4 is equal to A of 3. So what is A of 3 value? 40. So 40 will be stored in A of 40. What is A of 3 value? 40. So 40 will be stored in A of 4. Next assignment, A of 3 is equal to A of 2. So here A of 2 value is 30. So 30 will be stored in A of 3. So we have to write the logic here. So let's write the logic. For let the initial value of I is POS. I is equal to POS. Then what is the condition here? So how many movements are needed here? How many assignments are needed? So this is nothing but first assignment. So this is nothing but second assignment. This is nothing but third assignment. So 3 assignments are needed here. So what about the position value? The position value is 3 here. So what is the first operation we are implementing? A of 5 is equal to A of 4. So here what is I value? So the initial value of the I is 3. So now we have to write the logic here. Let the initial value of the I is n. So for I is equal to n. So after implementation, what is n value? 6 is n value. So now I contains 6. So what is the first statement here? A of 5 is equal to A of 4. So how to get 5 from 6? So A of 5 minus 1 is equal to, how to get 4 from the 6? A of 5 minus 2. So the body of the for loop is very simple. A of I minus 1 is equal to A of I minus 2. So this is nothing but is equal to operator. Next, how many assignments are needed? 1, 2, 3. 3 assignments are needed here. What about position value? 3. So if we write the condition as I greater than 3, then how many assignments will be done? So what is the initial value of I here? 6. So 6 greater than 3. Next, 5 greater than 3. 4 greater than 3. Very good. Next, 3 greater than 3. Condition is false. So here the condition is I is greater than, it's not 3. 3 is nothing but the value of position. So I greater than POS. Next, first 4 value. Next to 3 value. Next to 2 value. So every time what we are doing, we have to decrement I value. So I minus minus. So let's check whether our logic is correct or not. So I is equal to n. So I is equal to 6. Next to condition, 6 is greater than, what is POS? 3. So 6 is greater than 3. Condition is true. So body will be executed. So what is the body? A of 5 is equal to A of 6 minus 2 means A of 4. So A of 5 is equal to A of 4. So what is A of 4 value? 50. So 50 will be stored in A of 5. Next I becomes 5. So 5 is greater than 3. Condition is true. So A of 5 minus 1. So 5 minus 1 means 4. So A of 4 is equal to A of 3. So A of 3 value will be stored in A of 4. Next I minus minus. So now I becomes 4. So 4 is greater than 3. Condition is true. So A of 3 is equal to A of 4 minus 2. So what is 4 minus 2? 2. So A of 3 is equal to A of 2. So A of 2 value will be stored in A of 3. Next I minus minus. 3 greater than 3. Condition is false. So control comes out from the for loop. So these 3 assignments are done now. So now we have to perform this operation. What is position value? 3. So how to get this 2 from 3? So A of POS minus 1 is equal to EI. So what is element here? 333. So 333 will be stored in A of position minus 1. A of 3 minus 1. A of 3 minus 1 means A of 2. So the entire logic is over. Now we have to display the output. So printf after insertion array elements are so use a for loop because we are displaying more than one element. So for I is equal to 0, I less than n, I plus plus, printf %d /t comma A of I. So in this way, we can write a program to insert an element into the array at specified position. In this class, we are going to discuss about a C program to insert an element into the array at end position. So C program to insert an element into the array at end position. So we have to insert an element into the array at end position. So first let's solve the problem mathematically before writing the program. So let the size of the array is 5. So we can have 5 elements from A of 0 to A of 4. So A of 0, A of 1, A of 2, A of 3 and A of 4. Let array elements are 10, 20, 30, 40, 50. So in this program we have to insert an element into the array at end position. So let the element value here is some 60, 666. So we have to insert this element at end position. So initially the size of the array is 5. So we can store totally 5 elements. But after inserting, array size becomes 6. So here the first statement which we have to perform is n plus plus. So now n becomes 6. So totally we can store 6 elements in the array from A of 0 to A of 5. So A of 0, next A of 1, A of 2, A of 3, A of 4, A of 5. So there is no need to change the first 5 elements. So we have to keep all those elements as it is. And we have to store 666 at A of 5. So what is n value now? 6. So how to get 5 from 6? So A of n minus 1 is equal to ELE. So that is the only statement we have to write. So let us write the program. So hash include stdio.h, because we are using printf and scanf functions. Those two functions are available in stdio.h main function. So what are the input variables? Int n comma, let name of the array is A, let the maximum elements are 10, next ELE, and we require a for loop. So to perform operations on the for loop, let us declare a variable called I. Next, first read size of the array. So printf enter array size. Array size. So array size is denoted by n. So the next statement here is scanf %d comma %n. So what is n value here? 5. Next we have to read array elements. So printf enter array elements. Array elements. Here the index value starts from 0 and continues up to n minus 1. So for I is equal to 0, the condition can be written as I less than or equal to n minus 1 or I less than n, next semicolon I plus plus. We are performing reading, so we have to use scanf function. So scanf %d comma %a of I. So here array totally contains 5 elements. The next input here is element. So printf enter the element. Printf enter the element. So to be inserted into the array. So how to denote the element? Element is denoted by ELE. So scanf %d comma %ELE. Now here we are inserting the element at end position. So there is no need to change the first 5 elements. So initially the size of the array is 5, but after incrementation the size has to become 6. So in order to get 6, let us perform incrementation operation n plus plus. So now n becomes 6. So we have to store 666 in A of 5. So how to get 5 from 6? So A of n minus 1. So only one statement, that is A of n minus 1 is equal to ELE. So what is ELE here? 666. What is n value after incrementation? 6. So 6 minus 1 means 5. So A of 5 is equal to ELE. So this ELE 666 will be stored here. Now we have to display the array elements after insertion. So printf after insertion array elements are so index value starts from 0. So for I is equal to 0, I less than n, I plus plus. Next display the elements printf. So this is nothing but printf percentage this slash t comma A of 5. Slash t will displace tab space. So in this way we can insert an element into the array at end. In this class we are going to discuss about a C program to delete an element from the array at begin position. So C program to delete an element from the array at begin position. So we have to delete an element from the array at begin position. So before writing the program, let us solve the problem first. Let the size of the array is 5. So let n is equal to 5. So we can have 5 elements from A of 0 to A of 4, because the index value starts from A of 0 and continues up to n minus 1. So A of 0, A of 1, A of 2, A of 3, A of 4. Let the elements of the array are 10, 20, 30, 40, 50. So in this example, our target is we have to delete an element from the array at begin position. So we have to delete this element from the array. So after deleting this element from the array, so the output here is 10, 20, here we are deleting the element 10. So after deleting 10, the output is 20, 30, 40 and 50. Here the logic is very simple. Initially the size of the array is 5. After decrementation, the size will becomes 4 only. So we have to perform an operation called n minus minus. So n minus minus will decrements n value. So initially what is n value? 5. After decrementation n becomes 4. So now we have 4 elements from A of 0 to A of 3. So the first element is A of 0. Second element is A of 1. Next element A of 2. Next element A of 3. Here the logic is very simple. We have to store A of 1 in A of 0. So now A of 0 becomes 20. Here deletion means not the physical deletion. We have to place other value in that position. So we are placing 20 in A of 0. So 10 will be erased now. In place of 10, 20 will be stored. Next, store A of 2 in A of 1. So store 30 here. Next, store A of 3 in A of 2. So store 40 here. Next, store A of 4 here. So after deleting the element at begin position, what is the output here? We are deleting the first element from the array. So the output is remaining elements. So 20, 30, 40, 50. So before writing the logic, let us read all the elements. So the first statement here is hash include stdio.h. Why? Because we are using printf and scanf functions in this program. We need to use those two functions. So C program execution starts from main function. So here the input variables are n, size of the array. Next, an array elements. Next, to perform operations on the for loop, Let us declare a variable called I. So int n comma, let the size of the array is 10. So I have 10 comma I. So printf. So here the first statement is enter size of the array. Enter size of the array. So size is denoted by n. So the next statement is scanf percentage d comma %n. So let n value is 5. Next we have to read array elements. So here the statement is printf enter array elements. Enter array elements. So here index value starts from 0 and continues up to n minus 1. 4. So for I is equal to 0, the condition is I less than or equal to n minus 1, or we can write it as I less than n. So I less than n, I plus plus. Next for reading, use scanf function. So scanf percentage d comma %a of I. So totally we have 5 elements, 10, 20, 30, 40 and 50. Here we are deleting an element from the array at begin position. So initially the size of the array is 5. After decrementation the size must becomes 4. So the first statement here is n minus minus. So what is n value now? Initially n is 5. So now n becomes 4. So how many assignments are needed here? So 1, 2, 3, 4 assignments. So what is the first assignment? A of 0 is equal to, we have to store a of 1 value in a of 0. So a of 0 is equal to a of 1. Second assignment, store a of 2 in a of 1. So a of 1 is equal to a of 2. Next assignment, a of 2 is equal to a of 3. Next assignment, a of 3 is equal to a of 4. So totally we have 4 assignments. So for that we have to write the logic here. So let's see the logic here. So for I is equal to, so what is the initial value of the I here? So let the initial value of the I is 1. So for I is equal to 1. So what is n value here? 4. So 1 is less than or equal to 4. So first initialization, 2 is less than or equal to 4, second initialization, 3 is less than or equal to 4, fourth initialization. So 4 is less than or equal to 4, fourth initialization. Or we can write it as I is equal to 0. If I is equal to 0, then the condition is I less than n. So 0 is less than 4, 1 is less than 4, 2 is less than 4 and 3 is less than 4. So it is our choice. So we can write any logic here. Let the initial value of the I is 0. So for I is equal to 0. So if I value is 0, then what is the condition? So I less than n. So 0 less than 4, first one. 1 less than 4, second one. 2 less than 4, third initialization. 3 less than 4, fourth initialization. So for I is equal to 0, I less than n, I plus plus. Next we have to write the body of the loop. So what is I value? 0. So a of I is equal to, so how to get 1 from 0? I plus 1. So here the body is a of I is equal to a of I plus 1. So let's check whether our logic is correct or not. So now what is n value? 4. So I is equal to 0. I less than n. So what is n value? 4. So 0 is less than 4. Condition is true. So body will be executed. So a of 0 is equal to a of 0 plus 1. So 0 plus 1 means 1. So a of 0 is equal to a of 1. So what is a of 1 value? 20. So 20 will be stored in a of 0. So first assignment is over. Next I plus plus. I becomes 1. So 1 is less than 4. Condition is true. So a of 1 is equal to a of 2. So a of 2 value will be stored in a of 1. So second assignment is over. I plus plus. I becomes 2. 2 is less than 4. Condition is true. So a of 2 is equal to a of 2 plus 1. 3. So a of 3 value will be stored in a of 2. So third assignment is also over. Next I plus plus 3. 3 is less than 4. Condition is true. So a of 3 is equal to a of 3 plus 1. 3 plus 1 means 4. So A of 3 is equal to A of 4. So A of 4 value will be stored in A of 3. So everything is over. So now we have to display the outputs. So printf after deletion, array elements are for I is equal to 0, I less than n. But what is n value now? 4. So I less than n, I plus plus, printf percentage d slash t comma a of I. So in this way, we can write a C program to delete an element from the array at beginning position. In this class, we are going to discuss about a C program to delete an element from the array at specified position. C program to delete an element from the array at specified position. So in this program, we have to delete an element from the array at specified position. So before writing the program, let us solve the problem first. Let the size of the array is 5. So totally we can have 5 elements in the array from A of 0 to A of 4. So A of 2, A of 3, A of 4. Let elements of the array are 10, 20, 30, 40 and 50. So in this example, our target is we have to delete an element from the array at specified position. So we require one more variable. Let that variable is position. Let the value of the position is 3. So in this example, so we have to delete the third position element from the array. So this is the first position. This is the second position. So we have to delete this element from the array. So here the logic is very simple. Initially the size of the array is 5. After decrementation, the size will becomes 4. So here the first operation which we have to perform is n minus minus. So now n contains 4. So if n value is 4, then we can have 4 elements in the array from A of 0 to A of 3. A of 0 to A of 3. Here we are deleting this element, the third position element. So there is no need to change the first 2 elements. So we have to keep the first 2 elements the same. So 10, 20 and place A of 3 in A of 2. So this is nothing but deletion here. We are not deleting physically the corresponding element. So in place of this 30, we are storing the next element. So what is A of 3 value here? 40. So store 40 in A of 2. Next, what is A of 4 value? 50. So store 50 in A of 3. So after deleting an element from the third position, the output is 10, 20, 40 and 50 here. So store A of 3 in A of 2. Store A of 4 in A of 3. So before discussing this logic, first let us perform the readings first. So after reading size, array elements, position, we will write the logic. So here the first statement is hash include stdio.h. Next statement, main function. So what are the input variables in this program? N, an array and position. So int n comma, let the size of the array is 10, A of 10 comma, pos comma. To perform operations on the for loop, let us use a variable called I. So first read size of the array. So printf enter size of the array, enter size of the array. So in this example, size of the array is denoted by n. So the next statement is scanf %d comma ampersand n. So what is n value? 5. Next read array elements. So printf enter array elements. Enter array elements. Here the index starts from 0 and continues up to n minus 1. So for I is equal to 0, I less than or equal to n minus 1 can be written as I less than n, I plus plus. The next statement is scanf %d comma ampersand af5. So array is also needed. So totally we have 5 elements in the array. So 10, 20, 30, 40 and 50. And the next input variable here is position. So printf enter the position at which the element is deleted. Enter the position at which the element is deleted. So the next statement here is scanf %d comma ampersand pos. So pos value here is 3. Next we have to write the logic. Initially the size of the array is 5, but after decrementation the size will become 4. So here the first statement here is n minus minus. So initially what is n value? 5. So now n becomes 4. So now we have to write the logic here. What is the position value here? 3. So the initial value of the I is, let it be pos. Next, what is the condition here? So how many assignments are needed here? 2 assignments. The first assignment is store af3 value in af2. So af2 is equal to af3. The next assignment is store af4 value in af3. So af3 is equal to af4. So totally we have 2 assignments. So what is the value of the I here? I is equal to pos. What is pos value? 3. But after decrementation, what is n value? 4. So here the condition should be 3 is less than or equal to 4. So 3 is less than or equal to 4. Condition is true. So first assignment will be done. Next to 4 is less than or equal to 4. Condition is true. Second assignment will be done. So here the condition is I is less than or equal to n, I plus plus. So what is the first statement here? af2 is equal to af3. But what is I value? 3. So how to get 2 from 3? So by subtracting 1. So here the body is a of I minus 1 is equal to a of I. So let us check whether our logic is correct or not. So n minus minus. So initially n is 5. So now n becomes 4. Next for I is equal to pos. So what is I value? 3. Because here pos value is 3. Next condition, I is less than or equal to n. 3 is less than or equal to 1. 3 is less than or equal to n. What is n value? 4. 3 is less than or equal to 4. Condition is true. So body will be executed. So here what is the body? What is I value here? 3. So 3 minus 1 means 2. So a of 2 is equal to a of 3. So store a of 3 value in a of 2. So first assignment is over. I plus plus. Now I becomes 4. So 4 is less than or equal to 4. Condition is true. So body will be executed. A of 4 minus 1. That is nothing but a of 3. A of 3 is equal to a of 4. So store a of 4 value in a of 3. I plus plus. Next I becomes 5. So 5 is less than or equal to 4. Condition is false. So our output is over here. So next we have to display the array elements. So printf after deletion array elements are for I is equal to 0, I less than n, I plus plus, printf %d /d comma a of 5. So in this way we can delete an element from the array yet specify. In this class we are going to discuss about a C program to delete an element from the array at end position. C program to delete an element from the array at end position. So we have to delete an element from the array at end position. So in this program, the input variables are the size of the array n and the array elements. So let the size of the array n is equal to 5. So we can have 5 elements from a of 0 to a of 4. So a of 0, a of 1, a of 2, a of 3 and a of 4. Let elements of the array are 10, 20, 30, 40, 50. So these are the input variables. So n size of the array and array elements. So in this program our aim is we have to delete an element from the array at n position. So here the logic is very simple. Instead of displaying the 5 elements, we have to display only 4 elements. So we have to start displaying the values from 0 index to 3rd index. So that is the logic here. So let us write the program. So hash include stdio.h, because we are using printf and scanf functions. Those two functions are available in stdio.h. Next, main function. So in this example, the input variables are n. Let the size of the array is maximum size of the array is 10. And to perform operations on the for loop, let us declare a variable called I. And the first input variable is n. So n means size of the array. So printf enter size of the array. So here size is denoted by n. So scanf %d comma %n. So in this example, let us assume that n value is 5. Next we have to read elements of the array. So printf enter elements of the array. So here we have to read more than one element. So we have to use a for loop. So for I is equal to here the index value starts from 0. So I is equal to 0 and continues up to n minus 1. So we can write the condition as I less than n, I plus plus. So scanf %d comma ampersand a of I. So here in place of less than I, we can write less than or equal to n minus 1 also, because we have to continue up to size minus 1, that is nothing but 4. Here there is no need of any logic. Simply we have to print the elements from 0 index to 3 index. So printf after deletion array elements are so for I is equal to 0. Here in place of less than n, we have to write less than n minus 1. So I less than n minus 1. So display the elements. So printf %d /t comma a of I. So /t will give tab space. So in this program, n value is 5. Let elements of the array are 10, 20, 30, 40 and 50. So after deletion, array elements are, so this message will be printed on the monitor. Next, for I is equal to 0, 0, I less than n minus 1. Here I value is 5. So 5 minus 1 means 4. So 0 is less than 4. Condition is true. So the body will be executed. A of 0 will be printed. So what is A of 0? 10. So this 10 will be printed, and after that slash t, some 3 to 4 spaces will be printed. Let us assume that the cursor is here now. I plus plus, now I becomes 1. So 1 is less than 4, condition is true. So A of 1 will be printed. So 20 will be printed. Let the cursor is here now. I plus plus, 2 is less than 4, condition is true. So A of 2 will be printed. So 30 will be printed. So let the cursor is here now. Next, 3 is less than 4, condition is true. So A of 3 will be printed. So now what will happen? This 40 will be printed. Next, I plus plus. Now here the cursor is here after printing 40. So I plus plus 4. So 4 is less than 4, condition is false. So the control comes out from the for loop. So after deleting the last element, the array elements are 10, 20, 30 and 40. So in this way, we can delete an element from the array at end position. In this class, we are going to discuss about a C program to update an array element at a specified position. C program to update an array element at a specified position. So in this program, we have to update an array element at a specified position. So in this program, the input variables are the size of the array and elements of the array and position value as well as element value. So the first input variable is n. So n means size of the array. So let elements of the array are 10, 20, 30, 40, 50. So A of 0, A of 1, A of 2, A of 3, A of 4. Let elements are 10, 20, 30, 40, 50. So in this program, we have to update an array element at a specified position. So we need two more variables. The next variable is position. So let position value is 3. Next element value. Let element value is 333. So we have to update an element at third position. So A of 0 means first position. A of 1 means second position. A of 2 means third position. So this A of 2, this third position is replaced with 333. So we have to replace this 30 with 333. So this is the aim of this program. So now let's write the program. Hash include stdio.h. Why? Because we are using printf and scanf functions. Those two functions are available in stdio.h. Next, main function. Next, in this example, the input variables are n, size of the array. Let the maximum size of the array is 10, and we require two more input variables. POS stands for position, ELE stands for element. So we have four input variables: size of the array elements, position and element. So at which position we have to update the array element. So first read size of the array. So printf enter size of the array. Enter size of the array. So size of the array is denoted by n. So scanf %d comma %n. So in this example, let us assume that n value is 5. Next we have to read the array elements. So printf enter array elements. So here index value starts from 0 and continues up to n minus 1. So for I is equal to 0, so I less than or equal to n minus 1. So that can also be written as I less than n. Next I plus plus scanf percentage d comma ampersand a of I. So next we have to enter the array elements. So here the size of the array is 5. So we entered totally 5 elements. So 10, 20, 30, 40 and 50 are nothing but the elements of the array. Next we have to read position as well as element. So next one, printf enter the position at which the element is updated. So scanf percentage d comma, so position is denoted by POS, so ampersand POS. So in this example, let us assume that POS value is 3. Next we have to read element. So printf enter element, enter the element to be updated. So scanf percentage d comma ampersand, so element is denoted by EN. So in this example, what is the position value? 3. But we have to update yet a of 2 position. So how to get 2 from 3? So that is nothing but 3 minus 1. So what is 3 value? Position value. So here the logic is very simple. So there is only one statement. A of POS minus 1 is equal to ELE. A of POS minus 1 is equal to ELE. So what is the position here? 3. So 3 minus 1 will gives 2. So A of 2 is equal to ELE. So what is ELE? 333. So 333 will be stored at A of 2. So now display the elements. So printf after updation, array elements are for I is equal to 0, I less than n, I plus plus, printf percentage d slash d comma a of I. So after updation, array elements are, what is the output now? 10, 20, 333, 40 and 50. So in this way we can update an array element at a specified. In this class we are going to discuss about what is static memory allocation and what are the drawbacks of static memory allocation. So static memory allocation, the memory which is allocated during compilation time is known as static memory allocation. So static memory allocation means the memory which is allocated during compilation time, the memory which is allocated during compilation time. Let's see the drawbacks of static memory allocation. Drawbacks of static memory allocation are drawbacks of arrays. Why? Because arrays uses static memory allocation. Drawbacks of arrays. In advance, regarding size of the array. If you want to use 5 elements, then we need to specify the size of the array as 5. If we want to use 20 elements, then we have to specify the size of the array as 20. So we must know in advance regarding how many elements we have to store in the array. The second drawback here is once memory is allocated, then it's not possible to change size of the memory. So let us assume that we declared array as int a of 10. Let we are using 32-bit compiler. In a 32-bit compiler, the size of the integer is 2 bytes. So 2 into 10 means 20 bytes. So 20 bytes of memory will be allocated for A. So throughout the program, the size of the A is 20 bytes only. So it's not possible to change the size of the A. And the third drawback of array is if more memory is allocated, than required, then memory is wasted. We declared the array size as A of 10. Then 20 bytes of memory will be allocated for A. Let us assume that we use only 5 elements in the array. Then what will happen? The remaining 5 elements memory will be wasted. That means 10 bytes of memory will be wasted. So this is the drawback of array. If more memory is allocated than required, then memory is unnecessarily wasted. And the next drawback is if less memory is allocated, than required, then we can't perform possible operations. We declare size of the array as 10, but I want to use 20 elements in the array. Is it possible? It's not possible. Why? Because we declared size of the array as 10. So throughout the program, we can use only 10 elements only. But in this program, our target is we would like to use 20 elements. It's not possible. So we can't perform all the operations in effective manner. So this is one more problem with arrays. And another drawback with array is insertion operations are very time consuming. Insertion operations are time consuming. So let we have 5 elements in the array. So 0th element, 1, 2, 3, 4 elements. Let the elements are 10, 20, 30, 40, 50. And I want to insert an element called 100 at beginning position. Then in this situation, what we have to do is we have to move all the elements one position to the right. And store the element here. So this is the problem here. If you want to insert an element at the beginning position, then we have to shift all the elements one position to the right in order to store new element at beginning. Let us assume that the array contains 10,000 elements. And in that problem, if you want to insert an element at the beginning position, then we have to shift all the 10,000 elements one position to the right. So we can say that it is very time consuming process. It is very expensive process. And one more drawback is deletion operations are also time consuming. Deletion operations are also time consuming. Let us assume that we have 5 elements in the array: 0, 1, 2, 3, 4, 10, 20, 30, 40, 50. So in this example, our target is we want to delete an element from the array at beginning position. So what we have to do is we have to move all the elements from the index position 1 to n-1. one position to its left. So 20, 30, 40 and 50. Let the array contains 10,000 elements and we want to delete an element from the array at beginning position. Then what we have to do? We have to move 9,999 elements one position to the left. So it is very time consuming process. Why? Because we have to move so many elements one position to the left. So these are the various problems with arrays. We can overcome all these problems with the help of pointers or dynamic. Now let's see about performance analysis of an algorithm. We can analyze the performance of an algorithm by using two ways. First one is time complexity, second one is space complexity. So in order to analyze the performance of an algorithm, we use time complexity as well as space complexity. So first let's see about time complexity. First let's see the definition of time complexity. The amount of time that an algorithm requires for its execution is known as time complexity. So how much time that an algorithm requires for its execution is nothing but time complexity. There are mainly three types of time complexities are available. The first one is best case time complexity. Second one is worst case time complexity. Third one is average case time complexity. So we have three types of time complexities: best case, worst case, average case. Now let's see about best case time complexity. If an algorithm requires minimum amount of time, for its execution, then it is known as best case time complexity. So best case means algorithm requires minimum amount of time for its execution. Now let's see what is worst case time complexity. If an algorithm requires maximum amount of time, for its execution, then it is known as worst case time complexity. Now let's see what is average case time complexity. If an algorithm requires average amount of time, for its execution, then it is called as worst case time complexity. Now let's see an example for best case, worst case and average case. Before that, let's see what is linear search. So linear search means searching the elements of the list one by one until the key element is found or the array is completely exhausted. The array is completed. Let the elements of the list are some 10, 20, 30, 40, 50, whereas the key element is 40. So first we have to compare 10 with 40. So not equal. So compare 20 with 40. Not equal. So compare 30 with 40. Not equal. Next to compare 40 with 40. Equal. So we can say that the key element is found. So these are nothing but elements of the array or elements of the list. So this is nothing but key element. So compare key element with elements of the array one by one until the key element is found or the array is exhausted, the array is completed. So let the key element here is 100. So 10 100 not equal, 20 100 not equal, 30 100 not equal, 40 100 not equal, 50 100 not equal. Array is exhausted, array is completed. So we can say that here the key element is not found. So while searching an element using linear search, if the key element found at first position, let the key element is 10. So compare 10 with 10, both are equal. So this is nothing but best case. So while searching an element using linear search. If the key element found at first position, then it is called as best case time complexity. Why? Because what is best case time complexity? Algorithm requires minimum amount of time for its execution. So here we need only 1 unit of time for comparing the element. Now let's see an example for worst case time complexity. While searching an element using linear search, if the key element requires maximum amount of time, okay, that means if the key element found at last position, while searching an element using linear search, if the key element found at last position, then it is called as worst case time complexity. Why? Because worst case means algorithm requires maximum amount of time for its execution. So here what is the maximum amount of time? 5 units of time. So 10:50 not equal, 20:50 not equal, 30:50 not equal, 40:50 not equal, 50:50. So they are equal. So we can say that this is the best example for worst case. So what is the best example for best case? If the key element found at first position, then it is best case. What is worst case? If the key element found at last position, then it is worst case. Next, the average case means if the key element found at some second place or third place or fourth place, then we can say that it is some average case time complexity. Okay. So this is about different types of time complexities. So best case, what is best case time complexity? While searching an element using linear search, if the key element found at first position, then it is best case. If the key element found at last position, then it is worst case. If the key element found at some middle position, it may be some second position or third position or fourth position, then it is nothing but average case time complexity. So best case means algorithm requires minimum time for its execution. Worst case means algorithm requires maximum time for its execution. Average case means algorithm requires average amount of time for its execution. In order to calculate time complexity, we have two approaches. The first approach is frequency count or step count. So there are two approaches in order to calculate time complexity. The first one is frequency count or step count, whereas the second approach is asymptotic notations. The second approach is asymptotic notations. So we can calculate time complexity using two approaches. First one, frequency count or step count. Second one, asymptotic notations. We will discuss about frequency count and asymptotic notations in the next videos. Okay. Now let's see what is space complexity. What is time complexity? The amount of time that an algorithm requires for its execution. So whereas space complexity means in place of time we need to write space. So the amount of space that an algorithm requires for its execution is known as space complexity. We will discuss how to calculate space complexity in frequency count or step count approaches. So this is about performance analysis of an algorithm. So we can analyze performance of an algorithm using time complexity as well as space complexity. Again, we can calculate time complexity using two approaches: frequency count or step count and asymptotic notations. So we will discuss about frequency count and asymptotic notations in the next videos. Okay. Now let's see about frequency count or step count. In order to calculate the time complexity, we use frequency count or step count. We know what is time complexity. The amount of time that an algorithm requires for its execution is known as time complexity. We can calculate time complexity using two approaches. The first approach is frequency count. The second approach is asymptotic notations. In this video, we will discuss about frequency count. In the next video, we will see about asymptotic notations. Now let's see what is a frequency count. It specifies the number of times a statement is to be executed. Okay. So how many times the corresponding statement is executed. So that is nothing but frequency count. Here we can give the count value depends upon the statement. Here we have four rules. For comments and declarations, step count is 0. because we know that comments are not executed. Only for understanding purpose we use comments. In declarations also not necessary while writing the program, while writing the algorithm. So declaration of variables are needed only while writing the program. So in algorithm there is no need of any declaration. So that's why for comments and declarations the step count value is 0. Whereas for return statement and the assignment statement the step count is 1. So by using return statement we can return a value. Assignment statement in order to assign a right hand side value to left hand side variable. So for return statement and assignment statement the step count is 1. Next one, ignore lower order exponents when higher order exponents are present. So let the time complexity of the algorithm is like this: 3n power 4 plus 4n cube plus 10n square plus n plus 100. Now we have to consider only higher order exponent and ignore lower order exponents. Okay, so we need to consider only n power 4, 3n power 4. We have to ignore all these lower order exponents. And the last one is ignore constant multipliers. Ignore constant multipliers. Here the multiplier is 3, so we have to ignore this 3. So the time complexity of this algorithm will becomes big order of n power 4. So this is pronounced as order, big O. Okay, so order of n power 4. So how to pronounce this one? O means order of. Okay, order of. So let the time complexity of the algorithm is like this: 10n power 8. So here we have only one term. So the time complexity will become order of n power 8. Order of n power 8. Because here there are no other exponents we have. So these are the 4 rules here. So what is the first rule? For comments and declarations the step count is 0. Second rule, for return statement and assignment statement step count is 1. Third rule, we have to ignore lower order exponents when higher order exponents are present. And the last rule is ignore constant multiplier. So let us calculate time complexity of this algorithm. So S is equal to 0. So this is nothing but assignment statement. For assignment statement step count is 1. Next, for loop. So how many times this condition will be evaluated? Let n is equal to 3. Let n is equal to 3. So what is the initial value of 0? 0. What is the initial value of I? 0. So 0 is less than, what is n? 3. So 0 is less than 3. So one time condition is checked. Next I becomes 1. 1 less than 3. So 2 times condition is checked. Next I becomes 2. 2 is less than 3. So 3 times condition is checked. Next I becomes 3. 3 is less than 3. Condition is false. But this time also the condition is checked. So how many times the condition is checked here? 4. 4 is nothing but n plus 1. 4 is nothing but n plus 1. Why? Because what is n value? 3. So 3 plus 1 is nothing but 4. So here this condition will be checked for n plus 1 times. Okay. Next, how many times this body will be executed? How many times? N is equal to 3. So only 3 times the body will be executed. So whenever n becomes 3, 3 less than 3, condition is false. So control comes out from the loop. So the body will be executed only n times. Next, this is nothing but return statement. So for return statement, the step count is 1. For assignment and return statement, step count is 1. So we have to add all these values. We have to add all these values. So 1 plus n plus 1 plus n plus 1. So n plus n means 2n. 2n plus, next 1 plus 1 plus 1. That is nothing but 3. So 2n plus 3. So here what is the higher order exponent? N. So what is the time complexity of this one? Order of n. Order of n. Okay. So likewise, let us calculate space complexity of this algorithm. So space complexity means the amount of space that an algorithm requires for its execution. So here, in order to calculate the space complexity, we need to calculate the space of each variable. Here what is A? A is an array. What is the size of the array? N. N elements. So A occupies n elements or n votes. N votes. Okay. Next, n. N is nothing but number of elements. It occupies only one element. It may be 1 or 2 or 3 or 5 or 100 like that. Next, S. S is also a normal variable. It also occupies only one element, one word. So N is over, A is over. Next we have I. I is also normal variable. It also occupies one word. So these are the variables here, A, N, S, 1. So we need to calculate all these, we need to add all these terms. So N plus 3. So the space complexity of this one is big O of N. Big O of N. Now let's see one more example. So now let's see this example. So now we have to calculate the time complexity and space complexity for this algorithm using frequency count or step count. So this is nothing but matrix addition algorithm. Here we have three matrices A, B and C. So this is nothing but a matrix. So we have row size as well as column size. So this is nothing but the code. So in C of, this is nothing but C matrix. So for I is equal to 0, I less than n, I plus plus. For j is equal to 0, j less than n, j plus plus. C of ij is equal to a of ij plus b of ij. So let n is equal to 3. So then how many elements we can have? So this is nothing but 3 by 3 matrix. So in 3 by 3 matrix we can have 3 rows as well as 3 columns. 3 rows and 3 columns. So totally the matrix contains 3 square elements, that is nothing but 9 elements. So let us calculate the time complexity. So how many times this for loop condition will be evaluated? So the for loop condition will be evaluated always n plus 1 times. And the body of the for loop will be executed n times. So this is nothing but the body of this for loop. So this will be executed n times as well as this will be executed for n times. Next, the outermost for loop is over. Next we have to calculate for innermost for loop. Okay. So how many times this will be executed? N times. Okay. N times. So now we have to consider this for loop. So how many times this condition will be evaluated? So we know that the condition will be evaluated always n plus 1 times. N plus 1 times. Next, how many times the body of this for loop will be evaluated? The body of the for loop is always evaluated for n times. Okay. So it is over. Now we have to add all these terms. Okay. So what is the first one? N plus 1. Next one, n into n plus 1. That is nothing but n square plus n. Next one, n into n. So n into n is nothing but n square. So n square plus n square, 2n square. Next n plus n, 2n plus 1. So we have to consider only higher order exponent. That is nothing but n square. And we need to ignore constant multiplier. So the time complexity of this algorithm is big O of n square. Now let us calculate the space complexity of the algorithm. So here what are the variables that we have? First A, next B, next C, next we have I, J. So what is the size of A? A size is 3 by 3, n by n. So n by n. So 3 into 3 means 9. So this is nothing but n square. Okay. Let the size of the matrix is 2. So 2 by 2. So 2 by 2 means 4. 4 is nothing but 2 square. So 2 square means n square. So the size of the B is n square. It occupies n square boards, n square elements. If n is 4, then the matrix totally contains 4 into 4. That is nothing but 16. 16 elements. So C n square. I and J are normal variables. So it occupies only one board size. Next one, after J we have n also. So n also occupies one board. So 1. So add all these terms. So n square plus n square plus n square means 3n square. Plus 1 plus 1 plus 1 means 3. So the space complexity is, we have to consider only higher order exponents, 3n square. And we need to ignore constant multipliers. Ignore 3. So the space complexity of this algorithm is big O of n square. So the time complexity is big O of n square as well as space complexity is big O of n square. Now let's see one more example. Now let us calculate the time complexity for this algorithm using frequency count or step count approaches. This is nothing but matrix multiplication algorithm. Here we have three matrices A, B and C. A, B and C. So these are nothing but some two-dimensional matrices. where the first dimension specifies row size and the second dimension specifies column size. So the size of the matrix is n here. So this is the code here. So let us calculate now. So for I is equal to 0, I less than n, I plus plus. So this is nothing but the outermost for loop. We know that the outermost for loop will always execute it for n plus 1 times, because the condition will be false whenever n value, whenever it becomes n. Next, the body of the for loop will be executed for n times. So all these statements are nothing but the body of this for loop. So this body will be executed for n times. So this for loop will be executed for n times. This statement will be executed for n times. This statement will be executed for n times. This one will be executed for n times. So this is over. Next we have to consider the innermost for loop. So now we have to calculate for this for loop. So we know that the for loop will always be checked for n plus 1 times. So n into n plus 1 times. Because whenever it becomes n, then only the condition will be false. Next, the body of this for loop, will be executed for n times. So into n, into n, into n. So this for loop is also over. Next we have to calculate for this innermost for loop. So this innermost for loop will be executed for, will be checked for how many times? N plus 1 times. Next, the body of this loop will be executed for n times. Next we have to add all these terms. So what is the first term? The first term is n plus 1. The second term is n square plus 1. N into n square plus n. Next one is n into n square. Next one n into n square. N square into n plus 1. So n square into n cube. N cube, n square into 1, n square. Next one, n cube. So we have to add all these terms. So n cube, so 2n cube. Next n squares, 1n square, 2n square, 3n square. 3n square plus n, so 2n plus constants 1. So while calculating the time complexity, we have to consider only higher order exponents. So we need to consider 2n cube only. Ignore all these exponents. And here while calculating the time complexity, we have to ignore constant multiplier. So ignore 2. So the time complexity of this algorithm is order of n cube. Order of n cube. Now let us calculate the space complexity for this algorithm. So what are the variables that we have? We have A, B, C. Next N, I, J, K. So what is the size of A? This is nothing but a matrix. If the size of the matrix is 3, then we can have 3 into 3. That is nothing but 9 elements. So 3 rows where each row contains 3 elements. So this is nothing but the size of A is n square, size of B n square, size of C n square. So n is nothing but a normal variable. It stores only one value. I normal variable, it stores only one value. J normal variable, it stores only one value. K normal variable, it stores only one value. So 3n square plus 4. So we have to consider only higher order exponents and ignore constant multiplier. So the space complexity of this algorithm is big O of n square. So in this way we can calculate time complexity using frequency count or step count. If you take this one, the time complexity is n cube, big O of order of n cube, whereas the space complexity is order of n square. So in order to calculate the time complexity, we have one more approach, that is asymptotic notations. We will discuss about asymptotic notations in the next video. Now let's see about asymptotic notations. Asymptotic notations are mainly useful to calculate time complexity of an algorithm. We know what is time complexity, the amount of time that an algorithm requires for its execution. By using asymptotic notations, we can calculate best case time complexity, worst case time complexity, and the average case time complexity of an algorithm. Best case time complexity means if an algorithm requires minimum time for its execution, then it is known as best case. Worst case means if an algorithm takes maximum time for its execution. Average case means if algorithm takes average time for its execution, then it is average case. So by using asymptotic notations, we can calculate best case time complexity, worst case time complexity, and average case time complexity of an algorithm. If we take linear search, if the key element found at first position, then it is called as best case because we need only one comparison. Whereas if the key element found at last position, then it is called as worst case time complexity. Why? Because we need n comparisons. Whereas if the key element found at some average locations, then it is nothing but average case time complexity. Okay. There are 5 types of asymptotic notations are available. First one is big O notation, represented by big O. Second one is big omega notation, represented by omega. This is nothing but some sigma. Next one is theta notation. Fourth one is little o notation, represented by little o. Next one is little omega notation. You can represent little omega like this, some W, some circle. Okay. So by using these 5 notations, we can calculate time complexity of an algorithm. Let's see the first approach. The first approach is big O notation. Big O notation. So first one, big O notation. Big O notation is represented by big O. Big O notation mainly represents upper bound of algorithm running time. The big O notation mainly represents upper bound of algorithms running time. Upper bound of algorithms running time. Algorithms runtime. Next one. By using big O notation, we can calculate maximum amount of time that an algorithm requires for its execution. Big O notation is useful in order to calculate maximum amount of time for its execution. Maximum amount of time is nothing but worst case. So big O notation is mainly useful in order to calculate worst case time complexity of an algorithm. So here we have 3 points. What is the first point? Big O notation represents upper bound of algorithms running time. And by using big O notation, we can calculate maximum amount of time that an algorithm requires for its execution. So by using big O notation, we can calculate worst case time complexity. Let's see the definition of big O notation. Definition of big O notation. Let f of n comma g of n be 2 non-negative functions. Non-negative means positive functions. Let f of n and g of n be 2 non-negative functions. Then f of n is equal to big O of g of n if there exist 2 positive constants. So these are positive constants c comma n naught such that f of n is less than or equal to c star g of n for all n is greater than n naught. Okay. So let's see the graphical representation of big O notation. Graphical representation of big O notation. Graphical representation of big O notation. So here we have a graph. So in this graph, x-axis specifies n. So n means number of elements. Y-axis represents t. So t means time here. Okay. So here what is the condition? F of n should be less than or equal to c star g of n if for all n is greater than n naught. So this is nothing but c star g of n. Here big O notation always represents upper bound of the algorithm's running time. It always represents upper bound. So this is nothing but f of n. So this is nothing but upper bound. This is nothing but upper bound. So big O notation always represents this upper bound. So this is nothing but n naught. So if n is greater than n naught, then we can say that f of n is less than or equal to c star g of n. So before that, it may be either less or greater than C star G of n. Whereas if n is greater than n naught, then f of n value should be less than or equal to C star G of n. Here this is known as upper bound. So this is nothing but graphical representation of the big O notation. Now let's see an example here. Let f of n is equal to 3n plus 2, g of n is equal to n. Then we have to prove f of n is equal to big O of g of n. F of n is equal to big O of g of n. So in order to prove f of n is equal to big O of g of n, we have to satisfy this condition. What is the condition here? F of n is less than or equal to C star g of n for all n is greater than n naught. Okay. If this condition is satisfied, then we can say that f of n is big O of g of n. Here what is f of n? 3n plus 2 is less than or equal to C star. What is g of n? N. Now here we need to assume some C value here. Okay. Here let n value is 1. So 3 plus 2 means 5. So 5 is less than or equal to 3. So n should be greater than 3 here. Let n is equal to 4. All these are some assumption values. Let n is equal to 4. Okay. So 3n plus 2 is less than or equal to what is C value here? Let us assume that C value is 4. Okay. Because here if you take n as 1, then 3 plus 2, 5. 5 is less than or equal to what is C value? 4. So 5 is less than or equal to 4. So let us assume that it is 4 here. If it is not satisfied, then we will assume some other value as C value. Okay. So 4 into n. So if you take n as 0, let n value is let n is represented by n naught. If you take n naught as 1, then 3 into 1. So 3 into 1, 3. So 3 plus 2, 5. So 5 is less than or equal to. So 4 into 1, 4. So this condition is false. If you take n as 2, then 3 into 2, 6. 6 plus 2, 8. 8 is less than or equal to 4 into 2, 8. So this condition is true. If you take n naught as 3, then 3 plus 3, 9. 9 plus 2, 11. 11 is less than or equal to 12. 11 is less than or equal to 12. This is true. So here what is n naught value? N naught value should be greater than 2. So n naught value should be greater than 2. Okay. So we can say that here this condition is true. F of n is less than or equal to C star g of n for all n is greater than what is n naught? N naught is 2. N naught is 2. Whereas what is C value? C value is 4. So this is about big O notation. Okay. Now let's see about the second notation. The second notation is big omega notation. Big omega notation. Big omega notation is represented with this symbol, some sigma. Big omega notation mainly represents lower bound of the algorithm's running time. So that means it mainly represents minimum amount of time that an algorithm requires for its execution. So by using big omega notation, we can calculate minimum amount of time that an algorithm requires for its execution. So minimum amount of time is nothing but best case time complexity. So here we have 3 points. What is the first point? Big omega notation always represents lower bound of the algorithm's running time. And the second point is by using big omega notation, we can calculate minimum amount of time that an algorithm requires for its execution. So minimum amount of time is nothing but we can calculate best case time complexity. Okay. Now let's see the definition for big omega notation. Let f of n and g of n be two non-negative functions. Then f of n is equal to big omega of g of n if there exist two positive constants c comma n naught such that f of n is greater than or equal to c star g of n for all n is greater than n naught. Now let's see the graphical representation of the big omega notation. So here also we can have x-axis as well as y-axis. X-axis represents number of elements, y-axis represents time. Okay. So this is nothing but c star g of n. Here what is the condition here? F of n is greater than c star g of n. F of n is greater than c star g of n. So if n is greater than n naught, if n is greater than n naught, then we can say that f of n is greater than c star g of n. C star g of n. So before that, f of n value may be less than c star g of n or greater than c star g of n. So this is here, what is this one? This is nothing but lower bound. Here we need to consider always this C star G of n. So this is nothing but lower bound. So that's why we can say that big omega notation represents lower bound of the algorithm's running time. Now let us take an example here. Example, f of n is equal to 3n plus 2, g of n is equal to n. Then we have to prove f of n as big omega of g of n. So in order to prove this one, we have to prove f of n is greater than or equal to C star g of n for all n is greater than n naught. Okay, for all n is greater than n naught. Let f of n is equal to 3n plus 2. Here what is f of n? 3n plus 2 is greater than or equal to C star g of n. So what is g of n? N. So C star n. So 3 plus 2, if you take n as 1, so 3 plus 2, 5. 5 is greater than 1. So this condition is always true. But what is C? It is a positive value. So the minimum positive value is 1. So let C is equal to 1. Okay. Let C is equal to 1. So 3n plus 2 is greater than or equal to 1 into n. Greater than or equal to 1 into n. Okay. So if you take n naught as 1, then so 3 into 1, 3. 3 plus 2, 5. 5 is greater than or equal to 1 into 1, 1, 2. If you take n naught as 2, 2. So 3 into 2. If you take n naught as 2, then 3 into 2, 6. 6 plus 2, 8. 8 is greater than or equal to 1 into 2, 2. So we can say that what is n naught value? It should be greater than or equal to 1. So we can say that what is n naught? N naught is greater than 1, greater than or equal to 1. So we can say that n is greater than 1. Okay. Whereas what is C value? C value is 1. So this is about big omega notation. Now let's say about the third one. The third one is theta notation. Theta notation. It is represented by some theta. It mainly represents average bound of algorithms running time. So average bound of algorithms running time. By using theta notation, we can calculate average amount of time that an algorithm requires for its execution. So by using theta notation, we can calculate average case time complexity. So here we have 3 points. The first point is it always represents average bound of the algorithm's running time. The second point is by using theta notation, we can calculate average amount of time that an algorithm requires for its execution. So we can calculate average case time complexity by using the theta notation. Now let's see the definition here. Let f of n and g of n be two non-negative functions. Then f of n is equal to theta of g of n. If there exist, here we need three positive constants. C1 comma C2 n naught such that C1 star g of n is less than or equal to f of n is less than or equal to C2 star g of n for all n is greater than n naught. So this is the definition here. Let f of n and g of n be two non-negative functions. Then f of n is equal to theta of g of n. If there exist three positive constants C1 comma C2 comma n naught such that C1 star g of n is less than or equal to f of n is less than or equal to C2 star g of n for all n is greater than n naught. Now let's see the graphical representation of the theta notation. Here also we have x-axis as well as y-axis. X-axis represents number of elements, y-axis represents time. Okay, so this is nothing but C star g of n, average bound. Here what is this is nothing but f of n here. Here C2 star g of n is greater than f of n. C2 star g of n is greater than f of n. So this is nothing but C2 star g of n. Whereas C1 star g of n is less than f of n. So this is nothing but C1 star g of n. So this is nothing but n naught. So it always represents average bound. So before this we have C1 star g of n. Above this we have C2 star g of n. Okay. Now let's see an example. Let f of n is equal to 3n plus 2. G of n is equal to n. So here we have to prove f of n as theta of g of n. So in order to prove this one, we have to satisfy the condition c1 star g of n is less than or equal to f of n is less than or equal to c2 star g of n. So already we calculated c1 and c2 in big O notation as well as in big omega notation. So what is big O notation? F of n is less than or equal to c star g of n. So in that example c is 4. So what is c1 here? F of n is less than or equal to c2 star g of n. So what is c2 here? c2 is nothing but 4. And big omega notation means f of n is greater than or equal to c star g of n. In that example, so what is c value? 1. Okay. So here c1 value is 1. Okay. So 1 into what is g of n? N. So 1 into n is less than or equal to 3n plus 2 is less than or equal to what is c2? 4 into what is g of n? N. So let n naught is equal to 1. Then 1 into 1, 1. 1 is less than or equal to 5 is less than or equal to 4. So 1 is less than 5, this condition is true. But 5 is less than 4, this condition is false. Let n naught is equal to 2. Then 2 is less than or equal to 3 into 2, 6. 8. 8 is less than or equal to 8. So 2 is less than 8, 8 less than 8. So both are true. 8 less than or equal to 8. Both are true. Let n naught is equal to 3. So 1 into 3, 3. So 3 into 3, 9. 9 plus 2, 11. Whereas 4 into 3, 12. So we can say that if n is greater than 2, then this is always true. So what is n naught? N naught should be greater than or equal to 2. Whereas c1 value is 1, c2 value is 4. So we can say that f of n is theta of g of n. So in this way we can calculate theta notation, average case time complexity. Now let's see the fourth approach. The fourth and fifth approaches are very simple. So the fourth one is little o notation. Little o notation is represented by small o. The definition is very simple here. Let f of n and g of n be two non-negative functions. Then f of n is equal to little o of g of n such that here the condition is limit n tends to infinity f of n by g of n is equal to 0. So this is the definition here. There is no need of any graphical representation and example. Okay, we need graphical representation and example only in big O, big omega notation as well as theta notation. So what is the definition for little o notation? Let f of n and g of n be two non-negative functions. Then f of n is equal to little o of g of n such that limit n tends to infinity f of n by g of n is equal to 0. Now let's see the last one. The last one is little omega notation. Little omega notation is represented by some w like this. Let's see the definition here. Let f of n and g of n be two non-negative functions. Then f of n is equal to little omega of g of n such that limit n tends to infinity g of n by f of n is equal to 0. Or limit n tends to infinity f of n by g of n is equal to infinity. Then f of n is equal to little omega of g of n such that limit n tends to infinity g of n by f of n is equal to 0 or limit n tends to infinity f of n by g of n is equal to infinity. So in this way we can use asymptotic notations in order to calculate time complexity of an algorithm. Now let's see about general rules or norms for calculating time complexity. So we know what is time complexity, the amount of time that an algorithm requires for its execution. In order to calculate the time complexity, we follow certain rules. We will discuss all these rules here. Here we have 4 rules. The first rule is nothing but loops. The second rule is nested loops. Third rule is consecutive statements. Fourth rule is if-else. So let's see the first rule. What is the first rule? Rule. If there is a loop, then how we will calculate the time complexity? So let's see the theory here. The running time of for loop is the running time of statements in the for loop. So if there is a loop, then the loop running time is nothing but the running time of the body of the loop, the running time of statements of the loop. So let us take this example. For I is equal to 0, I less than n, I plus plus, s is equal to s plus I. Let n is equal to 3. Then how many times this condition will be evaluated? Initial value of I is 0. So 0 is less than 3, 1 time. 1 is less than 3, 2 times. 2 is less than 3, 3 times. Next I becomes 3, 3 less than 3. So here also the condition will be evaluated. So if n is equal to 3, then 1, 2, 3, 4. If n is equal to 3, then 4 times the condition will be evaluated. Okay. So here, the condition will be evaluated for n plus 1 times. Okay. Next, how many times the body will be executed? So the body will be executed only n times. So 0 less than 3, 1 time body will be executed. 1 less than 3, 2 times body will be executed. 2 less than 3, 3 times body will be executed. Next I becomes 3, 3 is less than 3, condition false. So the body won't execute. So here the body will be executed for n times. So now we have to add all these values. So n plus 1 plus n, that is nothing but 2 power n plus 1. While calculating the time complexity, we have to take only highest coefficient and ignore the remaining coefficient values. Here we have only one coefficient, that is nothing but n power 1. Why? Because n power 1 is nothing but n only. Next, if the equation contains any constant multipliers, here we have constant multiplier, then we have to neglect, we have to reject that constant, we have to ignore that constant multiplier also. So the time complexity will become order of n. This can be pronounced as order of n, or we can call it as big O of n. So that is the theory we have written here. The running time of for loop is the running time of statements in the for loop. So what is the running time of statements in the for loop? N. So that is nothing but the time complexity here. Now let's see the next point. If there is a nested loop, so what is a nested loop? Writing one loop inside another loop is nothing but nested loop. So if there is more than one loop, then it can be called as nested loop. If there is a nested loop, then how we can calculate the time complexity? That we will discuss here. Rule 2 nested loops. The total running time of statements inside a group of nested loops is the product of sizes of all the loops. So if there are two loops, then let the size is n. So n into n is nothing but n square. So n square will becomes the time complexity. If there are 4 for loops, and let us assume that the size is n, then n into n into n into n, that is nothing but n power 4. Here we have how many for loops? We have 2 for loops. And what is the size here? N. So n into n means n square. So n square will become the time complexity here. So let's see whether that is correct or not. So how many times the condition will be evaluated? N plus 1 time the condition will be evaluated. Next, the body of the for loop will be executed for n times. So this is nothing but body of the for loop. So all these statements are executed for n times. So this statement will be executed for n times. This statement will be executed for n times. Next, this innermost for loop will be executed. So how many times here the condition will be evaluated? The condition is always evaluated for n plus 1 times. Next, how many times the body will be executed? So the body will be executed for n times. So if we add all these terms, then n square, it will become 2n square. Next, n plus n, 2n. Next, constant, we have only one constant, that is nothing but 1. So while calculating the time complexity, we have to ignore lower exponents. So this n will be ignored. So n square will be considered. Here we have a multiplier 2. We have to ignore this constant multiplier also. So the time complexity will become, so the time complexity is order of n square. So that is the theory we have written here. The total running time of statements inside a group of nested loops is the product of sizes of all the loops. So if there are 2 for loops, then n into n. So if we multiply n into n, then what is the time complexity? N square will become the time complexity. Okay. Next, rule 3. So rule 3 is about consecutive statements. If there are some consecutive statements, then the running time is the maximum one. The maximum one. So if there are two statements, then the maximum statement, the time complexity will become the time complexity of the entire function. So here we have two statements. So this is the first statement and this is the second statement. So already we calculated this statement time complexity, the first example. So what is the time complexity here? Order of n. Next, already we calculated second statement time complexity in the second example, second rule. What is the time complexity here? N squared. So n squared. So which statement has the highest time complexity? Second statement. So the second statement time complexity will become the time complexity of this function. Okay. So let us calculate one more time. So simply we have to write all the statements time complexity and add all those terms. So how many times the condition will be evaluated? N plus 1 times. So how many times this body will be executed? N time. Next, this is the second statement. So how many times this for loop condition will be checked? N plus 1 times. Next, how many times the body of the for loop will be executed? The body of the for loop is always executed for n times. Next, we have to consider this innermost for loop. So how many times the condition will be checked? N plus 1 times. Next, how many times this body will be executed? N times. So if we add all these equations, then 2n squared plus 2n plus 2n means 4n plus 1 plus 1 means 2. So we have to consider only highest exponent value, that is nothing but 2 power n squared, and we need to ignore the constant multiplier. So the time complexity will become order of n squared. Okay. So that is the third rule, consecutive statements. If there are two consecutive statements, then the maximum statement time complexity will become the time complexity of that entire code or snippet. Next, rule 4 is about if else. If condition, let us assume that the body of if is S1, else S2. So if this condition is true, then S1 will be executed. If this condition is false, then else block, that is nothing but S2 will be executed. Here also the running time is nothing but the maximum of S1 and S2. If S1 has maximum time complexity, then S1 will become the time complexity of this entire block. Suppose if S2 has maximum time complexity, then S2 will become S2 time complexity. It will become the time complexity of this entire code. Okay. Let us take an example here. If n is less than or equal to 0, then return n. Else, for I is equal to 0, I less than n, I plus plus. S is equal to S plus I, return S. So how many times this if body will be executed? One time. Next, how many times return statement will be executed? Return statement is always executed for one time. Okay. So here also if you take this else, let us assume that else is also executed for only one time. Okay. If or else are executed only one time. So how many times here the condition will be evaluated? N plus 1 times. The body n times. Return statement only one. Okay. Return statement step code value is 1 because return statement is executed only one time. So how many n's are there here? So 1n, 2n's, yeah, only 2n's. 2n plus how many constants? 1, 2, 3, 4 and 5. So we need to consider only highest exponent. So this one. So we need to ignore the constant multiplier. So the time complexity here becomes n, because n is nothing but the time complexity of this else block, whereas the time complexity of the if block is only 1. So else block has maximum time complexity. So the time complexity of this code will become order of n. So in this way we can calculate the time complexity of the algorithm with the help of these 4 rules. Rule 1 is about a simple loop, a single loop. Rule 2 is about nested loops. Rule 3 is about consecutive statements. Rule 4 is about if else statement. Now let's see about various types of computing times or typical growth rates. Here there are different types of computing times are available. So we know what is time complexity. Time complexity means the amount of time that an algorithm requires for its execution. Here there are different types of notations: big O, big omega, theta, little o and little theta notation. Here we are using big O notation, different types of big O notations, different types of computing types. The first one is big O of 1 or order of 1. It represents a constant computing time. So 1 means a constant. It may be 1 comparison or 2 comparison or 100 comparisons. It is a constant. So next one, order of n, big O of n. So n specifies linear computing time. So if n value is 5, then 5 comparisons will be needed, like that. Next, big O of n square, order of n square. So this can be pronounced as big O or order. So order of n square. So n square specifies quadratic computing time. Next one, n cube. So n cube specifies cubic computing time. Next, 2 power n, in anything power of n. It may be n power n or m power n or a power b or b power c. So it is nothing but exponential computing time. Next one, log n log n, log m. So these are nothing but some logarithmic computing time. Okay. So these are the various types of computing types that we have. So order of 1, order of n square, n cube, 2 power n, and log n log n, like that. Now let's see the relationship among all these computing types. So here the first column represents n. So let us assume that n values are 1, 2, 4, 8. So here we are taking 2 power values. So 2 power 0 means 1, 2 power 1 means 2, the power of 2. Next, 2 power 2 means 4, 2 power 3 means 8. So if you take the next value, then it becomes 2 power 4. So 2 power 4 means 16. Next, 2 power 5 means 32. Next, 2 power 6 means 64. So likewise we have to take. Why? Because here we need to calculate log n. Okay, we need to calculate log n. So that's why we have taken 2 power values. Why? Because here we know that the formula for log a base a is 1. Okay. Next, we need to calculate the first column represents n, second column represents n square, next column n cube, next column 2 power n, next column log n, and the last column is n log n. So let us calculate n square. So 1 square means 1, 2 square means 4, 4 square means 16, 8 square means 64. Next, let us calculate n cube. So 1 cube means 1, 2 cube means 8, 4 cube means 64, 8 cube means 512, 8 square means 64, 64 into that 8 is nothing but 512. Next, 2 power n, 2 power 1 means 2, 2 power 2 means 4, next 2 power 4 means 16, 2 power 8 means 256. Why? Because 2 power 4 means 16. So 16 square is nothing but 256. Next, log n. So log 1 means 0, because that is the formula for log 1. The value of log 1 is 0. Next, log 2. By default, the base value is 2. Log a base a is equal to 1. So log 2 base 2 will become 1. Okay. Next, log 4. Log 4 can be written as log 2 square. Log a power m can be written as m log a. So 2 log 2. By default, the base value is 2. So 2 into 1 means 2. 2 into 1 means 2. Next, log 8. So log 8 can be written as log 2 power 3. So that's why we have taken these values, 2 power values. It is very easy to calculate log. If you take 2 power, that n value, okay, 2 power 0, 2 power 1, like that. So log 2 power cube, 8 can be written as like this, okay. Log n, so log 8 means log 2 power 3. So log a power m means m log a, so 3 log 2. By default, the base is 2. So 3 into 1 means 3. Next, n log n. So 1 into 0, 0. 2 into 1, 2. 4 into 2, 8. 8 into 3, 24. Next, let us write the relationship among all these computing times. So we need to observe all the columns. So which column contains lesser values? Log n contains lesser values. Why? Because what is log n here? 0, 1, 2, 3. Okay. So we can say that order of log n, it contains lesser values. So order of log n is less than. So what is the next one? So if you consider n and n log n. So 1, 0. So 0 is lesser. Next to 2, 2. Both are same. Next 4, 8. So 4 is lesser. 8, 24. 8 is lesser. So between n and n log n, which column contains lesser values? N. So order of n is less than. So next one, If we consider n square and n log n, n square and n log n, so 1 0, it contains lesser value. 4 2, it contains lesser value. Next 16 8, it contains lesser value. Okay. Next 64 24, it contains lesser values. So log n log n contains lesser values. So order of n log n is less than. Next, n square is less than. Next, if we consider n cube and 2 power n, which column contains lesser values? 2 power n contains lesser values, less than. So what is the next one? Order of 2 power n is less than order of n cube. So this is the relationship among all these computing times. So order of n log n is the smallest one. Next, order of n is the next smallest one. N log n is the next smallest one. N square is the next smallest one. 2 power n is the next smallest one. N cube is the next smallest one. Okay. So we can say that order of log n will produces the best time complexity, whereas order of n cube will produces the worst case time complexity. So this is about various types of computing times or typical growth rates. Now let's see about how to calculate space complexity of an algorithm in data structure. Generally, we can analyze performance of an algorithm by using two ways. The first one, time complexity. The second one, space complexity. Already we have seen about time complexity. Now let's see about space complexity. Space complexity means the amount of space that an algorithm requires for its execution. So how much space that an algorithm requires for its execution is nothing but space complexity. Generally, we know that in order to solve any problem, we have to develop a program. But we can develop a program in n number of algorithms. Let us assume that we want to implement sorting algorithm. We want to implement a sorting program. So we can implement a sorting program by using various algorithms like bubble sort, selection sort, merge sort, quick sort, radix sort, shell sort. By using all these algorithms, we can develop the sorting program. So first we have to take all the algorithms and we need to calculate the space complexity for each and every algorithm. The algorithm which requires less space, so that algorithm will become the best algorithm. So we need to develop the program based on that algorithm. So that is the major advantage of the space complexity. So the definition for the space complexity is the amount of space that an algorithm requires for its execution. So as a user or as a developer, our target is our algorithm should contain less number of space. So that is our target. So first let's see the formula for calculating the space complexity. In order to calculate the space complexity, the formula is S of P is equal to C plus SP. Here S means space complexity, P stands for problem. So in order to calculate the space complexity for a given problem, this is the formula. S of P is equal to C. C means constant part. C means constant part. So constant part is nothing but this is independent part. So that means the constant part should not depend upon any variables present in the program. So constant part is nothing but generally some constants. In our program we use some constants. Int A is equal to 10, B is equal to 20, C is equal to 30, like that. So they are nothing but some constants. And this SP is nothing but instance characteristics. Instance characteristics. Instance part. Instance part. What is instant characteristic? Instant part. Instance part is nothing but dependent part. Dependent part. Dependent part is nothing but variable part. So here this SP is nothing but instance characteristic or dependent part or variable part. So that means here the instance characteristics variables depends upon some other variables. If you take the example of an array, the size of the array, here the array depends upon the size. Let name of the array is A of 10. Now A depends upon the size 10. So array is nothing but instance variable. So if the corresponding variable depends upon some other variables which are present in the program, then they are nothing but instance variables or dependent variables or variable part. Whereas C is nothing but constant part or independent part. This is nothing but fixed part. That means it doesn't depend upon any other variables. Now let's see two examples. For those two examples, let us calculate the space complexity. First, let's take an example for addition of three numbers. Addition of three numbers. Let's take the first example, example 1. So here we are developing an algorithm, not the program. Here we are calculating the space complexity for the algorithm. So which algorithm requires less space? So that algorithm should be written with the help of a program. So based on that algorithm, we will develop the program. So algorithm, here our target is we want to calculate sum. Let names of the variables are A comma B comma C. So here A, B, C are nothing but some variables. Let A value is 10, B value is 20, C is equal to A plus B. Okay. So in this way we can calculate the sum of two numbers. So like this we can calculate. So now here we have to calculate the space complexity by using this formula. S of P is equal to C plus SP. Here what is C? C means constant part. SP means what? Variable part, dependent part. Here A, B, C are nothing but constant variables. Here A doesn't depend upon any variable, B doesn't depend upon any variable, as well as C doesn't depend upon any variable. So these are nothing but constant part. So A, B, C comes under constant part only. So for A, how much memory we require? For B, how much memory we require? For C, how much memory we require? So let us assume that if we are using a 32-bit compiler, then the size of the integer is, let these are nothing but some integer values, okay? Then the size of the integer is 2 bytes. Whereas if the compiler size is 64 bits, then the size of the integer is 4 bits like that, okay? For that, for ambiguity, what we are taking is, we are taking this as one-time unit. So what is this one-time unit? One-time unit may be either 2 bytes or 4 bytes. If the compiler is 32 bits, then one-time unit means 2 bytes. Whereas if the compiler is 64 bits, then this one-time unit is nothing but 4 bytes like that. So C is equal to, so here what is the constant part? Totally 3 time units. So 3 plus, here there is no other variable for SP, okay? Why? Because there is no instance part here. So 3 plus 0. So that is nothing but 3 time units. This 3 is nothing but a constant part. So the space complexity for this algorithm is big O of 1. So 1 specifies that it is constant part. Some constants are needed here. 3 times. So if it is a 32-bit compiler, then 2 bytes. So 2 into 3 means 6 bytes will be occupied by the corresponding variables. Whereas if it is 4 byte, if the size of the integer is 4 bytes, so 4 into 3 means 12 bytes. So 12 bytes will be occupied by the corresponding variables of the program. So the space complexity is big O of 1. Now let's take another example, calculating sum of array elements. Now let us calculate sum of array elements. So algorithm sum of A comma N. Here A means array size, N means A means array name, whereas N means size of the array. So initially we have to take a variable called total. So total is equal to 0. Next for I is equal to 0 to N do. Sum is equal to, total is equal to total plus A of I. So simply we are calculating the space complexity for an array of n elements. Now let us calculate the space complexity. S of P is equal to C plus SP. Here what is the constant part here? Here n doesn't depend upon any variable, total doesn't depend upon any variable, as well as I doesn't depend upon any variable. So totally 3 variables are there, n, total, as well as I. So for storing this n we require one time unit, for storing total we require one time unit, for storing I we require one time unit. So the constant part is nothing but 3 time units. Next, what is SP here? SP means instance characteristics. Here A is nothing but dependent part. Why? Because the size of the A will depends upon the n. The size of the A will depends upon n. Suppose let us assume that n means 5. So n means 5. So then A will become what? This the size of the A will become 5 into n. Okay. Whereas if n is 3, then SP will become what? 3n like that. Okay. So the space complexity is equal to, what is the constant part here? Constant part means 3, whereas variable part is nothing but 5n. Okay. Here while calculating the space complexity, we have to consider only higher order exponent. Here the higher order exponent is n power 1. So 5n is nothing but the space complexity. We know that while calculating the space complexity, we have to ignore the multipliers. So this n, big O of n will become the space complexity for this algorithm. So we require big O of n here in order to store this program. So in this way we can calculate space complexity for an algorithm in data structures. Now let's see about linked list. We can define linked list as a collection of nodes which are not necessary to be stored in adjacent memory locations. So we can define a linked list as a collection of nodes which are not necessary to be stored in adjacent memory locations. So that means linked list is nothing but a collection of nodes. Let the first node is stored at some 1000 memory location. Then the second node may be stored at some 10 memory location or 100 memory location or 2000 memory location or 5000 memory location. So that means the second node may be stored at any other location. So that means in a linked list, the nodes need not to be stored in adjacent memory locations. If you take array or structure, then the elements of the array or the elements of the structure are to be stored in adjacent memory locations. If you take integer array, let the size of the integer is 2 bytes. If the first element is stored at 1000 memory location, then the next element will be stored at 1002, next element 1004, next element 1006. Likewise, all the elements of the array or structure are to be stored in adjacent memory locations. Whereas in linked list, the nodes need not be stored in adjacent memory locations. There are mainly 3 types of linked list are available. First one is single linked list, second one is circular linked list, third one is double linked list. Now currently we are discussing about the first one. What is the first one? Single linked list. So the definition of single linked list and linked list both are same only. So we can define single linked list as a collection of nodes which are not necessary to be stored in adjacent memory locations. Here each node mainly contains 2 fields. The first field is data field, whereas the second field is address field or next field or pointer field. So what is the first field? Data field. It contains data of the node. The data value may be either integer value or floating point value or some character, or it may be a string, or it may be some long integer, or combinations of all, or combinations of just 2 or more. Okay. Next one is address field. It contains address of the next node. So address field or next field or pointer field contains address of the next node. In a single linked list, the last node next field contains null value. Null indicates end of the linked list. Now let's see the diagrammatic representation of a single linked list. So let's see the diagrammatic representation. Diagrammatic representation of a single linked list. So diagrammatic representation of a single linked list. Here linked list is nothing but a collection of nodes. Let the list contains 3 nodes here. So this is the first node, and this is the second node, and this is the third node. So our list contains totally 3 nodes. And let the address of the first node is 1000, address of the second node is 2000, address of the third node is 3000. It may be any address here. Okay. Here we are assuming that These three nodes are stored at 1000, 2000 and 3000. Actually the addresses are nothing but internally they are nothing but hexadecimal values. We know that any hexadecimal number starts with 0x and after that it is a combination of digits from 0 to 9 and A to F. Okay, but for understanding purpose we are taking some numeric values. Okay, here these addresses are need not to be stored in adjacent memory locations. Here each node contains two fields. So this is the first field and this is the second field. So this is the first field and this is the second field. This is the first field and this is the second field. So what is the first field here? Data field. What is the data field here? It contains some value. It may be integer value, float value, or character, or a string, or some floating point value, or a long integer value, or combinations. It is our choice. Here let us assume that our list contains some integer values. So let the data of the first node is 10, let the data of the second node is 20, let the data of the third node is 30. Here what is the second field? Address field or next field or pointer field. Here address field contains address of the next node. So what is the address of the second node? 2000. So first node next field contains address of the second node. So if you store address of the second node in the first node next field, then a link will be established from first node to the second node. Next, second node next field contains address of the third node. Address of the third node is 3000. So 3000 will be stored here. Then a link will be established from second node to the third node. And the last node next field contains null. In a single linked list, the last node next field contains null. Null indicates end of the list. So this is nothing but our diagrammatic representation of the single linked list. Now let's see how we can represent the node. So node representation. Node representation. Here we have two different values. The first one is some data field and the second one is some address field. So if we want to store multiple data type elements, then we must use structure. So we know the definition for a structure. So struct space name of the structure. Let the name of the structure is node. So struct node within the curly braces. Here we have two members. The first member is integer value. So what is the field here? Data. So int data. Int data. Because it stores some integer values. And let's see what is the next field here. Here the next field contains address of the next node. But that node is also belonging to the same structure. So this is nothing but self-referential structure. Self-referential structure means a structure which contains a pointer to itself. So this structure contains a pointer 2000, but with the help of 2000 we are storing the address of the same structure. Okay. So here the syntax for self-referential structure is struct space the name of the structure node and field value. Here let us assume that the field value is next, star next. Why? Because we are storing address of the next node. In order to store address of a node, we need to use pointer. Pointer stores address of a variable. So struct node star next. Next we know that structure definition ends with semicolon. So this is the node representation. Okay. Next here we use different types of nodes. Mainly we use three nodes. The first node is star new. Second node is star head. Next node is star temp. So mainly we use in single linked list. Mainly we use three nodes: new node, head node, temp node. So all these nodes are nothing but some pointer variables. Here the structure variable may be ordinary variable or pointer variable. Okay. Here we must declare it as pointer variable. Okay. Why? Because it contains some addresses. And another advantage of the pointer variable is there is no need to declare the maximum size. Okay. We can use n number of nodes as we like. Okay. Here we are using new node for allocation of memory for a node. Head for head always points to the beginning of the list. Let we have three nodes. then head always points to the beginning of the node, beginning of the list. So this is nothing but our first node. So head always points to the first node. Next, temp for traversing. Traversing means visiting the nodes of the list. Okay. So we are using temp for traversing from one node to the another node. So mainly we are using 3 nodes here. Next here, let's see how we allocate the memory. So in order to allocate the memory, we are using a node called new. So here the syntax is new is equal to struct node star malloc of size of struct node. So in order to allocate memory for new, we are using this statement. So let us observe this statement. Here we are using malloc function. Malloc function is mainly useful for allocating the memory. The return type of the malloc function is void. So void means malloc function doesn't return any value. But here whenever we created a node, then we should return some address. The corresponding variable, the corresponding node should be stored at some address. So we need to perform the typecasting. Why? Because the corresponding node will be stored at some address. So we need to return that address. So this is nothing but typecasting. So struct node. So this is nothing but some pointer variable. Why? Because we know that pointer stores address of a node. Here there is some address here. So with the help of this we are storing this address. Okay. So this is nothing but typecasting statement. Next we are using malloc function in order to allocate memory for the node. Malloc of size of. There is no need of any space between size and of. It is a single word. Size of is an operator which is available in stdio header file. Size of allocates the size for the corresponding node. Size of struct node. So what are the members of the structure? Data. So for data some memory will be allocated, as well as for next some memory will be allocated. So in this way we can allocate the memory for new node. In this class, let's see 2 functions. The first one is create function and the second one is display function. In the upcoming classes we will see insertion, deletion, next sorting, reversing, merging, counting. All these functions will be discussed in the next videos. Now let's see the first function. The first function is create function. So by using create function we can create a linked list. We can create a linked list. So let's see the create function. So create function. So we use as create in order to create a single linked list. So linked list is nothing but a collection of nodes. So let's see the logic here. First we have to allocate memory for the node. In order to allocate memory for the node, we are using new. So first we allocate memory for the node. So for that purpose we are using new. So we allocate memory for new. So our node contains 2 fields. The first field is data field, and the second field is next field. Okay. So let the address of the node is 1000. So this is the first step. Allocate memory for the node. Then after that, store value in new node's data field. Why? Because we know that node contains 2 fields. The first field is data field, second field is next field. So we have to store value in new node's data field. So let the first node data value is 10. And the next step is store null in new node's next field. Why? Because initially the list is empty. We have only one node. So the last node next field contains null. Null indicates end of the linked list. Okay. So after storing the value in data field, immediately we have to store null in new node's next field. So this is the first step we have to do. So allocate memory for the node, store value in data field, next store null in new node's next field. And we have 2 cases here. The first case is we have to check whether the list is empty or not. If the list is empty, then what we have to do? And case 2 is If list is not empty, then what we have to do? So here we have two cases. When the list is empty, then what we have to do? Case 2 is, if the list is not empty, then what we have to do? So let's see the first case. If the list is empty, so when the list is empty, here already I said that we uses a node called head. If head points to the first node, then we can say that list is not empty, because list contains some elements, whereas here head is not available at the first node. Here we are declaring the structure, we are defining the structure on the top of the main function. So the initial value of the head is null, because we are declaring that as a global structure. If you declare some global structure variable, then the default initial value is null. Why? Because we have to use that structure throughout the program. In our program we may use some 10 functions. So in all the 10 functions we should use that structure. So here the default initial value for the head is null. If head is null, then we can say that the list is empty. The initial value of the head is null. So here head is null. So what we have to do now? We have to place head and temp at the first node. So place head and temp at the first node. So head is equal to 1000, temp is equal to 1000. New is also 1000. So this is the first step. So what is the first step? If the list is empty, then we have to place head and temp at the first node. That is nothing but new node. Head should always point to the first node only. That means here the address of the head is always 1000. Okay. Whereas temp for traversing from one node to the another node. So let us assume that we created one more node. So how to create a node? So in order to create a node, we use new. So this is nothing but new node. Let the address of the node is 2000. So what is the previous value of new? 1000. New means 1000. New arrow data means here the structure variable is pointer variable. So if the structure variable is pointer variable, then in order to access the member we use arrow operator. Arrow means minus greater than. So new arrow data will gives 10, whereas new arrow next will gives null. Okay. So if you store initially, let a value is 10. Next let a value is 20. So what is the value of a now? 20. So 10 will be erased and 20 will be stored. Initially what is new? Initially new is 1000. Now what is new? 2000. So what will happen now? 1000 will be erased and 2000 will be stored here. So here now new will be at 2000 memory location. So here we have two fields, data field, next field. So after creating a node, what we have to do? The first step is we have to store value in the data field, and the second step is we have to store null in new node's next field. Let the value of the node is 20. Okay. Next, and after that we have to place null here. Next we have two cases here after creating the node. The first case is if the list is empty. The second case is if the list is not empty. So when we can say that the list is empty? If head is equal to null, then we can say that list is empty. If head is not equals to null, then we can say that the list is not empty. Now what is head value? 1000. So we can say that list is not empty. So if the list is not empty, then we have to do two things. The first one is store address of the second node in this node's next field. Okay. So what is the address of the second node? 2000. So we have to store 2000 here. If we store 2000 here, then a link will be established from first node to the second node. And next, what is the current node now? The current node is second node, but we should not change head. Head always points to the temp. So we have to move temp at this 2000 location. So likewise we have to perform the operation. Now let's see the code here. So what is the first code here? We are implementing create function. Okay. Here let us use do while. So do. So we can enter as many nodes as we want, as long as we press while. So if you press other than while, then the control comes out from the do while loop. Okay. So first what we have to do, we have to allocate memory for a node. So in order to allocate the memory here, what is the structure we are using? Struct node, and this structure contains two fields. The first field is data field, int data, and the next one is self-referential structure. So struct node star next. Data field stores value of the node, next field stores address of the node. And how many nodes we need to declare? 3 nodes. First node star new, second node star head, next node star temp. So new for allocating memory. Head always points to the first node. Let the list contains 100 nodes, then head points to the first node. Temp for traversing from one node to the another node. Here if it is a pointer variable, then we have to explicitly allocate the memory for the corresponding node. So in order to allocate memory for a pointer variable, we use dynamic memory allocation functions, malloc and calloc functions. Okay. So do first allocate the memory. So new is equal to, here we need to perform the typecasting. So what is the name of the node? Struct node asterisk, next malloc of, we are using malloc function, malloc of. So the initial values of all these are null. Why? Because we need to declare this structure on top of the main function. If it define on top of the main function, then the default initial values are some zeros, whereas if it declare inside a function, inside a main function or inside a user defined function, then the default values are some garbage values. Malloc of, here we have to use size of operator, size of, next struct node, next first we need to use this right parenthesis. So this right parenthesis is for this left parenthesis, next use this right parenthesis. So this right parenthesis is for this left parenthesis, next semicolon. So here we are using this for typecasting purpose. Why? Because malloc function return type is void, it doesn't return any value, but new node contains, new node should be stored at some address. So we need some typecasting here. Malloc of, here we have to allocate the memory. So we need to know the size of the node, the size of the structure. For that purpose we are using size of operator. No need of any space between size and of. Size of is an operator which is available in stdio. It gives the total size of the corresponding node of struct node. Okay. So whenever the statement is executed, then what will happen? Memory will be allocated for the node. Memory will be allocated for the node. So what is the name of the node? New is the name of the node. Next it contains two fields. Next let address here is 1000. Okay. Address here is 1000. So new is the name of the node. Next, here we have two fields, data field and next field. Let the address here is 1000. Okay. Next we need to read an integer value. So read an integer value. Printf enter a value. Printf, before that we need to declare a value. Printf enter a value. Enter a value. Next scan of percentage d comma ampersand value. So let the value here is 10. So then after that what we have to do? We have to store this value in new nodes data field. So we can write it as new arrow means minus greater than new arrow data is equal to value. If the structure variable is a pointer variable, then we have to use arrow operator. So what is the value here? 10. So 10 will be stored here. Then after that what we have to do? We have to store null in new nodes next field. So what is the statement here? New arrow next is equal to null. New arrow next is equal to null. We have to write null in uppercase letters. Why? Because it is a keyword. So null. Null indicates that there is no value. Here it indicates end of the list. Okay. So creation of the node is over. Next we have two cases. Case 1, if the list is empty. Case 2, if the list is not empty. So when we can say that the list is empty, if head is equal to null, then we can say that the list is empty. If head is equal to null, then we have to place head and temp at new locations. So here the condition is, if head double is equal to null, the initial value of the head is null, then place head and temp at new location. So head is equal to new, temp is equal to new. Head is equal to new, temp is equal to new. Initially head contains null. Null double is equal to null. Condition is true. So head is equal to new. What is new? 1000. So head will be placed at 1000 memory locations. Next, temp is equal to new. So what is the use of is equal to operator? It assigns right hand side value to left hand side variable. What is right hand side value? New. So what is new? New means 1000. New arrow data means 10. New arrow next means null. So new means address of the node, 1000. So 1000. So temp will be stored at 1000 memory location. So this is the first case. Next, the second case. So when the second case is executed, when the else block will be executed, if the list is not empty, so let us assume that we created one more node. So how to create a node? We have to use new. So it contains two fields. So new is equal to 1000. Let here the address is 2000. New is equal to 1000. New is equal to 2000. So what will happen? So this 1000 will be erased and new will be at 2000 memory location. So a is equal to 10. A is equal to 20. So first a will become 10. Next a is equal to 20. So 10 will be erased and 20 will be stored. Likewise here, new is equal to 1000. New is equal to 2000. So first 1000 will be stored. Next it will be erased and 2000 will be stored. Next, what we have to do? We have to read a value. Let the value here is 20. Next, new arrow data is equal to value. So store 20 here. Next, new arrow next is equal to null. Store null here. Next, what is the statement? Next, we have to check whether the list is empty or not. But here the list is not empty. Why? Because what is head here? Head means 1000. 1000 double is equal to null. 1000 double is equal to null. Condition is false. So we can say that list is not empty. So if the list is not empty, then else block will be executed. So if the list is not empty, then what we have to do is, here there are two steps. We have to store address of the second node in first node next field. The first node next field contains address of the second node. So what is the first node here? First node means head or temp. Here the first node is always temp only. Why? Because next, let us assume that we have two nodes. Next, we need to establish a link from second node to the third node. But head will always point to the first node only. So here, in order to establish the connections, we must use temp only. We must use temp only. So here, we need to store address of the new. So what is the address of new? 2000. So here we have to store 2000. If we store 2000 here, then a link will be established from first node to the second node like this. So how to write that statement? Yes, temp arrow next is equal to, temp arrow next is equal to, so temp arrow next is equal to new. So what is new? 2000. Next, we have to place temp at the second node. So how to place temp at the second node? Here temp means 1000. 1000 next means 2000. 1000 next means 2000. So we can write the statement as temp is equal to temp arrow next. Temp is equal to temp arrow next. So what is temp? 1000. 1000 next means 2000. So temp will be stored at 2000 now. Or we can write as the statement can be replaced with temp is equal to new. Temp is equal to new. Why? Because what is new? New is nothing but 2000. Okay. So temp will be placed at 2000. So it is our choice. So temp is equal to temp arrow next or temp is equal to new. Next, how long we have to repeat this do while loop? As long as we enter while. So write one more statement. So printf, do you want to add one more node? Do you want to add one more node? One more node to the list. So we need to enter either y or n. So y specifies yes, n specifies no. Next, Here it is better to use flush function. If we are working with some Turbo C software, then we have to use flush function. So flush of stdio. Next scanf %c comma %ch. Here %ch. This ch is nothing but a character variable. So here we have to declare char ch. Whereas this value is nothing but integer value. Okay. Whereas if we are working with Linux operating system, then there is no need of this flush function. But here we need to follow a condition as after this after this double quotations, we have to give one blank space. So if we are working with Turbo C, then we need to use flush function, and there is no need of any blank space here. Whereas if we are working with Linux operating system, then there is no need of flush of stdio function. Just after the double quotation, simply give one blank space. Okay. Next close this do loop. So y ch double is equal to y. Okay. So two nodes are created like this. Next, printf, do you want to add one more node to the list? Let us assume that we entered y. So y will be stored in ch. Y double is equal to y. Condition is true. So one more time the body will be executed. So let us establish one more connection here. So first memory will be allocated for the new node. So new. So let us assume that the address is 3000 here. Next value will be readed. Let the value is 30. Next store value in new node's data field. Next store null in new node's next field. Here head always points to the beginning node. Okay. Next temp points to the current node. Okay. So next what we have to do? We need to check whether the list is empty or not. If head double is equal to null. But what is head? 1000. 1000 double is equal to null. Condition is false. So else block will be executed. So we have to establish a link from second node to the third node. So what is the statement? Temp arrow next is equal to new. So what is new? 3000. So store 3000 in temp next field. So store 3000 here. So if we store 3000 here, then a link will be established from second node to the third node. Next temp is equal to temp arrow next. So what is temp? 2000. So 2000 next means 3000. So temp will be placed at 3000 location. So likewise we can create the linked list. Now let's see about display or traversing. So displaying or traversing means visiting or displaying the nodes of the linked list. Here let us assume that our list contains 3 nodes. Let the first node is stored at 1000 memory location. Second node is stored at 2000 memory location. Third node is stored at 3000 memory location. Here each node contains 2 fields. First field is data field, second field is next field. Let the first node data field is 10, let the second node value 20, let the third node value 30. Next, each node next field contains address of the next node. So what is the address of the second node? 2000. So 2000 will be stored in first node next field. If you store 2000 here, then a link will be established from first node to the second node. And the second node next field contains address of the third node. Address of the third node is 3000. If you store 3000 here, then a link will be established from second node to the third node. And the last node next field contains null. Null indicates end of the list. And head always points to the beginning of the node. Head always points to the beginning of the list. Beginning of the list. So what is the list starting node? This node. So head always points to the 1000 here. Okay. Next here, after displaying, we need to display output as 10 arrow, 20 arrow, 30 arrow, like that. So why? Because here we have to display only values. So what is the first node value? 10. Next we need to display some arrow in order to specify that there is a relationship between first node to the second node, or there is a link from first node to the second node. Next 20 arrow, 30 arrow, like that. Okay. Here the logic is very simple. Here for traversing we are using temp. So initially we have to place temp at head. So the first statement is temp is equal to head. Next we have to check whether this node next field is null or not. If this node next field is not null, then simply display the corresponding value and move the temp location one location forward. So likewise we have to continue the process. So let's see the logic here. So here the first statement is temp is equal to head. So what is head? 1000. So temp will be placed at 1000 memory location. Next we have to check whether it is null or not. Whether it is null or not. So here the condition is while temp not is equal to null or temp arrow next not is equal to null. So which condition we have to write? So let us write the condition as temp not is equal to null. Temp not is equal to null. So what is temp here? 1000. What is temp? Temp means 1000. Whereas temp arrow data means 10. Temp arrow next means 2000. So while temp not is equal to null. So what is temp? 1000. So 1000 is not is equal to null. Condition is true. So we have to display the value. So how to display the value? Printf. Here it is the integer value. So the control string is %d. And after that we have to display some arrow. Arrow means minus greater than, double quotations, comma. Here we have to display data here. So in order to display the data, the variable is temp arrow data. So while temp not is equal to null, 1000 is not equal to null. Yeah, condition is true. So body will be executed. So what is temp data? This is 1000. 1000 data means 10. So 10 arrow will be printed. Next, we have to place temp at 2000 memory location. So how to place temp at 2000 memory location? Temp is 1000. 1000 next is nothing but 2000. So we can write the statement as temp is equal to temp arrow next. Temp is equal to temp arrow next. So what is temp? 1000. 1000 next means 2000. So now temp will become 2000. So now temp will be placed at 2000 memory location. So once again the condition will be checked. While temp not equal to null. So what is temp? 2000. 2000 is not equal to null. Yeah, condition is true. So the body will be executed. So printf %d arrow comma temp arrow data. So 2000 data means 20. So 20 arrow will be printed. Next, temp is equal to temp arrow next. So temp means 2000. 2000 next means 3000. So temp will be placed at 3000 memory location. Next, once again condition will be checked. While temp not equal to null. So what is temp? 3000. So 3000 is not is equal to null. Yeah, condition is true. So printf %d arrow comma temp arrow data. So 3000 data means 30 arrow will be printed. Next, temp is equal to temp arrow next. So what is 3000 next? Null. So now temp will be placed at null location. Now temp is null. While temp not equal to null. While null not equal to null. Condition is false. So the control comes out from the while loop. So here the output is, this is the output. 10 arrow, 20 arrow, 30 arrow. So in this way we can display a single linked list values. In the last video we discussed about how to create a list as well as how to display a list. In this class let's see about how we can insert an element into the list at begin position, end position as well as at specified position. Let us assume that we have a single linked list with 3 nodes. So let it be the first node. We know that each node contains 2 fields. Let it is second node. Each node contains 2 fields. And let it is third node. Let the address of the first node is 1000. Address of the second node is 2000. Address of the third node is 3000. Let the first node data field contains 10. Second node data field contains 20. Third node data field contains 30. First node next field contains address of the second node. So that a link will be established from first node to the second node. Address of the second node contains, this address field of the second node contains address of the third node. So address of the third node is 3000. So that a link will be established from second node to the third node. So this is nothing but next field. Next field contains address of the next node. So second node address is available in first node next field. Likewise third node address is available in second node next field. The last node next field contains null. Here null indicates end of the linked list. And we have a node called head. Head always points to the beginning of the linked list. That means address of the first node is available in head. We should not change head. So always head points to the first node only. So let's see the first function. Here the first function is inserting an element into the list at begin position. Okay. So first we have to allocate the memory for the node. In order to allocate memory for the node, let us use new. So allocate memory for the node. So new. So we know that node contains two fields. So first allocate the memory for the node. Next we have to store some value in data field. Why? Because here we are inserting the element into the list at begin position. Okay. So first insert the value. So 10, 20, 30 is over. So let the value is 40. So insert 40 here. Next, so after inserting an element into the list at begin position, so this will become the first node. Okay. So that we need to establish a link from this node to the next node. So this node has to become second node after inserting this node. After inserting this node at begin position. So what is the address of the second node? 1000. So we have to store 1000 here. If we store 1000 here, then a link will be established from this node to this node. Then after that, after inserting at begin position, this node will become the first node. So we have to move head at this position. So we have to perform all these activities. Okay. So let us do all these activities. So here the diagram is very important. If we draw the diagram correctly, then automatically we can write the code. Okay. So first what we have to do? First we need to allocate memory for the node. First allocate memory for the node. So name of the node is new. Let the address is 1000, 2000, 3000 is over. Let the address is 4000 and it contains two fields. So first allocate the memory. So here we are writing the code for inserting the element at begin position. So first allocate the memory. So new is equal to, here we need to perform the typecasting. Struct to node star malloc of size of struct node. So for better understanding, it is better to refer the previous video. That is nothing but how to create a single linked list. So size of struct node. So in create function, all these steps are explained in detail. So node is created. Next we have to read a value. So printf enter a value. Enter a value. So next read the value. Scanf. Here the value is some integer type. So scanf %d comma ampersand value. So next what we have to do? We have to store value in data field. So this is nothing but data field. This is nothing but next field. Okay. So we can write the statement as new. Here the structure variable is pointer variable. So new arrow data is equal to value. So already in create function, the structure is defined like this. So struct to node. So node is name of the structure. It contains two fields. So int data, and the next field is next field. So struct to node star next, and we have some structure variables like star new, star head, and some star. So these nodes are sufficient here. If you want, we can also declare start. Okay. So new arrow data is equal to value. So let the value is 40. So 40 will be stored here. Then after that, what we have to do? We have to store address of the second node in new node's next field. So what is the address here? Head. So we need to store head in new next field. So we can write the statement as new arrow next is equal to head. New arrow next is equal to head. So what is head? 1000. So 1000 will be stored in new next field. So if we store 1000 here, then a link will be established from first node to the second node. Then after that, after inserting the node, what will happen? This node will become the first node. So we have to place head at this position. So we can write as head is equal to new. So what will happen now? What is new? 4000. So head will be placed at 4000 location. So in this way we can insert an element into the list at begin position. Now let's see how we can insert an element into the list at ending position. Now let's see how to insert an element into the list at end position. At end position, and let we have a linked list with 3 nodes. So it is first node, second node and third node. So first node address 1000, second node address 2000, third node address 3000. Let the first node data field is 10, second node data field 20, third node data field 30. So here address of the next field contains second node address. So if we store 2000 here, then a link will be established from first node to the second node. Next, second node next field contains address of the third node. So what is the address of the third node? 3000. So we have to store 3000 in second node next field. Next, last node next field contains null, and head always points to the beginning of the linked list. That is nothing but head contains address of the first node. So in this example, our target is we have to insert an element into the list at n position. So first we need to allocate memory for the node by using new. So it contains 2 fields. Let the address is 4000. So here the logic is very simple. We have to establish a connection from the last node of the list to new node. Okay. So that is the activity we have to do. So for that purpose, we need to place a variable at the last node. So for that purpose, we are using a variable called temp, a structure variable called temp. Here we are using temp for traversing from one node to the another node. Here the logic is very simple. In each node, we have to check whether its next field is null or not. If its next field is null, then we can say that it is the last node. Suppose if its next field is not equals to null, then we can say that there are some other nodes available here. Okay. So likewise we have to do the activities. So initially the temp is at 1000 location. So what is 1000 next? 2000. So 2000 is not equal to null. So condition is true. So we have to place temp at the next location. That is nothing but 2000. So again check whether this node next field is not equals to null or not. So 2000 next 3000. So 3000 is also not equals to null. So we can say that this is also not the last element of the list. So move temp at the next node. So what is 3000 next? Null. Null is equals to null. So we can say that this node is nothing but the last node of the linked list. So what we have to do now? We have to establish a connection from this node to the new node. Okay. So establish a connection here. So in order to establish the connection, what we have to do? We have to store new node address in temp next field. So store 4000 here. Then a link will be established from this node to this node. Next we have to store data here. Let the data is 40. Next we know that the last node next field always contains null. Next it is better to place temp at the last position. Okay. So in this way we can insert an element into the list at end position. Okay. So let us write the code now. Let us write the code. So what is this one? Null. So initially what we have to do? We have to allocate memory for the node. So before that it is better to place temp at head position. Head position. So the first statement is temp is equal to head. So what is head? 1000. So temp will be placed at 1000 location. So next allocate memory for the node. So for allocation of the memory we are using new. Let the address of the node is 4000. It contains 2 fields. So first allocate the memory. So new is equal to struct to node star. So this is nothing but typecasting. So struct to node star MLR of, here we are using size of operator in order to allocate memory for the node. Size of struct to node star. First right parenthesis for this left parenthesis, right parenthesis for this left parenthesis, semicolon. Okay. So next, what is the logic here? At each node we have to check whether its next field is null or not. So while temp arrow next not equal to null. So if its next field is not equal to null, then we can say that it is not the end of the node. If it is not the end of the node, if it is not the end of the list, then move temp to its next node. So temp is equal to temp arrow next. So let's check the condition now. While temp, so temp means 1000, 1000 next means 2000. So 2000 is not equal to null. 2000 is not equal to null. Condition is true. So body will be executed. So temp is equal to temp arrow next. So what is temp? 1000. 1000 next means 2000. So now the statement will become temp is equal to 2000. So temp will be placed at 2000 location now. So once again condition will be checked. While temp arrow next not equal to null. So temp means 2000. 2000 next means 3000. So 3000 is not equal to null. Yeah, condition is true. So body will be executed. So temp is equal to temp arrow next. So what is temp? 2000. So 2000 next means 3000. So temp will become 3000 now. So temp will be placed at 3000 memory location. Next, once again condition will be checked. While temp arrow next not equal to null. Temp means 3000. 3000 next means null. Null not equal to null. Condition is false. So we can say that this is the last node of the linked list. Okay. So allocation of the memory is over. Next, it is better to now we need to establish a connection from the last node of the list to the new node. Okay. So here we need to store 4000 here. If we store 4000 here, then a link will be established like this. So here we can write the statement as temp arrow next is equal to new. So then after that we need to read a value, printf, enter a value. It is our choice. If you want, we can read the value after allocation of the memory also. Printf, enter a value. Next, scanf, %d comma ampersand value. So let the value is 40. So we need to store 40 in new data field. So we can write the statement as new arrow data is equal to value. So what is value? 40. So 40 will be stored in new data. Next, the last node next field always contains null. So here the statement is new arrow next is equal to null. So we have to place null in new arrow next. Then it is better to move temp at new position, or otherwise also there is no problem. It is our choice. If you want, we can write the statement as temp is equal to new. If you don't place, then also there is no problem. Okay. So in this way we can insert an element into the list at n position. Now let's see how to insert an element into the list at specified position. Now let's see how to insert an element into the list at specified position. So already a list is created with 4 nodes. Here head points to the first node. In this example, let us assume that we want to insert an element into the list at a position called second position. Let the element here is 222 is the element that we want to insert. Okay. So at which position we want to insert the element? At second position. Let the element is 222 is the element. So let it is 0th position. Let it is first position. So it will becomes the second position. So after inserting 222 at second position, the output is 10, 20, 0th position, first position. Next to second position element 222, next to 30 and 40. So that is the output here. So what is the output? 10, 20, second position element 222, next remaining elements as it is. So that is the output here. Okay. So here we have to insert an element at second position. So let it is that position. So initially we have to allocate memory for the node. So let name of the node is new. Let the address of the node is 5000. We have to store some value here. Let the value is 50. Okay. Next here. So this is nothing but 0th position. This is nothing but first position. So we have to establish a link from first node to this node, as well as from this node to this node. So this is nothing but 0th position, this is nothing but first position, and this is nothing but second position element which we are inserting, and the remaining elements as it is. So this is nothing but first element, first link. Let it be second link. Okay. So we have to establish totally 2 links here. So initially we need to place a variable called template head position. Next we have to establish a link from position 1 to new node. So we need to place template 2000 location. So in order to place template 2000 location, we have to use a for loop. Okay. So we have to use a for loop. So how many iterations are needed here? Initially temp is a 1000 location, and we need to place template 2000 location. So we need to require only one iteration. So let the for loop is for I is equal to 0, I less than position I plus plus. If the condition is I less than position, then how many iterations will be there? 0 less than 2 first iteration, 1 less than 2 second iterations. So there will be 2 iterations. So it is better to write the condition as I is equal to 0, I less than position minus 1. Then 0 less than 2 minus 1. 2 minus 1 means 1. So 0 less than 1. So yeah, 1 iteration. Next 1 less than 1. Condition is false. Okay. So initially temp is at this location. If the body of the for, if the condition is true, then move temp at the next node. So now temp is at 2000 location. Here we have 2 links. This is the first link and this is the second link. So which link we have to establish first? Here, if we establish the first link first, then what will happen is this link will be broken. This link will be broken. So now it is not possible to establish a link from this node to this node. Okay. So here the point is, if we establish the first link first, then what will happen? This link will be broken. This link will be broken. So what is the statement there? Temp arrow next is equal to new. So if you write the statement as temp arrow next is equal to new, so what is new? 5000. So if you store 5000 here, then what will happen? Automatically this link will be broken. So it is not possible to store, it is not possible to get this 3000 address. So that's why we need to establish this second link first. We need to establish this second link first, and after that we need to establish the first link. So that is the code we have to write. So let us write the code here, so that if there are any doubts, then those doubts will be clarified. Okay. So what is the address here? So this address is nothing but 3000. Second node next field contains 3000. This is nothing but our new node. New node contains 2 fields. Let the address is 5000. Okay. So first we have to place temp at head position. So temp is equal to head. So temp is placed at 1000 location. Next here there are 2 inputs. First read those 2 inputs. Printf, enter the position at which element is inserted. So at which position we have to insert the element. So scanf %d comma ampersand pos. So what is the position we are assuming here? Second position. Next enter the element. So printf, enter the element to be inserted. Enter the element to be inserted. So scanf %d comma ampersand EL. So that the element is 222. Okay. So next what we have to do? So we have to write a for loop in order to place temp at position 1. Here our target is we want to insert the element at the second position. So if we want to place the element at second position, then we need to place the temp at position 1. So only one iteration is needed here. So the for loop can be written as for I is equal to 0, I less than POS minus 1, I plus plus. If the condition is true, then move temp one position to its right. So for I is equal to 0, so 0 is less than, what is position 2? 2 minus 1 means 1. So 0 is less than 1. Condition is true. So body will be executed. Temp is equal to temp arrow next. So temp means 1000. 1000 next means 2000. So temp will be placed at 2000 location. Next I plus plus. I will becomes 1. 1 less than 1. Condition is false. So the control comes out from the for loop. So next what we have to do? Okay. So which link we have to establish the first? We need to establish the second link first. Okay. Before that, it is better to store value in data field. Already value is readed. New arrow data is equal to, here we are taking value as some ELE, or if we want we can take it as some value. So new arrow data is equal to value. So what is the value here? 222 is the value. So insert the value here. So first we need to establish the second link first. So here what is the statement? New arrow next is equal to this 3000. How to get 3000? Temp means 2000. So 2000 next is nothing but 3000. So new arrow next is equal to temp arrow next. So what will happen now? So what is temp? 2000. So 2000 next means 3000. So 3000 will be stored in new next. Then a link will be established like this, and automatically this link will be broken. Then after that, what is the next statement? We have to establish a link from position 1 to this one. Okay. So what is the statement here? Temp arrow next is equal to new. So that 5000 will be stored here. So temp arrow next is equal to new. So what is new? 5000. So 5000 will be stored here. So that there is a link from this temp to this new node. So in this way we can insert an element into the list at begin position, specified position and end position. In the next video we will see how we can perform a deletion operation at begin position, specified position and end position. Now let's see about how to delete an element from the list at begin position, specified position and end position. So let we have a list with 4 nodes. Address of the first node 1000, address of the second node 2000, address of the third node 3000, address of the fourth node 4000. Let the first node data field contains 20, second node data field contains 20, third node data field 30, fourth node data field 40. Next, first node next field contains second node address, that is 2000. Second node next field contains third node address, that is 3000. Third node next field contains fourth node address, that is 4000. And the last node next field contains null. Here the node structure declaration is like this. Struct node. We have 2 fields, int data field, and the second field is struct node star next field. And mainly we are using 3 structure variables here. The first structure variable is star new. Here there is no need of new here. Next, star head. Head always points to the beginning of the list. New for memory allocation. Here there is no need of any memory allocation. Why? Because we are performing only deletion operation here. The next one is temp for traversing from one node to the another node. Okay. So it is better to refer my previous video, that is creating a single linked list. Then you will get the perfect knowledge about this program. Here it is very simple case here. Here our target is we have to delete an element from the list at begin position. So after deleting, what is the output here? After deleting, head, here we are using head here. Head always points to the beginning of the list here. Head always points to the beginning of the list. So after deleting this node, then head should point to the 2000 here. So initially let us place temp at head location and display the value. So temp is equal to head. Here we are deleting first node. So printf deleted node is %d comma. So delete the node. So temp arrow data. So what is temp arrow data? 10 will be printed now. So after performing the deletion, so what will happen? The first node will become this node. So we have to place head at this position. So how to place head at 2000? We know head means 1000. So 1000 next is nothing but 2000. So we can write as head is equal to head arrow next. Head is equal to head arrow next. So head means 1000. So 1000 next means 2000. So head will be placed at 2000 location. Okay. And now there is no need of this node. So it is better to place null here. So temp arrow next is equal to null. Temp arrow next is equal to null. So if you place null here, then this link will be broken. Then after that there is no need of this memory. So it is better to use free function. So whenever we use this free function, then the memory will be destroyed for this step, so that this memory will be used in order to store some other variable. So in this way we can delete an element from the list at begin position. Now let's see how we are going to delete an element from the list at end position. So deleting an element from the list at end position. So after deleting an element from the list at end position, so the output is 10, 20 and 30. So 40 will be deleted from the list. So here the logic is very simple. Initially we have to place temp at the first node, and from each node we have to check whether its next node next field is null or not. So from this node we have to check what is its next node, 2000. So 2000 next field is null or not. So if it is null, then we can say that we have to delete this node. So that here we need to place the null here. Okay. So likewise we have to perform the operation. So let's see the logic here. So temp is equal to head. So initially temp will be placed at 1000 location. Next, from each node we have to check whether its next node next field is null or not. So temp is equal to head. So from each node we have to check whether its next node next field is null or not. If it is not equals to null, then move temp one position to its right. If it is equals to null, then we can say that we need to place null yet at that node next field. So that means here the logic is very simple. If you want to delete the last node, then what we have to do is we need to place temp at the last but one node. So if there are 10 nodes, then we need to delete the 10th node. So if we want to delete the 10th node, then we need to place temp at the 9th node. Okay, and place null in the 9th node next field. So it is sufficient. Okay. So what is temp here? 1000. 1000 next 2000. Next 2000 next 3000. So 3000 is not equal to null. Condition is true. So let's see one more time. So what is temp? Temp means 1000. Next 1000 next means temp next. 1000 next means 2000. So temp arrow next will gives 2000. Next 2000 next means 3000. So 3000 is not equal to null. Condition is true. So temp is equal to temp arrow next. So temp means 1000. 1000 next means 2000. So temp will be placed at 2000 memory location. Next temp means 2000. 2000 next means 3000. Next 3000 next means 4000. 4000 is not equal to null. So body will be executed. So temp arrow next. So 2000 next means 3000. So temp will be placed at 3000 location. Next once again condition will be checked. Temp means 3000. 3000 next means 4000. 3000 next means 4000. 4000 next means null. Null not equal to null. Condition is false. So the control comes out from the value. So in this example we want to delete this last node. So we have to place temp at the last but one node. Okay. So what we have to do now? So simply we need to place null here. So temp arrow next is equal to null. So if you place null here, then what will happen? Temp arrow next is equal to null. So this link will be broken here. Okay. This link will be broken here. So suppose if you want to delete this 40 also, then what we can do is, so what is the address here? 4000. Okay. So temp is at 3000 location. So we need to declare one more structure variable like star D. So D stands for deleted node. So we can write as D is equal to temp arrow next. D is equal to temp arrow next. So what is temp here? 3000. So 3000 next means 4000. So D will be placed at 4000 memory location. Now display the value. Printf deleted node is %d comma D arrow data. So what is D data? 40. So 40 will be printed now. Now place null here. So temp arrow next is equal to null. Temp arrow next is equal to null. So we have to write null in uppercase letters. Then if you place null here, then this link will be broken. Now there is no need of this node. So we can destroy that node with the help of free function, free of D. So that this memory will be destroyed, we can use that memory for storing some other variable. Okay. So in this way we can delete an element from the list at n position. Now let's see how we can perform deletion operation at specified position. Now let's see how to delete an element from the list at specified position. Let we have a linked list with 4 nodes. Head points to the first node. Let here the position is second position. So let it be 0th position, let it be first position, let it is second position. So in this example our target is we want to delete 30. So after deleting 30 the output is 10, 20 and 40 is the output here. So here initially we have to place temp at head position. Next if we want to delete the second position element, then we need to traverse the temp until we get first position. So this is nothing but first position. And here the statement is very simple. We need to place the last node address. Why? Because we are deleting this node here. So if you place 4000 here, then automatically these links will be broken and a link will be established like this. So that is the logic we have to write here. So let us write that logic. So what is the second node? 20. Next field 3000. Next third node 30. Next field 4000. Next fourth node 40. Next field null 4000 here. So initially we have to place temp at head position. So temp is equal to head. Then after that here the input is position. Printf enter the position at which the element is deleted. So scanf %d comma $pos. Let the position here is 2. So we need to place temp at position 1. So the for loop can be written as for I is equal to 0, I less than pos minus 1, I plus plus, temp is equal to temp arrow next. So what is a value? 0. 0 is less than position minus 1. 2 minus 1 means 1. So 0 is less than 1. Condition is 2. So body will be executed. Temp is equal to temp arrow next. So temp means 1000. 1000 next means 2000. So temp will be placed at 2000 memory location. I plus plus. I becomes 1. 1 less than 1. Condition is false. So now, so this is nothing but the deleted node. So where is temp? Temp is a 2000 location. So here we can write as d is equal to temp arrow next. So temp means 2000. So 2000 next means 3000. So that they will be placed here. So display that node. Printf deleted node is percentage d comma d arrow data. D arrow data. Now our target is we have to delete this node. So in order to delete this node, what we need to do is we need to place 4000 here. Why? Because we are deleting this node here. So how to get this node here? So we have to place here. So temp arrow next is equal to so this is nothing but temp. So in 2000 next we have to store 4000. So how to get 4000? D means 3000. So D next is equal to 4000. D next is equal to 4000. Or the statement can be replaced with temp arrow next. It is our choice. Temp arrow next. So what is temp? Temp means 2000. So 2000 next means 3000. 3000 next is nothing but 4000. Okay. So if you store 4000 here, then these two links will be broken and a link will be established from this node to this node. Okay. Next we can place null here. So the statement can be written as d arrow next is equal to null. Now there is no need of this node. So destroy the memory. So free of d. So the output here is after deletion 10, 20 and 40 is the output. So in this way we can delete an element from the list at begin position, end position and specified position. Now let's see about counting number of nodes in a single linked list. Let we have a single linked list with 3 nodes. We know that a single linked list or any linked list is a collection of nodes. Let we have 3 nodes in the list. Let the address of the first node is 1000, address of the second node is 2000, address of the third node is 3000. In a single linked list, each node mainly contains 2 fields. The first field is data field, the second field is next field. Let the data of the first node is 10, data of the second node is 20, data of the third node is 30. Next field contains address of the next node. So address of the second node is 2000. So 2000 is stored in first node next field, so that a link will be established from first node to the second node. The second node next field contains address of the third node, so that is nothing but 3000. If we store 3000 here, then a link will be forward from second node to the third node. And the last node next field contains null. So null indicates end of the linked list. And we have a node called head. Head always points to the beginning of the list. So let we have a list with these 3 nodes. So now in this program our target is we have to count the number of nodes present in the linked list. So this linked list totally contains 3 nodes. So this is the first node, second node and third node. So we have to produce 3 as the output. So for that, what is the logic here? So initially we have to place a temporary variable called temp at head. So here the first statement is temp is equal to head. Temp is equal to head. And we need to declare, before that we need to declare a variable called count. The initial value of the count is 0. Count is 0. If this address is not equals to null, then we can say that it is a node. Suppose if the address is equals to null, then we can say that there is no node. Okay. So we have to check whether temp is not equal to null or not. If temp is not equal to null, then we can say that that is a node. So increment the count value. Why? Because if count is not equal to 1, then we can say that it is a node. So we have to increment the count value. So then count will become 1. Then after that we have to check its next node. So we will get 2000 by traversing temp next. Okay. So let's write the logic here. So the logic is very, very simple here. We have to check whether the temp is not equals to null or not. So while temp is not equals to null, then we have to increment count value. So count plus plus or count is equal to count plus 1. Next, traverse temp to its next node. So we can traverse temp to its next node by using the statement temp is equal to temp arrow next. Next, whenever the condition is false, then we can say that the linked list is over. So print count value now. So printf number of nodes is equal to it is an integer value. So the format specified is %d comma. So the value is available in count. Okay. So this is the logic here. So let's check whether our logic is correct or not. So temp is equal to head. So initially temp is at head, that is nothing but 1000 memory location. Next count is equal to 0. So the initial value of the count is 0 now. Next check the condition. While temp not is equal to null. So what is temp? 1000. So 1000 is not equal to null. So condition is true. So this body will be executed. So count is equal to count plus 1. So previous value of count 0. So 0 plus 1, 1. So now count will becomes 1. Next temp is equal to temp arrow next. So what is temp? 1000. 1000 next means 2000. So now temp will be placed at 2000 memory location. So body is over. So once again the condition will be evaluated. So while temp is not equal to null. So what is temp? 2000. So 2000 is not equal to null. Condition is true. So body will be executed. Count is equal to count plus 1. So what is the previous value in count? 1. So 1 plus 1 means 2. So now count will become 2. Next temp is equal to temp arrow next. So what is temp now? 2000. So 2000 next means 3000. So now temp will be placed at 3000 memory location. So once again the condition will be checked. Okay. Why? Because the body's execution is over. So while temp not equal to null. So temp means 3000. So 3000 is not equal to null. Condition is true. So body will be executed. Count is equal to count plus 1. So the previous value of count is 2. So 2 plus 1, 3. Next to temp is equal to temp arrow next. What is temp? 3000. So 3000 next means null. So now the value of the temp is null. So temp is equal to null. So once again condition will be evaluated. So what is temp now? Null. Null not equal to null. Condition is false. So the control comes out from while loop. So printf number of nodes is %d comma. So what is count value? So 3. So in this way we can find out the number of nodes available in the single linked list. Now let's see about searching a node in single linked list. Let we have a single linked list with 3 nodes where address of the first node is 1000, address of the second node is 2000, address of the third node is 3000. Let each node contains 2 fields, data field and next field. Let data field is an integer value. We know that next field contains address of the next node. So here data of the first node is 10, data of the second node is 20, data of the third node is 30, and this address field contains address of the next node. So the second node address is 2000. So 2000 is stored in first node next field. So a link will be formed from first node to the second node. Next to second node next field, address field contains address of the third node. So 3000 is stored in second node next field, so that a link will be formed from second node to the third node, and the last node next field contains null. Null indicates end of the linked list. Here we follow linear search logic. So we know the logic for linear search. Compare the key element with elements of the list one by one until the key element is found or the list is completed, the list is exhausted. Okay. So let's write the logic here. Initially we have to place temp at head. So temp is nothing but a structure variable. So first we have to read key value. So printf enter key element. So first we have to read the key element which we want to search. Enter key element. Here key element is of type int. So before that we have to declare some key element, int key. Next scanf %d comma ampersand key, because key element is an integer value. So the format specified is %d. Okay. So here the logic is very simple. We have to compare the key element with these 3 elements 10, 20 and 30 until the key element is found or the list is exhausted or the list is over. Okay. So initially we have to place temp at head. So the statement is temp is equal to head. Next, we have to search as long as the list is not null. So if the temp is not equal to null, then we can say that there is a node. So compare key element with that node. So if this condition is true, then compare key element with that node. So we can get that node with the help of temp arrow data. So this is nothing but data feed, this is nothing but next feed. So if key double is equal to temp arrow data. So this list is already created. Okay. So please refer my previous video, single linked list creation, so that you will get a perfect idea about how to create a single linked list. So if key is double is equal to temp arrow data, then initially we have to declare a variable called flag. The initial value of the flag is 0. If flag value is 0, then we can say that the key element is not found. Whereas if flag value is 1, then we can say that key element is found. So flag is equal to 1, break. Next close the if loop, next close the while loop. So close the if and close the while. Then after that write the logic here. If flag double is equal to 1, then we can say that printf key element found. Printf key element found. Else we can say that printf key element not found. Key element not found. So let's check whether our logic is correct or not. So first statement, in flag is equal to 0. So the initial value of the flag is 0. If flag is 0, then we can say that key element is not found. Whereas if flag is 1, then we can say that key element is found. So printf enter key element scanf %d comma %key. So let the key element is 20. Next, temp is equal to head. So what is head? 1000. So temp is placed at 1000 memory location. Now check the logic. While temp not equal to null. So what is temp? 1000. So 1000 is not equal to null. Condition is true. So compare key element with this data. So what is key element? 20. 20 double is equal to, what is temp data? What is 1000 data? 10. So 20 double is equal to 10. 20 double is equal to 10. Condition is false. So what we have to do? We have to search for the next node. So what is the next node address? 2000. So how to traverse to the next node? By using the statement temp is equal to temp arrow next. So in order to traverse to the next node, we have to use this statement. Okay. So what is key value? 20. 20 double is equal to 10. Condition is false. So the control comes out from the if. So what is the next statement? Temp is equal to temp arrow next. What is temp? 1000. 1000 next means 2000. So now temp will become 2000. So now temp will be placed at 2000 memory location. So once again the condition will be evaluated. While temp not equal to null, what is temp? 2000. 2000 is not equal to null. Condition is true. So body will be executed. What is key value? 20. So 20 double is equal to, what is temp? 2000. 2000 data means 20. So 20 double is equal to 20. Condition is true. So if body will be executed. So flag is equal to 1, break. So why we are using break statement here? If key element is found, then there is no need to search the remaining elements in the linked list. So that's why we use this break statement. If you don't use this break statement, then the remaining elements in the list are also to be compared. So break. So whenever break statement is executed, then the control comes out from the loop. So the control comes out from the loop. So what is the next statement? If flag double is equal to 1, what is flag value? The statement is executed. So now flag will become 1. So 1 double is equal to 1. Condition is true. So what is the output? Key element found. So that message will be printed on the monitor. So that the key element is 100. Now let's check whether our logic is correct or not. So printf enter in flag is equal to 0. So what is the flag value now? 0. Printf enter key element. What is the key element that we enter? 100. So now key value is 100. So first statement, temp is equal to head. So initially temp will be placed at head. So what is head? 1000. So temp will be placed at 1000 memory location. Next, while temp not equal to null, What is temp? 1000. So 1000 is not equal to null. Condition is true. So body will be executed. If key double is equal to temp arrow data, what is key value? 100. What is temp data? 10. 100 double is equal to 10. 100 double is equal to 10. Condition is false. So if this body won't execute, so the control comes out from the if temp is equal to temp arrow next. What is temp? 1000. 1000 next means 2000. So now temp will become 2000. So once again condition will be checked. Why temp not equal to null? What is temp now? 2000. 2000 is not equal to null. Condition is true. So body will be executed. If key double is equal to temp arrow data, what is key? 100. What is temp data? 20. 100 double is equal to 20. 100 double is equal to 20. Condition is false. So the control comes out from if. Why? Because if the condition is true, then only this body will be executed. Now the condition is false. So the control comes out from the if. So temp is equal to temp arrow next. Temp means 2000. 2000 next means 3000. So temp will be placed at 3000 now. Next, once again condition will be checked. While temp not equal to null, 3000 is not equal to null. Condition is true. So body will be executed. What is key value? 100. 100 double is equal to temp data 30. 100 double is equal to 30. 100 double is equal to 30. Condition is false. So the control comes out from if temp is equal to temp arrow next. What is temp? 3000. 3000 next means null. So now temp will becomes null. So once again condition will be evaluated. What is temp now? Null. Null not equal to null. Condition is false. So the control comes out from the while. So the list is exhausted and the key element is not found. Okay. If flag double is equal to 1, what is flag? 0. 0 double is equal to 1. Condition is false. So printf key element is not found. So this message will be printed on the monitor. So in this way we can perform searching in a single linked list. It is not possible to perform search operation using binary search. We must always use linear search only. In linear search, we compare key element with elements of the list one by one. Whereas in binary search, we have to divide the given list into two parts, where low contains 0th element, high contains n-1 element. That is nothing but the last element. And we need to calculate mid. So that is not possible in a single linked list. We can perform binary search only on arrays and some pointers. It is not possible to perform binary search with linked list. So we must always use only linear search for searching a node in a single linked list. Now let's see about sorting a linked list. Here for sorting we have to follow the logic of bubble sort. Let's write the logic for the bubble sort using arrays. So for I is equal to 0 we need two for loops, I less than n, I plus plus. Next for j is equal to 0, j less than n, j plus plus. In bubble sort we have to compare adjacent elements. If they are in ascending order, then there is no problem. If they are not in ascending order, if a of j is greater than a of j plus 1, then temp is equal to a of j is equal to a of j plus 1, a of j plus 1 is equal to temp. So this is the logic for bubble sort. So for I is equal to 0, I less than n, I plus plus. For j is equal to 0, j less than n, j plus plus. If a of j is greater than a of j plus 1, then temp is equal to a of j is equal to a of j plus 1, a of j plus 1 is equal to temp. So we have to compare adjacent elements. If they are in ascending order, then there is no problem. If they are not in ascending order, then we have to swap them. So after first iteration, the maximum element will be moved to the last position. After second iteration, the second maximum element will be moved to the last but one position. So likewise the process will be continued. So in linked list also we follow array logic. Okay. Let we have a single linked list with 3 nodes. So let we have a list like this. So let we have 3 nodes. Let the first node data is 30, second node data is 20, third node data is 10, address is 1000, address is 2000, address is 3000 here. Here each node contains 2 fields. The first field is data field and the second field is next field. Data field is nothing but an integer value. Next field contains address of the next node. So address of the next node is 2000. So this 2000 is stored in first node next field. If you store 2000 here, then a link will be formed like this. Next, address of the third node is stored in second node next field. If you store 3000 here, then a link will be found from second node to the third node. And the last node next field contains none. And head always points to the beginning node. So head always points to the 1000. Here our target is we want to sort the elements in ascending order. So the output here is after sorting, the output is 10, 20 and 30 is the output. So for that we have to write the logic here. Initially this list is created with 3 nodes. So for create function it is better to refer my previous video, that is nothing but single linked list create function. Let's write the logic here. Here initially we have to declare a temporary variable, 2 temporary variables. The first temporary variable is for I, the second temporary variable is for j. Let the first temporary variable is t1 and the second temporary variable is t2. Okay. Next, for I is equal to 0. Here I means t1, whereas j means t2. Okay. For we can write as here what is 0? 0 means the first element. The first element address is available in head. So for t1 is equal to head. Next, what is the condition? I less than n. So here what is the condition here? t1 is not equal to null. So we have to repeat the loop as long as the t1 is not equal to null. So t1 is not equal to null. Next, I plus plus. Here I plus plus means we have to move to the next node. We can move to the next node with the help of this next. So t1 is equal to t1 arrow next. t1 is equal to t1 arrow next. Next, for this j is nothing but t2. t2 is equal to what is 0? 0 means first element. That is nothing but head. Next, how long we have to repeat the loop? As long as t2 is not equal to null. Next, in order to move to the next node, we have to use this t2 is equal to t2 arrow next. So this is nothing but next field. This is nothing but data field. Next condition, we have to compare the adjacent elements. If a of j is greater than a of j plus 1. Here, what is a of j here? This j is nothing but this innermost loop variable. Here j means t2. So how to get data here? If t2 arrow data is greater than a of j plus 1. So how to get a of j plus 1? A of j plus 1 is nothing but t2 next data. t2 next data is greater than t2 arrow next arrow data. So if this condition is true, then we have to swap the variables. So we have to declare an integer temporary variable called t. So t is equal to t2 arrow data. Next statement, t2 arrow data is equal to t2 arrow next arrow data. Next one, t2 arrow next arrow data is equal to t. So in this way we can write the logic for sorting a single linked list by using bubble sort logic. Now let's check whether our logic is correct or not. So here we have totally how many nodes? We have 3 nodes. We have 3 nodes. So this is the first node, this is the second node, and this is the third node. So let the address of this node 1000, address of this node 2000, address of this node 3000. Let the data of this node is 30, data of this node is 20, data of this node is 10. This next field contains address of the next node. This next field contains address of the next node. That is nothing but 3000. Whereas the last node next field contains none. Initially head points to the beginning node, that is nothing but 1000. So here we have to compare the adjacent elements 30 and 20. So 30, 20, they are not in ascending order. So we have to swap them. So in place of 30 we will get 20. In place of 20 we will get 30. Next again we have to compare 30 and 10. So 30, 10, they are not in ascending order. So swap them. So after first iteration what was happened? The maximum element is moved to the last position. Whereas in the second iteration, the second maximum element, that is nothing but 20, will be moved to the last but one position. So in this way we have to perform the operation. Let's check whether our logic is correct or not. So what is the first statement? T1 is equal to head. So initially T1 is placed at head, that is nothing but 1000. Next to T1 is not equal to null. What is T1? 1000. So 1000 is not equal to null. Condition is true. So this body will be executed. For T2 is equal to head. So T2 is also placed at head, that is nothing but 1000. Okay. Next T2 is not equal to null. What is T2? 1000. So 1000 is not equal to null. Condition is true. So the body will be executed. So this body will be executed. Next statement, if T2 arrow data. So this is nothing but T2, 1000. What is 1000 data? 30. So 30 is greater than T2 arrow next arrow data. What is T2? 1000. This T2 means 1000. 1000 next means 2000. T2 arrow next. So 1000 next means 2000. So this is nothing but this 2000. So 2000 data. What is 2000 data? 20. So T2 means 1000. 1000 next means 2000. 2000 data means 20. So 30 is greater than 20. 30 is greater than 20. Condition is true. So it means these two elements are not in ascending order. So we have to swap them. So swap the elements. So T2 is equal to T2 arrow data. So this is nothing but what is T1 data? This is nothing but T1 data. So this is nothing but T2 data. We know the logic for swapping two numbers. T is equal to A is equal to B is equal to T. So T is equal to T2 arrow data. So what is T2 arrow data? So this is nothing but T2 arrow data, and this is nothing but T2 arrow next arrow data. So T is equal to T2 arrow data. So 30. Next T2 arrow data is nothing but T2 arrow next arrow data. What is T2 arrow next arrow data? 20. Next T2 arrow next is equal to T2 arrow next arrow data. Okay. T2 arrow next arrow data is equal to T. What is T? 30. So after swapping, what was happened? T2 data will become 20. So this is nothing but T2 data. So it will become 20. Next T2 arrow next arrow data will become 30. So this will become 30. So body execution is over. So once this body execution is over, then what will happen? This is the innermost for loop which we are executing. So control goes to the expression 3. What is the next statement? T2 is equal to T2 arrow next. What is T2? 1000. 1000 next means 2000. So T2 will be placed at 2000 now. So once again condition will be checked. Here first, once again condition will be checked. What is the condition here? T2 is not equal to null. What is T2? 2000. So 2000 is not equal to null. Condition is true. So this body will be executed here. Okay. If T2 arrow data is greater than T2 arrow next arrow data. So what is T2 data? 2000 data. 30 is greater than. What is T2 next? 2000 next means 3000. So 3000 data means 30. 3000 data means 10. So 30 is greater than 10. Condition is true. So it specifies that these two elements are not in ascending order. So we have to perform this swapping. So in place of 30 we will get 10. In place of 10 we will get 30. Next. So body execution is over. So once again expression 3 will be executed. Okay. T2 is equal to T2 arrow next. T2 is equal to T2 arrow next. So what is T2? 2000. So now 2000 next means 3000. So 2000 next means 3000. So now T2 will be at 3000 memory location. Okay. So after this data we don't have any node after 30. So here we can write the condition as T2 arrow next is not equal to null. T2 arrow next is not equal to null. Here if we want we can also change this outermost for loop condition as T1 arrow next not equal to null. T1 arrow next is not equal to null. T2 arrow next not equal to null. Why? Because if there are 5 elements in the list, then if we sort 4 elements, then automatically the 5th element is at the proper order. There is no need to sort that 5th element. So that's why we have to write the condition as T1 arrow next is not equal to null. Okay. If there are 100 elements, then if we sort 99 elements, then automatically the 100 element is at the proper order. Okay. So T1 arrow next is not equal to null. T2 arrow next is not equal to null. Okay. So now check the condition. T2 arrow next is not equal to null. So what is T2? 3000. So 3000 next means null. Null. So null not equal to null. Condition is false. Null not equal to null. Condition is false. So the control comes out from this innermost for loop. Innermost for loop. So control goes to this expression 3 now. So the first iteration is over. So after first iteration, what was happened? The maximum element is moved to the last position. What is the maximum element? 30. So 30 is moved to the last position. So once again, this condition will be checked. This expression 3 will be executed. So what is this expression 3? T1 is equal to T1 arrow next. What is T1? 1000. 1000 next means 2000. So now T1 will be placed at 2000 memory location. T1 will be placed at 2000 memory location. Okay. So once again, condition will be evaluated. So 2000 is not equal to null. Condition is true. So body will be executed. Next, T2 is equal to head. So what is T2 now? T2 will be placed at head now. Okay. T2 will be placed at head now. So what is head? 1000 memory location. Next to T2 arrow next is not equal to null. So what is T2 arrow next? 1000 next. So 1000 next means 2000. So 2000 is not equal to null. Condition is true. So this body will be executed. If T2 arrow data is greater than T2 arrow next arrow data. What is T2 data? 20. What is T2 next data? So T2 means 1000. So 1000 next means 2000. So 2000 data means 10. So 20 is greater than 10. 20 is greater than 10. Condition is true. So this body will be executed. So we have to swap the elements. So what was happened here? The elements are in sorted order. So in this way we can sort the elements of a single linked list. So simply we are following some bubble sort logic. We have to compare adjacent elements. We have to compare adjacent elements. If they are not in ascending order, then swap them. If they are in ascending order, then there is no need of any swapping. Now let's see the logic for reversing a single linked list. Let we have a single linked list with 3 nodes like this. This is the first node. This is the second node. And this is the third node. So this is the syntax for the node declaration. So struct node, it contains 2 fields. The first field is data field and the second field is next field. So this is nothing but this field is data field, whereas this field is next field. So first field data field, second field next field. So first field data field, second field next field. Let the address of the first node is 1000. Address of the second node is 2000. Address of the third node is 3000. Let here data is of type integer. Let the data of the first node is 10. Data of the second node is 20. Data of the third node is 30. Here next field contains address of the next node. So second node address should present the first node next field. So if we store 2000 in first node next field, then a link will be formed from first node to the second node. And second node next field contains address of the third node. If we store 3000 here, then a link will be formed from second node to the third node like this. And the last node next field contains null. Null indicates end of the list. And we have a node called head. Head always points to the starting node. So head means 1000. Head arrow data means 10. Whereas head arrow next means 2000. Okay. So a single linked list is already created. Okay, like this. So for creation, please refer my previous video. That is creation and displaying of single linked list. So that if there are any doubts in create function, then those doubts will be clarified. So here, if we print the output, then the output will be printed as 10 arrow, 10 arrow, 20 arrow, 30. Because what is the first node data? 10. This arrow represents there is a link from head to this node to this node. Next to 20 arrow, 30. So likewise the output will be printed. Whereas if we reverse the single linked list, then the output is, so first 30 will be printed, so 30 arrow, next 20 will be printed, next 10 will be printed. So the output of this reversing a single linked list is 30, 20, 10. Whereas the normal output is 10, 20, 30. So let's see the logic here. If there are 3 nodes in the linked list, then 3 iterations are needed. If there are 10 nodes in the linked list, then 10 iterations are needed. So the number of iterations depends upon the number of nodes in the single linked list. Okay. So here the logic is very simple. Here after reversing the single linked list, this node will becomes the last node, whereas this node will becomes the first node. Why? Because what is the output after reversing 30, 20, 10? So this 10 node, it will becomes the last node, whereas it will becomes the first node. So for the last node, what is the next field? The last node next field always contains null. So we have to place null here. What is the address of this node? 1000. So this is the first iteration. So in the first iteration, what we have to do? We have to place null in the last node next field. After reversing, this 10 will become the last node. So we need to place null in this last node next field. So this is the first iteration. And in the second iteration, what we have to do is, what is the address of this node? 2000. Data of this node 20. In the second iteration, we have to place address of the last node in the last but one node's next field. So what is this address? 1000. So we have to store 1000 in the last but one node next field. If we store 1000 here, then a link will be formed from this node to this node. So a link will be formed like this. So this is the second iteration. Okay. In the third iteration, what we have to do? We have to place address of the second node in the first node next field. What is the address here? 3000. Data 30. So after reversing, what will happen? This node will become the first node. So we have to store address of the second node in the first node address field or next field. So we have to store 2000 here. So if we store 2000 here, then a link will be formed from first node to the second node. So after reversing, this node will become the first node. So we have to place head here. Okay. So now what will happen? Head points to this node 3000. So first head data will be printed. So 30 will be printed. Next head arrow next means 2000. So control goes to the 2000. So what is 2000 data? 20. So 20 will be printed. Next what is head next? 1000. So control goes to the 1000. So what is 1000 data? 10. So 10 will be printed. Next what is 1000 next field? Null. So null not equal to null, condition is false. So likewise the output will be printed. Now let's check whether our logic is correct or not. So reverse is the function name. Next we are using two structure variables here, current and next. So in this example, current and next are some structure variables, some node names, whereas next is a member of the structure. So we are using next as a member of the structure as well as a node name. So this is nothing but next. This next field contains address of the next node, as well as we are using next as a node name in order to point to the next node. Okay. Next structure node star prev is equal to null. So the initial value of the prev is null. Okay. Next this is the logic here. So what is the first statement? Current is equal to head. So current is equal to. So this is the first iteration. Okay. So current is equal to head. What is head? 1000. So now current will be at 1000 memory location. So current will be at 1000 memory location. Next, while current not equal to null. So what is the current? 1000. So 1000 is not equal to null. Condition is true. 1000 is not equal to null. So condition is true. So body will be executed. So this is the first iteration. So in the first iteration, what will happen? We have to place null in the last node next field. So that is the thing we have to do. Okay. Let's see the logic here. Next is equal to current arrow next. So next is equal to current arrow next. So what is current? Current means 1000. So 1000 next means 2000. So next is equal to current arrow next. So current means 1000. 1000 next means 2000. So now next will be placed at 2000 memory location. Because if it is the current node, then what is the next node? This is the next node. Suppose if current node is the second node, then the next node is this third node. Suppose if current node is at 3000 memory location, Then the next node may be at 4000 memory location, like that. Okay. Next, current arrow next is equal to pre. Current arrow next is equal to pre. So what is current? 1000. So what is 1000 next? We have to place null in 1000 next field. So this is the logic which we are doing. So 10 we have to place, this is nothing but 1000. Current arrow next is equal to null. So this is nothing but current. So current arrow next. So we have to place null here. Okay. Next, pre is equal to current. So pre is equal to current. So operations on the first node is over. So now this node has to become the previous node. So pre is equal to current. So what is the current node? At 1000 location. So now pre is also at 1000 memory location. Next, current is equal to next. Current is equal to next. So if this node becomes the previous node, then the next node will become the current node. Okay. So 20. This is nothing but 2000. So this will become the current node. So the logic is very simple here. In the first iteration, what we have to do? We have to place null in. This is the logic which we are doing. We have to place null in the last node next field. Okay. So next is equal to current arrow next. So next is equal to current arrow next. So what is the next here? Initially, what is the current node? 1000 is the current node. So current is equal to head. So current is equal to 1000. So while current is not equal to null, while 1000 is not equal to null, so condition is true, body will be executed. So next is equal to current arrow next. So what is the next node now? So this, if it is the current node, then it is the next node. Okay. So next is equal to current arrow next. So we have to place next here. So already next is placed here. Next to current arrow next is equal to previous. So we have to place null in current next field. So here we have placed a null here. Okay. Next. So the operations on this node is over. Okay. Now we have to perform operations on the second node. So now previous will become the current. So pre is equal to current. So initially current is at 1000. So now pre is at 1000 memory location. Next current is equal to next. So now we have to place current at next memory location. So what is next? 2000. So place current at 2000 memory location. So the first iteration is over. Now let's see the third iteration. Okay. Let's see the third iteration. Okay. Second iteration. So once again the loop will be repeated. While current is not equal to null. Now what is the current node? Now current node is 2000. Previous node is 1000. Okay. Next is equal to current arrow next. Next is equal to current arrow next. So what is current now? 2000. What is 2000 next? Initially we have 3000 here. So what is 2000 next? 3000. So now next will be placed at 3000 memory location. Next to current arrow next is equal to pre. So what is current? 2000. So in 2000 next we have to store pre. In 2000 next we have to store pre. What is pre? 1000. So if you place 1000 here, then a link will be formed like this. So that is the thing which we are doing. In the second iteration, we have to store address of the last node in the last but one node next field. So that a link will be formed here. Now performing operations on this node is over. Now this node will become the previous node, whereas this node will become the current node. So here the statement is pre is equal to current. Pre is equal to current. So pre is placed at 2000 memory location. And the next statement is current is equal to next. So now actually current is at 2000 memory location. Now current will be placed at 3000 memory location. Okay. So in the second iteration, what was happened? In the second node next field, we stored address of the last node. Okay. And we placed the previous at the current node and next at current at the next node. Now once again, the loop will be repeated while current is not equal to null. So what is current? 3000. So 3000 is not equal to null. Condition is true, so body will be executed. So next is equal to current arrow next. Next is equal to current arrow next. So what is the next field here? So this is the current node. So current next means null. So now next will become null. Now next will become null. Okay. Next, current arrow next is equal to pre. So in current next we have to store pre. What is pre? 2000. So we have to store 2000 here. If we store 2000 here, then a link will be formed like this. Next, current arrow next is equal to pre. So next is equal to, what is the statement there? Next is equal, current arrow next is equal to pre. So establishing the link is over. Next to pre is equal to current. So we have to place pre at 3000 memory location. Next, current is equal to next. Now current will become what? Null. Current will become null. Next, while current not equal to null. What is the current? Null. Null not equal to null. Condition is false. So the control comes out from the while loop. So head is equal to pre. So what is pre? 3000. So now head is at 3000 memory location. Okay. So what was happened now? So reversing the linked list is over and the head points to the 3000 memory location. Here the logic is also very simple. Initially we have to place the current at head memory location. Initially head is at 1000 memory location. While the current is not equal to null, we have to remember only one statement. If this is the current node, then it will become the next node. So we can write it as next is equal to current arrow next. Next is equal to current arrow next. If it is the current node, then it will become the next node. Next, current arrow next is equal to previous. So here what is the variable here? Right hand side variable, current arrow next. So here the left hand side variable is current arrow next. So what is the use of is equal to operator? It is useful to assign a right hand side variable to left hand side value to the left hand side variable. Okay. So here this is the right hand side variable. So the next statement begins with this right hand side variable. So current arrow next is equal to pre. So in current next we have to store address of the previous node. Next here what is the right hand side variable? Pre. So the next statement starts with pre. So operations on this node is over. Now this node has to become the previous node and this node has to become the next node. So previous is equal to current, current is equal to next. So whenever the condition is false, then we have to place head at the previous node. Okay. So in this way we can reverse a single linked list. Now let's see about advantages and disadvantages of linked list, or advantages and disadvantages of single linked list, or we can also call it as the differences between arrays and linked list. Okay, let's see the first advantage. First let's see the advantages. After that we will discuss the disadvantages. Let's see the first advantage. Linked list is a dynamic data structure. That is, memory will be allocated at runtime. So no wastage of memory. We know that arrays uses static memory allocation. Static memory allocation means the memory will be allocated during compilation time. So it is not possible to change the size of the array during execution time. So if more memory is allocated than required, then memory will be wasted. If less memory is required, then it is not possible to perform the operations. Whereas linked list is a dynamic data structure. That means the memory will be allocated during runtime, execution time. So it is our choice. We can use as many nodes as we want because memory allocation should be done during execution time. So we can say that there is no wastage of memory. Now let's see the next point. It is not necessary to know in advance regarding the number of elements to be stored in the list. The major problem with arrays is, in array we must know in advance regarding what is the size of the array, how many elements we need to be stored in the array. Whereas in linked list that problem will not arise because it is a dynamic data structure. So it is not necessary to know in advance regarding the size of the linked list. So we can use as many nodes as we like because memory allocation will be done during runtime. Now let's see the next advantage. Insertion and deletion operations are easier as shifting of values is not necessary. If you take arrays, insertion and deletion operations are very expensive. Why? Because let us assume that we have an array like this. The array contains some 5 elements. Let us assume that I want to insert an element into the array at begin position. Now what we have to do is we have to shift all these elements one position to the right in order to store the new element at the first position. Okay. So 50 will be shifted one position to the right, 40 will be shifted one position to the right, 30 will be shifted one position to the right, 20 will be shifted one position to the right, 10 will be shifted one position to the right. Now we have to store the new element here. Let us assume that we have 1 lakh elements in the array. Then how many shiftings are needed? 1 lakh shiftings are needed. That is the problem in the array. If we want to delete an element from the array at begin position, then also we have to shift the elements of the array one position to the left. Here we want to delete the beginning element. So what we have to do is we need to shift all the elements one position to the left. One position to the left. Suppose if the array contains 1 lakh elements, then 99,999 shiftings are needed. Whereas if you take linked list, there is no need of any shiftings. If you want to insert the element at the beginning, simply we can insert the element before the head node. Okay. If you want to insert the element at the last position, simply we can insert the element at the end of the tail node. Okay. So we can say that insertion and deletion operations are very simpler if you use a linked list. Whereas in arrays, they are very complex. Why? Because too many shiftings are needed. Now let's see one more advantage of the linked list. Different types of data can be stored in the data field of a node. The major problem with arrays is array can store only similar data type element. That means if integer array stores only integer values, float array stores only float values, character array stores only characters. Whereas if you take linked list, we can store any type of data in a linked list. A linked list is a collection of nodes. That node contains data field and next field. Okay, a data field may be integer value or float value or character value or a string or long integer or some boolean value or combinations of everything. So that is one more advantage of the linked list. Next advantage, the memory locations need not to be in adjacent memory locations. That is, nodes need not to be stored in adjacent memory locations. If you take array, then all the array elements will be stored in adjacent memory locations. Let the first element is at 1000. Let the size of the integer is 2 bytes. Then the second element is at 1002, third element at 1004, next element at 1006, next element at 1008, likewise. Whereas if you take linked list, then the nodes need not to be stored in adjacent memory locations. Let's see the last advantage of the linked list. Linear data structures such as stacks, queues are easily implemented with the help of the linked list. So these are various advantages of the linked list. Now let's see the disadvantages. Now let's see about disadvantages or limitations of linked list or single linked list. First disadvantage, random access of elements is not possible in single linked list. That is, we can't access a particular node directly. If you take arrays, then we can access any element directly. If we want to access the first element of the array, then we can access with a of 0. If we want to access the third element of the array, then we can access with a of 2. If we want to access the last element of the array, then we can access with a of n minus 1, where n specifies size of the array. But in linked list, it is not possible to access a node directly. Okay. Next, second drawback, binary search algorithm cannot be implemented on a single linked list. We can perform only linear search algorithm with the help of the linked list. It is not possible to implement binary search on linked list. Why? Because we know the logic for binary search. In a binary search, the given list is divided into two parts. The first part and second part. Okay, we have to compare key element with that list middle element. Suppose if the key element is less than the middle element of the array, then we have to search only in the left part. Suppose if the key element is greater than the middle element of the array, then we have to search only in the right part. But like that, it is not possible to implement in linked list. Okay, then because linked list means here the operations are performed according to the addresses. Okay, 1000, 2000, 300, they are nothing but some addresses. Okay, so it's not possible to implement binary search on linked list. Third drawback, there is no way to go back from current node to its previous node. That is, only forward traversal is possible. In single linked list and circular linked list, we can traverse only from left to right. Whereas in double linked list, we can traverse from right to left also. So we can say that in a single linked list, only in a single linked list and circular linked list, only forward traversal is possible. Whereas in double linked list, both forward traversal as well as backward traversal is possible. That means in a double linked list, we can traverse from the last node to its previous node with the help of previous field. Whereas in single linked list, that is not possible. Next drawback, extra storage space for pointer is required. So we know what is a linked list. It contains some pointer fields. So, why? Because that pointer field contains address of the next node. In a single linked list and double linked list, the last node next field contains null, whereas in a circular linked list, the last node next field contains address of the first node. But in order to store that pointer, some extra storage space is required. Last drawback, reversing the single linked list is very difficult, whereas reversing the double linked list is very easier. So compared to the double linked list reversing, single linked list reversing is very difficult. So these are the various advantages and disadvantages of single linked list or linked list. Now let's see about circular linked list. A circular linked list is also a linear data structure. That means it is a collection of nodes, and all the nodes need not to be stored in adjacent memory locations. But the major difference between single linked list and circular linked list is that in a single linked list, the last node next field contains null value, whereas in a circular linked list, the last node next field contains address of the first node. So that is the only difference between single linked list and circular linked list. So we can define a circular linked list as a collection of nodes in which the last node next field contains address of the first node. Here we have three nodes here. Let's see the diagrammatic representation of circular linked list. So we have three nodes here. Let each node contains two fields. The first field is data field and the second field is next field. So data field, next field, data field, next field. Let address of the first node is 1000, address of the second node is 2000, address of the third node is 3000. Let data of the first node 10, data of the second node 20, data of the third node 30. Here the next field contains address of the next node. So what is next node address? 2000. So we have to store 2000 here. Then a link will be established from first node to the second node. So here also the next field contains address of the next node. So it contains 3000. So if we store 3000 here, then a link will be established from second node to the third node like this. Here the last node next field contains address of the first node. So what is the address of the first node? 1000. So we have to place 1000 here. Then a link will be established from last node to the first node like this. So in this class, let's see how we can implement create function as well as print function. In the upcoming classes, we will see how to implement insertion operation in three cases: at begin position, end position, specified position, as well as delete operation in three cases: begin position, specified position, and end position. So let's see the first one. Let's see the first function here. The first function is create function. So by using create function, we can create a circular linked list. Here the node representation is struct node. Here also the node contains different data type elements. The first one is some integer value, whereas the second field is some address. So if we want to store multiple data type elements, then we have to use structures. So in order to define a structure, the syntax is struct space structure name. Let name of the structure is node. So here we have two fields. The first field is data field. Data field is of type integer, whereas the second field is next field, which is of type next. Why? Because we are using next field in order to store address of the same node. So this is called a self-referential structure. Here we are using three nodes. First one is new node, and the second one is head node. Next one is temp node. So new for the allocation of the memory. Head always points to the beginning of the circular linked list. That means head always points to the starting node of the linked list. Temp for traversing from one node to the another node. So let's see the create function here. So first of all here we need to allocate memory for the node. So in order to allocate memory for the node, So we are using new. So allocate memory for the node. So the node contains two fields. The first field is data field, whereas the second field is next field. Okay. So let address of the node is 1000. Then after that, here we need to perform two steps. First we have to store value in the data field. Next, here in a circular linked list, the last node next field contains address of the first node. So here the list contains only one node. So this node will become the first node as well as the last node. So we need to store 1000 here, so that a link will be formed from first node to the second node like this. So first we have to perform this step. So let us write the code here. So do, here we have to perform the repetition as long as we enter y. So y stands for yes. So if we enter other than y, then the list will be completed. Okay. So do, first allocate memory for the node. So for allocation of the memory we are using new. So new is equal to, so this is for typecasting purpose, struct node star. Why? Because MLR function doesn't return any value, but here the node should be stored at some address. So for storing that address we are performing the typecasting. So MLR of size of is an operator which is available in stdio.h. So size of struct node. So size of will allocate memory for the corresponding members of the node. So now what will happen? The memory will be allocated for the node. So memory allocation is over. Next we have to store value in the corresponding node. So before that we need to read some value. So printf enter a value. Printf enter a value. Next scanf %d comma ampersand value. So next what we have to do? We have to store value in new node data field. So we can write the statement as new arrow data is equal to value. So what is the value here? Let the value is 10. So 10 will be stored in new node data field. Next, what is the next field here? The next field contains address of the first node. So that is nothing but new. So we can write the next statement as new arrow next is equal to. So what is the address of the node? New. So with this allocation of the memory is over. Next, storing the value in data field is over, and storing the address of the first node is over. Next, here we have two cases. The first case is if the list is empty. The second case is if the list is not empty. We can say that the list is empty if head is equal to null. If head is equal to null, then we can say that the list is empty. Whereas if head not equal to null, then we can say that the list is not empty. Here the default initial value of the head is null. Why? Because the structure variables, the corresponding structure should be defined, should be declared on top of the main function. So it will become some global structure variable. For a global structure variable, the default initial value is null. So the initial value of the head is null. So if head double is equal to null, then what we have to do is this node will become the head node as well as temp node. So why we are using head node? Head always points to the beginning of the linked list, the starting node of the linked list. Suppose if the circular linked list contains 10 nodes, then head always points to the first node. Whereas we are using temp for traversing from one node to the another node. So here what is the condition here? If head double is equal to null. If head double is equal to null. So what is the initial value of the head? Null. So what we have to do now? We have to place head as well as temp at new position. So we can write as head is equal to new. Next one, temp is equal to new. So the initial value of the head is null. So we can say that the list is empty. So the condition is true. So head is equal to new. So what is new? 1000. So head will be placed at 1000 memory location, as well as temp will be placed at 1000 memory location. So let us assume that we created one more node. So how to create a node? So in order to create the node, we use new. So new, here the node contains two fields. The first field is data field. So let the value is 20 here. So 20 is stored in new node's data field. Next what will happen? So new arrow next is equal to new. New arrow next is equal to new. So what is new here? Let the address of this node is 2000. So what will happen now? So 2000 will be stored here. Then a link will be established like this. Okay. So now we have to check here what is new here. 1000. Next to new 2000. So initially new value is 1000. Next to new is 2000. So 1000 will be erased and new will be a 2000 memory location. So no longer new is available here. So next what we have to do? Here we have two cases. The list may be empty or the list may not be empty. If head double is equal to null, then we can say that the list is empty. But here what is head? Head is 1000. So 1000 double equal to null. Condition is false. So we can say that the list is not empty. If the list is not empty, then what we have to do is we have to establish a connection from the first node to the second node, and the last node next field contains address of the first node. So what we have to do is here, in order to establish the connection from first node to the second node, we have to use a stem. Don't use head here. Why? Because after creating the second node, we may create third node. So we need to establish the connection from second node to the third node. So now temp is at second node. Head should not be at the second node. Head will always point to the first node only. So we have to use temp here. So temp arrow next is equal to new. So here we have to store 2000. So if we store 2000 here, then a link will be formed like this. So let us write that step. Else establish a connection from first node to the second node. So what is the statement? Else temp arrow next is equal to new. Temp arrow next is equal to new. So 2000 is stored here, so that a link will be established from the first node to the second node. Then after that we have to move temp to the new. We have to move temp to the new. So how to move temp to the new? Simply we can write as temp is equal to new. Temp is equal to new. So what is new here? 2000. So now temp will be placed at 2000 memory location. Next, what is the next step here? In a circular linked list, the last node next field always contains address of the first node. So what is the last node here? It may be either new or temp. It is our choice. So we have to write as, what is the address of the first node? 1000. So store 1000 here. Then this link will be broken and a link will be formed like this. A link will be formed like this. So what is the statement here? New arrow next is equal to head. New arrow next is equal to head. Next to close the else block. Okay. Next to close the else block. So what is new here? New means 2000. So in 2000 next field store head address. What is head address? 1000. So that a link will be formed from this node to this node. Okay. Then after that here we have to repeat the loop as long as we enter while. So here write two more statements. Printf, do you want to add one more node? Do you want to add one more node to the list? So we have to press either Y or N. So Y means yes, N means no. So scanf. Here before that, if we are working on Turbo C operating system, then we have to clear the buffer. So before reading the character, so in order to clear the buffer, we have to use flush function. So flush of CDLL. Next scanf %c comma %ch. So ch is nothing but a character variable. Next close the do loop, and here the condition is y ch is double is equal to y. So as long as we enter y, then we can create one more node. If we enter other than y, then what will happen? The list will be over. Okay, creation of the list will be over. Now let us create one more node here. So printf, do you want to add one more node to the list? Let us say here, if we are working on a Linux operating system, then there is no need of flush function. Simply after this double quotation, we have to give one blank space. after this left double quotation, we have to give one blank space. Then only the corresponding character will be entered into the memory. Okay. Whereas if we are working on some turbo C, then we have to write a flush of stdin function. Okay. So let us assume that here we enter y. So scanf %c comma ampersand ch. Now ch contains y. Y double is equal to y. Condition is true. So once again the body will be executed. So first memory will be created. So what is the name of the node? So new is the name of the node. New is the name of the node, and it contains how many fields? 2 fields, data field as well as next field. Let the address of this node is 3000. Next, enter a value. Let the value is 30. Next, new arrow data is equal to value. So 30 will be stored here. Next, new arrow next is equal to new. So what is new here? 3000. So 3000 will be stored here. Then a link will be formed like this. Next, if head double is equal to null. So what is head? 1000. 1000 double is equal to null. Condition is false. So we can say that the list is not empty. So that we need to establish a connection from second node to the third node. We need to establish a connection from second node to the third node. Okay. So else block will be executed. Why? Because head is 1000. 1000 double is equal to null. Condition is false. So temp arrow next is equal to new. So what is temp? 2000. So 2000 next is equal to new. So what is new here? 3000. So we have to store 3000 here. We have to store 3000 here. So if we store 3000 here, then a link will be formed from second node to the third node. So this link will be broken. Next statement, temp is equal to new. So now temp will be at new location. So what is new? 3000. So temp will be at 3000 location. Next, new arrow next is equal to head. What is head? 1000. Here we have to store 1000 here. So that a link will be formed from the last node next field to the first node. So that this link will be broken. Okay, already this link is broken. So this link is not available there. Next, so the third node is created. So printf, do you want to add one more node to the list? Let us assume that we entered n. So n double is equal to y. Condition is false. So the control comes out from the 2. So in this way we can create a circular linked list. Now let's see how we can perform display operation. Now let's see displaying or printing or traversing a circular linked list. So traversing means displaying or visiting the nodes of the linked list. So let's see how we can display the list here. Here the first node, here this is nothing but our circular linked list. So the first node data field is 10, second node data field 20, third node data field 30. First node next field contains address of the second node next field contains address of the third node, the last node next field contains address of the first node. So initially head points to the first node. Here after displaying the output, we can get the output like this: 10 arrow, 20 arrow, 30 arrow, like this. Okay. So initially we have to place temp at head position. Then after that, at each node we have to check whether its next field is not equals to starting node or not. So what we have to do? At each step we have to check whether that node next field is not equals to this start node or not. If it is not equals to that start node, then we can say that it is not the last node. So display that node. So let us write the code here. So temp is equal to head. Temp is equal to head. So initially temp will be placed at 1000 memory location. So let us write the condition as it is our choice. Our target is we want to display output like this. So we can use temp not is equal to null or temp arrow next not is equal to head. It is our choice. So while temp arrow next not is equal to head, then we can say that it is not the last node, or so printf %d arrow comma temp arrow data. Next, so the displaying of one node is over. So move temp to its next node. So we can write here as temp is equal to temp arrow next. So what is the condition here? While temp arrow next not equal to null. So temp means 1000. So 1000 next means 2000. So 2000 is not equal to 1000. So what is temp? 1000. 1000 next 2000. So 2000 is not equal to head. Here head is 1000. So 2000 is not equal to 1000. So condition is true. So display the value. So print out %d yaru, comma temp yaru data. So what is the data here? Temp yaru data 10. So after that we displayed some yaru. It shows that there is a link from first node to the second node. So 10 yaru will be printed. Next to temp is equal to temp yaru next. So what is temp? 1000. 1000 next means 2000. So temp will be placed at 2000 memory location. So once again condition will be evaluated. So temp yaru next. So temp means 2000. So 2000 next means 3000. So 3000 is not equal to head means 1000. So 3000 is not equal to 1000. So condition is true. So the corresponding temp data will be printed. So what is 2000 data? 20. So after 20 yaru will be printed. So 20 yaru will be printed. Next to temp is equal to temp yaru next. So what is temp? 2000. 2000 next means 3000. So temp will be placed at 3000 memory location. So once again condition will be evaluated. So what is temp? 3000. 3000 next means 1000. 3000 next means 1000. What is head? 1000. So 1000 is not equal to 1000. 1000 is not equal to 1000. Condition is false. So the control comes out from the value. But this 30 arrow is not displayed. So we have to display that value there. So printf %d arrow, comma temp arrow data. Temp arrow data. So what is temp here? 3000. So 3000 data means what? 3000 data means 30 arrow. So 30 arrow will be printed. So in this way we can display the nodes of the circular linked list. In the next class we will see how we can perform the insertion operation as well as deletion operations. Now let's see how to perform insertion operation in the circular linked list. Here we have three cases. We can perform insertion operation at begin position or at end position or at specified position. Initially let's see how to insert an element into the circular linked list at begin position. Here we have a circular linked list. We know that in a circular linked list is nothing but a collection of nodes where each node contains some data field and next field. So the first node address is 1000, second node address 2000, third node address 3000. Let the data of the first node is 10, data of the second node is 20, data of the third node is 30. Here the next field contains address of the next node. So second node address is available in first node next field. Next to second node next field contains address of the third node. Whereas the last node next field contains address of the first node. So what is the address of the first node? 1000. So 1000 will be stored here. And head always points to the beginning of the circular linked list. Beginning of the circular linked list. So already a list is created. So for the list creation it is better to refer the previous video, my previous video. That is nothing but creation of a circular linked list. So let's see here. So initially we have to allocate memory for the node. Why? Because in this example our target is we want to insert the element at begin position. So let us allocate memory for the node. So in order to allocate memory for the node we are using new here. So this node contains two fields, data field and the next field. Let the address of the node is 4000. Address of the node is 4000. Next we have to store value in the data field. So store value here. So here after inserting the value at begin position, the output is 40, 10 and 20, 30 is the output here. So here we need to establish a link from the last node next field to the new node. So we have to place temp at the last node. So here for traversing from one node to the another node we are using temp. Initially we need to place temp at head location. So place temp at head location. So temp is equal to head. Next we have to traverse temp till we get the last node. So for that purpose in each node we have to check whether its next field is not equals to head or not. if the node's next field is equals to head, then we can say that it is nothing but the last node. So for that the condition is while temp arrow next not equal to head, then temp is equal to temp arrow next. So initially temp is at 1000 location. So what is 1000 next? 2000. So 2000 is not equal to head. Head means 1000. So 2000 is not equal to 1000. So condition is true. So the body will be executed. So what is temp? 1000. 1000 next means 2000. So temp will be placed at 2000 memory location. Next once again condition will be evaluated. So temp means 2000. 2000 next means 3000. So 3000 is not equal to 1000. 3000 is not equal to 1000. So condition is true. So temp is equal to temp arrow next. So temp means 2000. So 2000 next means 3000. So temp will be placed at 3000 memory location. Next temp means 3000. 3000 next means 1000. 1000 is not equal to head means 1000. So 1000 is not equal to 1000. So condition is false. So the control comes out from the while loop. So we can say that this is the last node of the circular linked list. So what we have to do now, in a circular linked list, the last node next field contains address of the first node. Address of the first node. So what is the address of the first node? 4000. So here we have to place 4000. So if you place 4000 here, then this link will be broken and a new link will be formed like this. Okay. So simply we can write the statement as temp arrow next is equal to new. But before that we have to allocate memory for the node. So in order to allocate the memory for the node, we are writing the statement new is equal to struct node star. For typecasting we are using this statement. Why? Because malloc function doesn't return any value. So malloc of size of struct node. So memory is allocated. Memory is allocated for the new node. Now we establish the connection. Okay. So temp arrow next is equal to new. Temp arrow next is equal to new. Next what we have to do? We have to store a value in new node's data field. So this is nothing but data field. So before that read value, printf enter a value, printf enter a value. So scanf %d comma ampersand value. Scanf %d comma ampersand value. So first what we have to do? We have to store value in new node's data field. New node's data field. So 40 will be stored here. Then after that we need to establish a connection from new node to the head node. So we have to store 1000 here, because in each node the next field contains address of the next node. So store 1000 here, so that a link will be established from first node to the next node. So we can write the statement as new arrow next is equal to head. Next head always points to the beginning of the circular linked list. So we have to place head at 4000 memory location. So 4000 is nothing but new. So head is equal to new. So in this way we can insert an element into the circular linked list at end position. So what are the steps we are doing? Initially we have to place temp at beginning of the circular linked list, and we have to move temp till we get the last node, and then establish a connection from this temp next field to new. That means store new address in temp's next field. Next store value in data field. Next store the address of the head in new node's next field. Next place head at new. So it is very easy to write the code if we draw the diagram correctly. Now let's see the next case. The next case is inserting an element into the circular linked list at end position. So now let's insert an element into the circular linked list at end position. Here we have three nodes. First node data 10, second node data 20, third node data 30. First node address 1000, second node address 2000, third node address 3000. First node next field contains second node address. Second node next field contains third node address. Whereas the last node next field contains address of the first node. Head always points to the beginning of the circular linked list. So in this example our target is we have to insert an element into the circular linked list at n position. So for the allocation of the memory we are using new. So first we allocate the memory for the node. So let address of the node is 4000. So here we have data field and this is nothing but next field. And simply establish a connection from the last node next field to new node and store address of the head node in new node's next field. So those two activities we have to do. So for that purpose what we have to do is initially we have to place temp at head location and we need to move temp till we get the last node. So already we have written that code in the previous one. That is nothing but inserting the node at beginning position. So temp is equal to head, and next the condition is while temp arrow next not is equal to head, while temp arrow next not is equal to head, then temp is equal to temp arrow next, temp is equal to temp arrow next. So initially temp is at head location, that is nothing but 1000. So what is 1000 next? 2000. So 2000 is not equal to 1000. Condition is true. So body will be executed. Temp is equal to temp arrow next. So temp means 1000. 1000 next means 2000. So temp will be placed at 2000 memory location. So once again condition will be evaluated. So temp means 2000. 2000 next means 3000. 3000 is not equal to 1000. So condition is true. So temp is equal to temp arrow next. So 2000 next means 3000. So temp will be placed at 3000. Next once again condition will be evaluated. So temp means 3000. So 3000 next means 1000. So 1000 is not equal to 1000. Condition is false. So control comes out from the while loop. So we can say that this is the last node of the circular linked list. So initially we have to allocate memory for the node. So allocate memory for the node. So new is equal to struct node star malloc of size of struct node. So allocation of the memory is over. So next what we have to do, we have to establish a connection from this node to the last node. So for that purpose we have to store this 4000 here. So if we store 4000 here, then a link will be formed from this node to this node and this link will be broken. So how to write this statement? The name of this node is new, this field is next. So temp arrow next is equal to, so this is nothing but new. So temp arrow next is equal to new. Temp arrow next is equal to new. So what is new? 4000. So 4000 will be stored here. Next we have to store a value in data field. So before that it is better to read a value. So printf enter a value. Printf enter a value. Next scanf %d comma ampersand value. So next insert value in data field. So let the value is 40. So insert value here. So we can write the statement as new arrow data is equal to value. So next what we have to do, after inserting the element into the list at n position, this node will becomes the last node. The last node next field contains address of the first node. What is the address of the first node? 1000. So we have to store 1000 here. If we store 1000 here, then a link will be formed like this. A link will be formed and this link is already broken. So how to write this statement? So name of the node is new arrow, field is next, new arrow next is equal to 1000 is nothing but head address, head. So new arrow next is equal to head. So everything is over. A link is formed from the last node to the new node, as well as the last node next field contains address of the first node. Okay. So it is very easy to write the code if you draw the diagram correctly. So in this way we can insert an element into the list at n position. Now let's see how we can perform insertion at specified position. So now let us perform insertion operation at specified position. Here our circular linked list mainly contains 4 nodes. So first node, second node, third node and fourth node. The last node next field contains address of the first node. So let us assume that here the position is second position and the element is 222. So we want to insert 222 at the second position. let this element is position 0. So let it be position 1. So it is the second position. So after inserting the element at second position, the output is 10, 20. So what is the value we are inserting? 222. So 10, 20, 222, 30 and 40 is the output here. Okay. So for that we have to write the code here. So at which position we have to insert? At second position. So what we have to do is initially we have to take a variable called temp, place temp at head position, and we are inserting the element at second position. So we need to traverse temp till we get the first position. So we have to place temp here. So for that purpose we have to use a for loop. For loop, let us write the code first. So what we have to do? Initially place temp at head position. Next, what are the input variables? Enter the position at which the element is inserted, enter the value. So we have two inputs, position as well as value. So let us assume that those two are already readed. So next what we have to do? We have to use a for loop. For I is equal to 0, I less than, let's see the condition, POS I plus plus, temp is equal to temp arrow next. Temp is equal to temp arrow next. So for I is equal to 0, next I less than position. What is position? 2. So 0 is less than 2. Condition is true. So temp is equal to temp arrow next. So what is temp? 1000. So 1000 next means 2000. So temp will be stored at 2000 memory location. Next I plus plus 1. 1 is less than 2. Condition is true. So what will happen? One more time temp will be moved to its next position. But here our target is we need to place temp at position 1. So here we can write the condition as 0 less than POS minus 1. 0 less than POS minus 1. So 0 is less than 1. Okay. So 0 less than 1 condition is true. So temp is placed at 2000 memory location. 1 less than 1 condition is false. So control comes out from the for loop. So now temp is at the position 1, this position. So now we have to insert the element at the second position. So for that purpose, allocate the memory using new. So let address of the node is 5000. Next we have to read a value. Already value is read. So store 222 here. Next we have to establish two links here. This link as well as this link. So we have to establish two links, this link as well as this link. So which link we have to establish? If we establish this link first, then what will happen? In place of 3000, 5000 will be stored. If we store 5000 here, then it is not possible to get 3000 address. Why? Because we are getting 3000 by using this temp next field. So what we have to do is initially we have to establish this link, and after that establish this link. If we establish this link first, then what will happen? In place of 3000, 5000 will be stored. If we store 5000 here, then this link will be broken. So it is not possible to maintain a connection from new next to this node. So first establish this link. Okay. So before that, allocate the memory. So new is equal to struct node star, new is equal to struct node star, malloc of size of struct node, size of struct node. So first store value in data field. So we can write it as new arrow data is equal to value. So first we have to establish this connection. So store 3000 in news next field, because this is the 0th position, first position, second position, and after that we have to display 30 and 40 also. So what is the statement here? New next is equal to, new next is equal to. So how to get 3000 here? Temp means 2000, 2000 next means 3000, temp means 2000, 2000 next means 3000. So new arrow next is equal to temp arrow next. So what is temp? 2000, 2000 next means 3000. So store 3000 in new next field, so that a link will be established like this. Next, what is the second one? Establish a connection from this position 1 node to the new node. So temp arrow next is equal to, temp arrow next is equal to, we have to store new here. So what is new? 5000. So if you store 5000, then a link will be formed like this. Okay. So here inserting the element into the list at specified position is similar to single linked list insertion at specified position. Okay. So in this way we can perform insertion operation at begin position, specified position and end position. In the next class we will see how we can perform deletion operations. Now let's see about deleting a node from circular linked list. We can delete a node from circular linked list in three cases. First one at begin position, second one at end position, third one at a specified position. So let's see the first case at begin position. This is a circular linked list which contains totally 4 nodes. We know that in a circular linked list each node contains 2 fields, data field and next field. Data field contains data of the node, whereas next field contains address of the next node. So data of this node is 10, data of this node 20, 30, 40, and this next field contains address of the next node. So 2000 is available in first node next field. Next to second node next field contains address of the third node. Third node next field contains address of the fourth node. Whereas the last node next field contains address of the starting node. So here address of the starting node is 1000. So we need to place 1000 in the last node next field. We know that here we use a node called head. Head always points to the beginning node. So a circular linked list is already created with these 4 nodes. So for creation purpose, please refer previous video, circular linked list creation and display video. So let us perform the deletion at beginning position here. So here after deleting the first node, the output is 10. So here we are deleting 10th element. So after deleting 10th, the output is 20, 30 and 40 is the output. We know that in a circular linked list, the last node next field contains address of the first node. But after deleting this node will becomes the first node. So we need to store 2000 in address of the last node. So for that purpose we need to declare, we need to use a temporary variable, and we need to place that temporary variable at the last node location. So let us assume that we are using a variable called temp. So this is nothing but a temporary variable. So by using this temporary structure variable, we can traverse from one node to the another node. Okay. So here the first statement is we need to place temp at head location. So temp is equal to head. So temp will be placed at head. Head means 1000. So temp will be placed at 1000 memory location. Then after that we need to move temp till we get the last node. So for that purpose, in each node next field, we have to check whether it is starting address or not. So if the node next field contains starting address, then we can say that it is the last node. Okay. Why? Because if we consider the last node, so this node next field is 1000. So 1000 is nothing but starting address. So we can say that this is the last node. Okay. So for that purpose, we have to write a while loop. While. So in each node, we have to check whether its next field is starting address or not. Starting address is denoted by head. So while temp arrow next is not is equal to head. So if it is not the last node, then move temp one position to its right. So temp is equal to temp arrow next. Temp is equal to temp arrow next. So let us trace this one. So while what is temp? 1000. 1000 next means 2000. So 2000 is not is equal to head means 1000. So 2000 is not is equal to 1000. Condition is true. So temp is equal to temp arrow next. So this temp means 1000. 1000 next means 2000. So temp will becomes 2000 now. So once again condition will be evaluated. Why temp means 2000? 2000 next means 3000. So 3000 is not is equal to 1000. Condition is true. So temp is equal to temp arrow next. So temp means 2000. 2000 next means 3000. So this is nothing but 3000. So temp will be placed at 3000 location. So once again condition will be checked. So temp means 3000. 3000 next means 4000. So 4000 is not is equal to 1000. Yeah, condition is true. 4000 is not equal to 1000. Condition is true. So temp is equal to temp arrow next. So temp means 3000. 3000 next means 4000. So temp will be placed at 4000 memory location. So once again condition will be checked. So temp means 4000. 4000 next means 1000. So 1000 is not is equal to 1000. 1000 is not is equal to 1000. Condition is false. So the control comes out from the while loop. So now temp is at this location. Okay. So what is that location? The last location. Okay. And now we are deleting this node here. So what we have to do is we need to declare one more structure variable, that is D. So we can declare it as struct. Let the name of the structure is node. So struct to node star D. So D stands for some deleted node. So D is equal to, we have to place it at head location. So now where is temp? So temp is at the last location. So temp is at the last location. So now we are placing D at this location. Now display the value printf /n deleted node is, so we have to display deleted node data. So deleted node is, so that is nothing but an initial value %d comma. So what is the node location? It may be either head or D. It is our choice. I am writing it as some head arrow data. So this will be printed. Deleted node is 10. So but after deleting that node, this node will become the first node. So we have to traverse head to its next location. So that can be done with the help of head is equal to head arrow next. Head is equal to head arrow next. So what is head? 1000. 1000 next means 2000. So head will be placed at 2000 location now. Now there is no need of this node. Before that, it is better to establish the connection here. Temp arrow next is equal to the last node next field contains address of the first node. But we are deleting this node. So this node will becomes the first node now. So temp arrow next is equal to head. So what is head? 2000. So we need to store 2000 in temp next field. So whenever we store 2000 here, then this link will be broken and a new link will be formed from the last node to first node like this. Okay. Then after that, there is no need of this node. So here break this connection. So D arrow next is equal to null. So whenever we place null here, then this connection will be broken. And after that, there is no need of this memory. So use free function so that the memory will be destroyed for D. We can use this memory for allocating some other variable. Okay. So in this way, we can delete a node from the circular linked list at the beginning position. So here, what we are doing here, initially we have to place temp at starting node, and we need to move temp until we get the last node. Then after that, move head one position to its right. Why? Because we are deleting the first node, and then store address of the head in the last node next field. If we want, we can place null here so that this link will be broken, as well as destroy this node memory. So in this way, we can delete a node from circular linked list at the beginning position. Now let's see how we can perform deletion at end position. Now let's see how we can perform deletion operation from circular linked list at end position. So let us assume that our circular linked list contains totally 4 nodes. So in this example, our target is we want to delete a node from the circular linked list at end position. So we have to delete 40 from the circular linked list. So this node, that means the last but one node, this node will becomes the last node. So we need to store address of the first node in this node last field. So for that purpose, initially we have to take a variable called temp. Here we are using temp for traversing from one node to the another node. Initially we need to place temp at head position, and we have to traverse the temp till we get the last but one node. So from each node we have to check whether its next node is not equals to the start or not. If it is not equals to start, then we can say that it is not the last but one node. So we can traverse the temp. So traversing the temp will be done until we get the last but one node. Okay. So let us write the code. So initially we have to place temp at head location. So here the first statement is temp is equal to head. So what is head? 1000. So temp will be placed at 1000 location. Then after that, from each node we have to check whether its next field is not equals to head or not. Not equals to head or not. If it is not equals to head, then we can say that it is not the last but one node. So move temp one position to its right. So temp is equal to temp arrow next. So whenever the condition is false, then we can say that that node is the last but one node. So let us trace this one. So here temp means 1000, 1000 next means 2000. So this 1000 next we gives 2000. Next to 2000 next means 3000. Okay. So temp arrow next means 3000. So 3000 is not is equal to 1000. 3000 is not is equal to 1000. Yeah, condition is true. So this body will be executed. So temp is equal to temp arrow next. So temp means 1000, 1000 next means 2000. So this is nothing but 2000. So now temp will be placed at 2000 memory location. So once again the condition will be evaluated. This temp means 2000. 2000 next means 3000. 3000 next means 4000. 4000 is not is equal to 1000. Condition is true. So temp is equal to temp arrow next. So what is temp? 2000. 2000 next means 3000. So temp will be placed at 3000 now. Temp will be placed at 3000 now. Next, once again condition will be evaluated. So this temp means 3000. 3000 next means 4000. Next to 4000 next means 1000. So temp arrow next will give 1000. So 1000 is not is equal to 1000. So what is 1000 here? What is head? 1000. So 1000 is not is equal to 1000. Condition is false. Condition is false. So the control comes out from the value. Okay. So the control comes out from the value. Okay. So this is nothing but the deleted node. So let us take a variable called d. D stands for deleted node. So let us write as d is equal to temp arrow next. Why? Because here we want to delete the last node. So what is temp now? 3000. 3000 next means 4000. So d will be placed at 4000. So now what we have to do now? Here we have to delete this node. So before delete that node, it is better to store address of the first node in the last but one node next field. Because after deleting this node will becomes the last node. So we can write here as temp arrow next is equal to store address of the first node. So what is the address of the first node? Head. So temp arrow next is equal to head. So what is temp? 3000. So in 3000 next store head. Head means 1000. So if you store 1000 here, then this link will be broken and a link will be formed like this. Okay, this link is also broken. Okay. So next what we have to do? Here we need to print this data also. So print the data, printf slash deleted node is. So which node we want to delete? The last node. So what is the name of the last node? D. So D arrow data. D arrow data. So what is D data? 40 will be printed. Then after that we need to place null here. If you place null here, then this connection will be broken. So D arrow next is equal to null. So place null here. So if you place null, then this link will be broken. Next, there is no need of this memory. So destroy the memory. So destroying the memory is done with the help of free function. So free of t. So in this way, we can delete a node from the circular linked list at n position. So here the logic is very simple. Initially we need to place temp at the starting node. Okay. Then after that we need to traverse the temp till we get the last but one node. And then store address of the first node in the last but one node next field. Then automatically this node will becomes the last node. Okay. If you want, we can declare a variable called d. D stands for deleted node. Place null here and display the data and as well as destroy the memory. These three are optional here. Okay. Displaying the data, d arrow next is equal to null free of d. It is optional. Okay. These three are not compulsory statement. Without writing these three statements also, with the help of the display function, we can display the output as 10, 20, 30. Because after deleting this node, what is the output? 10, 20, 30 is the output. So in this way, we can perform deletion operation at n position. Now let's see how we can perform deletion operation at a specified position. Now let's see how to perform deletion operation from circular linked list at a specified position. So let our circular linked list contains 5 nodes. We know that here each node contains some data field and next field, and the last node next field contains address of the first node. Okay, let here the position is so 0, 1, 2, 3. Let the position is 3 here. So we want to delete the third position node from the circular linked list. Let it be position 0, position 1, position 2, position 3. So we want to delete this 40 from the circular node. So after deleting 40 from the circular linked list, the output is 10, 20, 30 and 50 is the output. Okay. So initially we need to declare a variable called temp. Here we are using temp for traversing from one node to the another node. Initially place temp at head position, and we have to traverse temp till we get second position. Why? Because we want to delete the third position node. So we need to traverse temp till we get 3000. So temp will be at 3000. Here deletion means we should not delete this node physically. Simply we need to store address of the last node in this node position. So instead of 4000 we need to store 5000. So if we store 5000 here, then what will happen? A link will be established from this node to the last node, and automatically these links will be broken. Okay. So that is the code we have to write. So initially we need to place temp at head position. So the statement is temp is equal to head. Then after that, here what is the extra input here? Position. So read that one also. Printf enter the position at which the element is deleted. Next, scanf %d comma POS. Scanf %d comma ampersand POS. That the position here is 3. Then after that, use a for loop for traversing the temp from one node to the other node. Here write the for loop as for I is equal to 0, I less than POS minus 1, I plus plus, temp is equal to temp arrow next. Temp is equal to temp arrow next. So what is I? 0. So 0 is less than position minus 1. So 0 is less than position means 3. So 3 minus 1 means 2. So 0 is less than 2. Condition is 2. So body will be executed. So temp is equal to temp arrow next. So temp means 1000. 1000 next means 2000. So temp will be placed at 2000 now. So temp will be placed at 2000 now. Next, once again, I plus plus, I becomes 1. 1 less than 2. Condition is 2. So temp is equal to temp arrow next. So temp means 2000. 2000 next means 3000. So temp will be placed at 3000 now. I plus plus, I becomes 2. 2 is less than 2. Condition is false. So we can say that temp is at position 2. So what we have to do now? We need to delete this node. So for that purpose, let us take a node called D. D stands for deleted node. We need to place D at position 3. Temp means 3000. So 3000 next means 4000. So we can write as D is equal to temp arrow next. D is equal to temp arrow next. So what is temp? 3000. 3000 next means 4000. So D will be at 4000 location. Now what we have to do? In place of 4000 we need to store 5000. Why? Because we are deleting this node. So how we can write that statement? So this is nothing but temp next. So temp arrow next is equal to temp arrow next is equal to, we have to store 5000. What is 5000? D means 4000. 4000 next means 5000. So we can write as D arrow next. So what is D? 4000. 4000 next means 5000. So what will happen now? D next will be stored in temp next. So what is D next? 5000. So store 5000 here. Then a link will be established like this. Then after that we have to destroy this memory. So before that, display the node. Printf deleted node is %d comma D arrow data. So what is D arrow data? 40. So 40 will be printed. Then after that, place null here, so that these links will be broken. That link will be broken. So D arrow next is equal to null. Then after that, there is no need of this memory now. So free the memory. So destroying the memory is done with the help of free function. So in this way, we can perform here this deletion operation at specified position. This is similar to the single linked list deletion specified position. Why? Because we know the difference between single linked list and circular linked list. In a single linked list, the last node next field contains null. whereas in a circular linked list, the last node next field contains address of the first node. So deleting the specified position in linked list as well as in circular linked list, both are same only. So with this deletion of a node from the circular linked list at beginning position, specified position and ending position is over. In the next video we will see double linked list. And now let's see about advantages and disadvantages of circular linked list. We know what is a circular linked list. It is a collection of nodes where each node contains data field and next field. Here data field contains some integer value or float value or character or some strings or some combinations, and the next field contains address of the next node. The major difference between single linked list and circular linked list is, in a single linked list the last node next field contains null, whereas in a circular linked list the last node next field contains address of the first node. Let's see the advantages of the circular linked list. The major advantage is we can eliminate extra code for some operations like deleting the last node. So we know that in a circular linked list the last node next field contains address of the first node. So we can perform deleting the last node operation very easily than single linked list. It requires limited code than deleting the last node in a single linked list. Why? Because in a circular linked list the last node next field contains address of the first node. So deleting the last node operation becomes quite easier than single linked list deleting the last node operation. And the second advantage is concatenating and splitting becomes more easy. So if we have two circular linked list, then concatenation will become very easy. Why? Because in a circular linked list the last node next field contains address of the first node. So we need to establish only two connections. So we have to establish a connection from the first node next field to the first link, the first list last node next field to the second list first node, as well as establish a connection from the second list last node next field to the first node. So we can say that the concatenation of two circular linked list, as well as if you want to split a circular linked list, it also becomes very easily. Okay. And let's see the disadvantages of circular linked list. The first disadvantage is there is a possibility to get into infinite loop. If you write the condition as while temp not equal to null or temp arrow next not equal to null, then the control will goes into infinite loop. Why? Because in a circular linked list the last node next field always contains address of the first node. So we should not have null in the last node next field. So that's why there is a possibility, if you write null as the condition while temp not equal to null or temp arrow next not equal to null, then there is a possibility that the control may goes into infinite loop. Okay. And the second problem is it is not easy to reverse linked list. It is not easy to reverse a circular linked list. So reversing the double linked list is very easy. Why? Because we can go to the last node and with the help of the previous field we can move to its previous node, whereas in a single linked list as well as circular linked list previous field is not available. So it is very difficult to reverse a single linked list as well as a double linked list. So these are the various advantages and disadvantages. So what is the first advantage? We can eliminate some extra code while performing deleting the last node. Why? Because the last node next field contains address of the first node. And the second advantage is the concatenation of two circular linked list as well as splitting a circular linked list becomes very easy. Okay. And the problems are, the first possibility is there is a problem that the control may goes into infinite loop. Why? Because in a circular linked list we don't have null. In single linked list and double linked list the last node next field contains null, whereas in circular linked list the last node next field contains address of the first node. So if you write the condition as while temp is not equal to null or temp arrow next is not equal to null, then the control goes into infinite loop. And the second problem is reversing the circular linked list operation is very difficult than double linked list. Okay. So these are the various advantages and disadvantages of circular linked list. Now let's see about double linked list. A double linked list is a collection of nodes where each node contains three fields. The first field is previous field, the second field is data field, and the third field is next field. Previous field contains address of the previous node, data field contains data of the node, next field contains address of the next node. In a double linked list, the first node previous field and the last node next field contains null. Now let's see the diagrammatic representation of a double linked list. So this is the diagrammatic representation where each node contains three fields. This field is previous field, this one is data field, and this field is next field. Let us assume that our double linked list contains three nodes. So previous field, data field, and next field. Let we have one more node. So previous field, data field, and next field. Let address of the first node is 1000, address of the second node is 2000, address of the third node is 3000. So this is nothing but previous field. So before this node, this is nothing but starting node. So before this node we don't have any value. So the first node previous field is null. Let the data of the first node is 10, data of the second node is 20, data of the third node is 30. Next, this next field contains address of the next node. So the next node address is 2000. So whenever we place 2000 here, then a link will be established from the first node to the second node like this. Okay. Next, this node. Let us consider the second node. This is nothing but previous field. So this previous field contains address of the previous node. So what is the address of its previous node? 1000. So whenever we store 1000 here, then a link will be formed from each node to its previous node like this. Then after that, this is nothing but the next field of the second node. So the next field contains address of the next node. So what is the address of the next node? 3000. So we need to store 3000 here. Then a link will be formed from second node to the last node like this. Second node to the third node. Next, this is nothing but previous field of this node. So this previous field contains address of the previous node. So we have to store 2000 here because 2000 is address of its previous node. So whenever we place 2000, then a link will be formed from last node to its previous node. And after this node we don't have any other node. So the last node next field contains null. So we can say that a double linked list is a collection of nodes. Here we have three nodes where each node contains three fields: previous field, data field, next field. Previous field contains address of the previous node, data field contains data of the node, next field contains address of the next node. In a double linked list, the first node previous field and the last node next field contains null values. And here, so this is nothing but double linked list here. We can perform various operations on the double linked list: create operation, print operation, printing or displaying or traversing, next insertion at beginning position, specified position, ending position, next deletion at begin position, specified position and end position, reversing. Likewise we can perform various operations on the double linked list. Now in this video, let's see how we can perform creation operation and display operation. In the upcoming videos we will see other operations like insertion, deletion and reversal and reverse. Okay. So now first let us perform create operation. So creating a double linked list. Creating a double linked list. So create operation. Here the node declaration is like this. So struct a node, struct a node. Here our node contains different data type elements. It contains some integer values, some addresses. So it is better to declare it as a structure. Why? Because structure contains a collection of different data type elements. It stores integer values, float values. So likewise, so for that purpose we are declaring it as a structure. So the syntax for defining a structure is struct space structure name. So here the first field is previous field. So struct node star pre. So this is nothing but a self-referential structure. Self-referential structure means a structure which contains a pointer to itself. So that structure contains a pointer. That node contains an address, but that address points to the same structure only. And the next field is data field. And the next field is next field. So struct node self-referential structure star next. Next here we need to have three structure variables: star new, star temp, star head. So this is nothing but our node representation. So with the help of previous field, we can store address of the previous node. With the help of the data field, we can store data of the corresponding node. With the help of this next field, we can store address of the next node. And we have taken three structure variables: new, head and temp. New for allocation of the memory, temp for traversing from one node to the another node, head always points to the beginning of the circular, beginning of the corresponding double linked list. So here first we have to allocate the memory. So in order to allocate the memory, we use new. So first we need to allocate the memory. So allocate the memory first. So that node contains how many fields? 3 fields. So let address of the node is 1000. Next node name is new. So first we need to place null here because we don't have any other previous node initially. Next read a value and store the value in data field. Let the data of the first node is 10. Next to store null in new node's next field. So first we have to do this activity. Okay, allocate the memory for the node, store null in previous field as well as next field, and store value in data field. Okay, so let us write that code first. So do, here we have to perform the repetition as long as we entered y. If we entered other than y, then we can say that our list is over. So for repetition purpose, here our list contains more than one node. So for repetition purpose, we are using do while loop. So do. So first we allocate the memory. So new is equal to. So this is nothing but typecasting. Struct to node asterisk malloc of size of by using malloc function we are allocating the memory. So size of we allocate the memory here. Size of we allocate the memory depends upon the size of the corresponding data type. If the integer size is 2 bytes, then 2 bytes of memory will be allocated for data. If it has some floating point value, if float size is 4 bytes, then 4 bytes of memory will be allocated. So size of struct to node. So allocation of the memory is over. Then after that we have to store null in previous field. So new arrow prev is equal to null. Then after that we need to read a value. Printf enter a value. Printf enter a value. Next to scanf %d comma ampersand value. So next what we have to do? We have to store value in new data field. So new arrow data is equal to value. So let the value is 10. So 10 is stored there. Next we have to store next null in new next field. So new arrow next is equal to null. So null is to be stored in new next field. Then after that we have two cases. If the list is empty or if the list is not empty. So the first case is if the list is empty. Second case is if the list is not empty. So when we can say that the list is empty, if head is equal to null, then we can say that the list is empty. Why? Because in a double linked list or circular or in a linked list, in a single linked list, head always points to the first node. That means head should contain address of the first node. That is nothing but head should contain 1000. If head is null, then we can say that the list is empty. Suppose if the list is empty, then what we have to do is we have to place temp and head at the first node. That is nothing but new. So initially the initial value of the head is null. Why? Because this node structure is to be defined on top of the main function. Because in our program we may implement several functions like create function, print function, insertion at beginning specified, deletion at beginning specified, ending position, deletion, next to counting, reversing. Likewise we can implement a number of operations. In all the operations we need to have we need to use this structure node definition. So that's why this structure should be defined on top of the main function. Then these structure variables will become global structure variables. If there are global structure variables, then the default initial values are null. So by default null will be stored in head, temp and new. Okay. So initially head is null. So if head is null, then what we have to do? If head is null, then we can say that our list is empty. So we need to place head and temp at new location. So that is the code we have to write. So if head double is equal to null, so initially head value is null. So we need to place head and temp at new location. So head is equal to new, temp is equal to new. So initially head is null, so head is placed at new, that is nothing but 1000 location, as well as temp is placed at the new, that is nothing but 1000 memory location. Okay, and let us create one more node now. So what we have to do? So allocate memory for the node. So new. So now new will be at 2000 address. Why? Because in a variable we can store only one value. So next what we have to do? Allocation of the memory is over. Next read a value. Let the value is 20. Next what we have to do? We have to store null in previous field. Next to store value in data field. Let the value is 20. Next to store null in the next field. Next to store null in the next field. So again we have to check whether our list is empty or not. If the list is empty, then we need to place head and temp at the starting node location. That is nothing but new location. But here the list is not empty. Why? Because what is head? What is head? Head is at 1000 location. 1000 double is equal to null. 1000 double is equal to null. Condition is false. So we can say that our list is not empty. Already a list is created. Okay. So what we have to do now? We have to make this list as a double linked list. So what we have to do is very simple. So in a double linked list, what we have this next field contains address of the next node. So what is the address of the next node? So this node will become the address of the next node. So what is the statement we have to write now? Head arrow next is equal to new, or temp arrow next is equal to new. Here, in order to establish the connections, always we need to use temp only. Why? Because after creating the second node, let us assume that one more node is created. Then we have to establish the connection from second node to the third node. But here we should not change head. Head always points to the address of the first node. That means head will always be 1000 only. We should not change head. So that's why we need to establish the connection with the help of temp, not with the help of the head. From third node to fourth node, we need to establish the connection. Temp will be at the third node, whereas head is at first node only. But we need to maintain some connections between third node to the fourth node. So in order to establish the connections, we have to make use of the temp here. So place null here, place 2000 here. So if you place 2000, then what will happen? A link will be established like this. So how to write that code? We need to use temp. So temp arrow next is equal to. So what is 2000? So 2000 is nothing but new. So temp arrow next is equal to new. Okay. So next what we have to do? In a circular linked list, each node previous field contains address of the previous node. So new arrow pre is equal to address of its previous node means head or temp. Temp only. We should not use head. So what is the statement? New arrow pre is equal to temp. New arrow pre is equal to temp. So what is temp? 1000. So we need to store 1000 here. Then what will happen? A link will be formed from new node to its previous node, that is nothing but temp. Next what we have to do? So this node, the second node creation is over. So we have to move temp one position to its right. So we can write the statement as temp is equal to temp arrow next. Why? Because what is 1000 next to 2000? Or we can write as temp is equal to new. Or we can write as temp is equal to new. Temp is equal to new. So what is the statement? Temp is equal to new is nothing but the third statement. So temp is equal to new. So temp is equal to new. So what will happen now? Temp will be placed at new position. So now temp means 2000. Okay. Next we can enter n number of nodes here. So we can write as some printf statement. Printf, do you want to add one more node? Do you want to add one more node to the list? One more node to the list. So we need to enter either y or n. So y specifies yes, n specifies no. So f flush of stdio. F flush means it is useful for clearing the buffer. before reading any character, we have to clear the buffer in turbo C. So if you are working with turbo C, then before reading the character, we have to use a flush function. Whereas if we are working on Linux operating system, then there is no need of a flush function. Scanf %c comma. We need to declare a variable called ch. It is of type character. So char ch. So we have to repeat the loop as long as we enter 5. So while ch double is equal to y. Okay. So second node creation is over. So this statement will be executed. Printf, do you want to add one more node to the list? Let us assume that we entered y. So scanf %c comma &ch. Now ch contains y. So while y double is equal to y double is equal to y, condition is true. So one more time the body will be executed. Okay. So what will happen? Memory allocation will be done now. So allocate the memory for new. Allocate the memory for new. So this is nothing but new. So let the address of this one is 3000. Next, new arrow pre is equal to null. So now store null here. Next, read a value. Let the value is 20. Next, store value in data field. Store value in data field. So 30 is stored here. Next, store null in next field. So store null in next field. Next, we have to check whether the list is empty or not. If head double is equal to null. But what is head? 1000. 1000 double is equal to null. Condition is false. So S block will be executed. What is the first statement? Temp arrow next is equal to new. Temp arrow next is equal to new. So what is new? 3000. So here we need to store 3000. Then a link will be established from temp to new. Next statement, new arrow pre is equal to temp. So what is temp? 2000. So in new previous field we need to store 2000. Then a link will be formed from new node to its previous node. That is nothing but temp. Next statement, temp is equal to new. So what will happen now? Temp will be placed at new location. So what is new? 3000. Next, do you want to add one more node to the list? Let we have entered n. So now ch contains n. N double is equal to y. Condition is false. So the control comes out from the do while loop. So now our double linked list contains 3 nodes. Okay. Now let's perform displaying or printing or traversing operation. Now let's see display or printing or traversing operation. So traversing or displaying means visiting the nodes of the list and displaying those nodes. Let our double linked list contains 3 nodes. Let we have 3 nodes like this. Here each node contains 3 fields. Let address of the first node is 1000, address of the second node 2000, address of third node 3000. Let data of the first node 10, data of the second node 20, data of the third node 30. This previous field contains address of the previous node. Here this is the first node. So before this node we don't have any other node. So null. Next, this next field contains address of the next node. So 2000 is its next node address. So if we store 2000 here, then a link will be formed like this. Next, this node previous field contains address of the previous node. So we have to store 1000 here. Then a link will be formed like this. Next field contains address of the next node 3000. Next previous field contains address of the previous node 2000. Last node next field. After this node we don't have any other node. So it contains 10. So now after displaying the output is like this: 10, some double arrow, 20, double arrow, 30 like this. So 10, left arrow, some minus, right arrow. So it specifies it is a double linked list. It contains previous field as well as next field. This previous field contains address of the previous node. This next field contains address of the next node. Next to 20 and 30. So we need to display the output like this. Initially head is at the first node starting position, the linked list starting position. That is nothing but initially head is at 1000. So we need to place temp at head position. Here the logic is very simple. We have to place temp at some head location. So we know that head always points to the beginning of the list. If it is not equals to null, if its address is not equals to null, then display the value and move temp one position to its right. So temp is equal to head. So initially temp is at 1000 location. Then after that we have to check whether it is not equals to null or not. While temp is not equals to null. If it is not equals to null, then display the value printf percentage d. Then after that some lefty arrow less than symbol minus greater than symbol, temp arrow data. Next move temp one position to its right. So temp is equal to temp arrow next. So temp is equal to head. So initially temp is at 1000 location. Next while temp not is equal to null. So what is temp? 1000. So 1000 is not equal to null. Condition is true. So printf percentage d arrow. So percentage, what is percentage d? Temp arrow data. So what is temp arrow data? 10. So now 10, after 10 we are displaying this symbol. So up to this is printed. Next temp is equal to temp arrow next. So temp means 1000. 1000 next means 2000. So now temp will be placed at 2000 memory location. So once again loop will be repeated. While temp not is equal to null, 2000 is not equal to null. Condition is true. So printf percentage d of this arrows, temp arrow data. So 2000 data means 20 will be printed, and after that this arrow will be printed. Okay, this arrow will be printed. So up to this is over. Next temp is equal to temp arrow next. So 2000 next means 3000. So now temp will be at 3000 memory location. So once again condition will be evaluated. 3000 is not equal to null. Condition is true. So what is temp data? 30 arrow. So this will be printed. Next temp is equal to temp arrow next. 3000 next means null. So now temp will be at null location. So once again condition will be checked. Null while temp not equal to null. But what is temp value? Null. Null not equal to null. Condition is false. So the control comes out from the while loop. So this is the output here. So in this way we can perform a creation operation and display operation. In the next video we will see how we can perform insertion operation in double linked list at begin position, end position and specified position. Now let's see about inserting a node in double linked list. In this class we will see about how we can perform insertion operation at begin position, end position and specified position. Initially let's see how we can perform insertion at beginning position. Let we have a double linked list with 3 nodes. We know that in a double linked list we can have a collection of nodes where each node contains 3 fields. Previous field, data field and next field. Previous field contains address of the previous node. Data field contains data of the node. Next field contains address of the next node. Okay. So this previous field contains address of the previous node. So before this node we don't have any other node. So this previous field is null now. Let the data of the first node is 10. Data of the second node is 20. Data of the third node is 20. Next field contains address of the next node. Its next node address is 2000. So store 2000 here. Next, this previous field contains address of the previous node. So store 1000 here. Then a link will be formed. Next, this next field contains address of the next node. So a link will be formed like this. This previous field contains address of the previous node. So if you store 3000 here, then a link will be formed like this. In a double linked list, the first node previous field and the last node next field contains null, and head points to the beginning of the double linked list. Head points to the beginning node of the double linked list. So a list is created already like this. For this creation purpose, it is better to refer my previous video, creation and printing of double linked list. So in this example our target is we want to insert the element at beginning position. So this is the beginning position. So at this position we want to insert the element. Let the name of the node is new. So first allocate memory for new node. So we have our node contains 3 fields. Let the address of this node is 4000. Next, before this node we don't have any other node. So place null here. Then after that read a value and store value in data field. Let the value is 40 here. So store 40 here. Next, after inserting the element at beginning position, so this will becomes the first node and this will becomes the second node. So we need to store 1000 here. So if we store 1000 here, then what will happen? A link will be formed from first node to the second node like this. Then after that, after inserting the element, this node will become the first node. So in place of this null, we need to store address of its previous node. So that is nothing but 4000. If you store 4000 here, then a link will be formed like this. Then move head to the new position. Why? Because head always points to the beginning position. So let us write that code here. So first we have to allocate the memory. So new is equal to struct node star. New is equal to struct node star malloc of size of struct node. Malloc of size of struct node. So allocation of the memory is over. So next what we have to do? New arrow prev is equal to null. So in previous field store null. Next we have to read a value. Printf enter a value. Printf enter a value. Next scanf %d comma ampersand value. So next store value in new data field. So new arrow data is equal to value. So here our node contains 3 fields. So our node is like this: struct node. Next it contains 3 fields: struct node, star prev, it contains address of the previous node. Next data field, it contains data of the node. Next struct node, star next, it contains address of the next node. So new arrow data is equal to value. Next new arrow next is equal to. So what is new next now? We have to store 1000. 1000 means head. So new arrow next is equal to head. So what is head? 1000. So if we store 1000 in new next, then a link will be formed from new to head like this. Next, after inserting the node, this node will become the second node. So now head previous field contains address of the first node. So what is 4000 new? So new means 4000. So 4000 is to be stored in head prev. So if 4000 is stored here, then a link will be formed like this from head to the new. After inserting the node, what will happen? This node will becomes the first node. So we have to place head at 4000. So head is, what is 4000? 4000 is nothing but new. So head is equal to new. So in this way we can perform insertion into double linked list at beginning position. Now let's see how we can perform insertion operation at end position. Now let's see how we can perform insertion operation in double linked list at end position. Here we have a double linked list with 3 nodes, and head points to the first node, that is nothing but head is at 1000 memory location. So in this example our target is we want to insert the node at end position. So let our node is new. So allocate the memory for new. We know that each node contains 3 fields. So this is nothing but previous field, data field and next field. Let address of the node is 4000. So first we have to allocate memory for the node. So next what we have to do here, after inserting the node, this node will become the last node. So this node will become the last buffer node. So we have to take a temporary variable called temp and initially place temp at the starting node and traverse the node and traverse the temp node till we get the last node. So for that, what is the logic here? In each node we have to check whether its next field is not equal to null or not. If its next field is not equals to null, then we can say that it is the last node. So traverse temp one position to its right. Suppose if its next field is equals to the null, then we can say that it is the last node. So we have to come out from the while loop now. Okay. So for that, write the logic. So temp is equal to head. So initially place temp at head position. Then after that, in each node we have to check whether its next field is not equal to null or not. If it is not equals to null, then we can say that it is not the last node. So move temp one position to the right. So temp is equal to temp arrow next. So whenever this condition is false, then we can say that temp is at our last position. So initially temp is at head, that is nothing but 1000. So 1000 next means 2000. So 2000 is not equal to null. So 2000 is not equal to null. So we can say that the condition is true. So temp is equal to temp arrow next. So temp means 1000. 1000 next means 2000. So temp will be placed at 2000 now. Next, once again condition will be evaluated. So temp means 2000. 2000 next means 3000. So 3000 is not equal to null. Condition is true. So temp is equal to temp arrow next. So temp means 2000. So 2000 next means 3000. So temp will be placed at 3000 now. Next, 3000 next means null. Null not is equal to null. Condition is false. So the control comes out from the while loop. So now where is temp? Temp is at 3000 memory location. Then after that we have to allocate the memory for the new. So we allocate the memory for the new. So new is equal to structure node star malloc of size of struct node. Malloc of size of struct node. Okay. So next what we have to do? So after inserting the node at n position, this node will becomes the last buffer node. So we have to store address of new in the last node next field. So in place of this null, we have to store 4000. Then a link will be formed like this. Right in dotted arrow, it specifies it is the new link. Then after that, this node will becomes the last node. The last node, this node previous field will become this 3000 now. So store 3000 here. So if you store 3000 here, then a link will be formed from last node to its previous node. Okay. So for that write the statements. So new arrow pre is equal to temp. So what is temp? 3000. So store 3000 in new pre. Okay. Store 3000 in new pre. Likewise here we have to write one more statement. Temp arrow next is equal to what is the statement? We have to store 4000 here. So what is 4000 new? So this is nothing but temp. So in 3000 next store new 4000. Next we have to store value here and store null here. So before that we have to read the value. So printf enter a value. Next scanf %d comma ampersand value. So store value in new data field. So new arrow data is equal to value. Next it will become the last node. Let the value here is 40. So store 40 here. This node will become the last node. So store null in new next field. So new arrow next is equal to null. So what is the logic we are doing here? Here our target is we want to insert an element at n position. So allocate memory for the new node. Next, initially we need to place temp at head position and traverse the temp till we get the last node. So now temp is at the last node. So store address of the new node in temp next. Next to store address of this temp in new previous. Store value in data field. Store next in null field. Store null in next field. So in this way we can perform insertion operation at n position. Now let's see how we can perform insertion operation at the specified position. Now let us perform insertion operation in double linked list at specified position. So let this list is already created with 4 nodes and head points to the first node. So that means head is at 1000 memory location. Let here the position is 3 and some the element is some 333. So we want to insert 333 at the position 3. So let it is 0th position, first position, second position. So we want to insert the element at the 3rd position like this. Okay. So after deleting 333 at the 3rd position, the output is 10, 20, 30, and after second position we want to insert the element 333. So 333 and 40. So here the output is 10, 20, 30, 333 and 40. So if you want to insert element at 3rd position, then we need to traverse temp till we get the second position. Why? Because we want to insert the element at the 3rd position. So initially we have to place temp at head position and we need to traverse the temp till we get the second position. So for that purpose we have to write the for loop. So temp is equal to head, and before that we need to read the position and the element. So printf enter the position, scan of %d comma ampersand POS. Printf enter the element, scan of %d comma ampersand element. So position is 3, element is 333. Okay. So already they are read. Next, for I is equal to 0, I less than POS minus 1, I plus plus temp is equal to temp arrow next. So for traversing we are using this for loop. So what is I value? 0. So 0 is less than position minus 1. Position is 3. So 3 minus 1 means 2. So 0 is less than 2. Condition is true. So body will be executed. So temp is equal to temp arrow next. So temp means 1000. 1000 next means 2000. So now temp will be placed at 2000 memory location. Next I plus plus, I becomes 1. 1 less than 2. Condition is true. So temp is equal to temp arrow next. Temp means 2000. 2000 next means 3000. So temp will be placed at 3000 now. Next I plus plus, I becomes 2. 2 less than 2. Condition is false. So the control comes out from the for loop. Okay. So next what we have to do now? Next we have to allocate memory for the new. That address here is 5000. So allocate the memory for new. So new is equal to struct node star malloc of size of struct node. Malloc of size of struct node. Okay. So allocation of the memory is over. So let address here is 5000. And next here we need to establish the connections here. So for that what we have to do is here we are inserting the element at the third position. So in this 4000 we have to store this 5000. Why? Because after this node we need to insert this element. So in place of this 4000 we have to store 5000. Next in place of here in new previous field we have to store 3000 here. Okay. So for that purpose we have to write the code here. So which connections we have to establish first? So if we establish these connections first, then what will happen is this 4000 will be lost. This link will be broken. So for that purpose what we have to do is we have to establish these connections first. We have to establish these connections first. After establishing these two connections, establish these connections. If we establish this connection first, then what will happen? Then temp arrow next is equal to new. What is new? 5000. So if we store 5000 here, then this link will be broken. So it is not possible to get 4000 now. Okay. Why? Because in new next we need to store this 4000. So for that purpose we have to establish these connections first. So this node will become first node, second node, third node, fourth node. So it will become the fourth node, and this node will become the fifth node. So here this next field contains address of the next node. So we have to store 4000 here. So if we store 4000 here, then a link will be formed like this. Okay. So this link will be broken. Then after that, after inserting this node will become the last node. This node will become the last node. So this node previous field is nothing but this node. So we have to store 5000 here. So if you store 5000 here, then what will happen? A link will be established like this. So the two statements are, what is the first statement? New arrow next is equal to, so what is this one? Temp. So 3000 next means 4000. So 4000, we have to store 4000 here. So new arrow next is equal to temp arrow next. So new means 5000. So 5000, in 5000 next we have to store temp next. So temp means 3000. 3000 next means 4000. So we have to store 4000 here. Then a link will be formed like this. Next statement, temp arrow next arrow prev is equal to new. So what is temp? 3000. 3000 next means 4000. So in 4000 previous field, store new. So store new. New means 5000. So if you store 5000 here, then a link will be formed like this. Then after that we have to establish these two connections now. Okay. So after inserting this node will become the fourth node. So here we have to store 5000. So here the statement is temp arrow next is equal to new. Next here it will become the third node. It will become the previous node. So here we need to store 3000. So the statement will become new arrow prev is equal to temp. So what is temp? 3000. So 3000 is to be stored in new pre. Okay. Next, here we have to store value. So already value is nothing but element. So already this value is read. So new arrow data is equal to value. So in this way we can perform insertion operation at specified position, begin position and end position. So here a specified position is somewhat complicated, but we need to remember only one thing here. If we establish these two connections first, then this link will be broken. So it is not possible to retrieve 4000. So first we need to establish these two connections, and after that establish these two connections. So in this way we can perform insertion operation. In the next video we will see how we can perform a deletion operation from double linked list at begin position, specified position and end position. Now let's see how we can delete a node from double linked list at begin position, specified position and end position. Initially let's see how we can perform deletion operation from the begin position. So our double linked list contains totally 3 nodes and head points to the beginning node. For creation purpose, it is better to refer my previous video, that is creation and printing of double linked list. Here we want to delete this node from the double linked list. So after deleting this node, the second node will become the first node. So for that we have to write the code here. So let's see how we can write the code here. So initially we have to place temp at head position, and so temp is equal to head. So temp will be at the 1000 memory location. Then after that display the corresponding value. So which node we are deleting? So printf deleted node is %d comma. So we are deleting this node. So we can write either head arrow data or temp arrow data. So what is head arrow data? Head means 1000. So 1000 data means 10. So 10 will be printed now. So after deleting this node, the second node will become the first node. So we have to traverse head one position to its right. So for that we can write as head is equal to head arrow next. Head is equal to head arrow next. So head means 1000. 1000 next means 2000. So head will be placed at 2000 memory location now. So next what we have to do? Here after deleting the first node, okay? After deleting the first node, then there is no other node before this node. So head previous should contain null now. So head arrow pre is equal to null. So we need to store null here. So if we store null, then this connection will be broken. And after deleting the first node, so no longer this node will be available. So store null here, so that this link will be broken, as well as destroy the memory. So temp arrow next is equal to null. Next destroy the memory for the temp. So the memory for the temporary node will be deleted. So in this way we can perform deletion operation at begin position. Now let's see how we can perform deletion operation at end position. Now let's see how we can delete a node from double linked list at end position. So let we have a double linked list with 3 nodes and head points to the first node, that is nothing but head is at 1000 location. So in this example our target is we want to delete this node. So if we want to delete the last node, then we need to place temp at the last but one position. So if you place temp at the last but one position, and then if you place null here, then automatically these links will be broken. So first we have to place temp at head position. So temp is equal to head. So temp will be placed at 1000 memory location. Then after that we have to traverse temp till we get the last but one node. So from each node we have to check whether its next node is not equals to null or not. If it is not equals to null, then we can say that it is not the last but one node. So while temp arrow next not equal to null, if this condition is true, then move temp one position to its right. So what is temp here? 1000. So 1000 next means 2000. 2000 next means 3000. So 3000 is not equal to null. Condition is true. So body will be executed. Temp is equal to temp arrow next. So temp means 1000. 1000 next means 2000. So temp will be placed at 2000 memory location. Next, once again body will be executed. Once again condition will be evaluated. So temp means 2000. 2000 next means 3000. 3000 next means null. Null not equal to null. Condition is false. So the control comes out from the while loop. So we can say that now the temp is at the last but one position. So which node we are deleting? We are deleting that node. So let us write now as D is equal to temp arrow next, where D stands for deleted node. So place D here. Okay. And then after that, what we have to do? Now we are deleting this node. So display that data. Printf deleted node is so which node we are deleting? Some integer value %d comma D arrow data. So 30 will be printed. Next, after deleting this node will becomes the last node. The last node next field always contains null. So place null here. So temp arrow next is equal to null. So if you place null here, then this link will be broken. As well as after deleting this node, so no longer this node will be available. So place null here, so that this link will be broken. So D arrow pre is equal to null. Now after deleting this node, there is no need of this node. So destroy the memory for this node. So free of D. So in this way we can perform deletion. Now let's see about deleting a node from double linked list at specified position. Let we have a double linked list with 4 nodes and head points to the first node. Let here the position is second position. So let it be 0th position, first position, second position. So we want to delete this node from the double linked list. So if we want to delete the third node from the double linked list, then we need to place temp at the second position. So initially we have to place temp at head position, and we have to traverse the temp till we get first position. Why? Because we want to delete the second position node from the double linked list. So here the first statement is temp is equal to head. So temp is placed at head. That is nothing but 1000 memory location. Next, for traversing, just we have to read the position. Let we have 2 statements like printf enter the position, scanf %d comma %pos. Here the position is 2. So for traversing the temp, use a for loop. For I is equal to 0, I less than position minus 1, I plus plus, temp is equal to temp arrow next. So initially the value of I is 0. So 0 is less than, position means 2. So 2 minus 1 means 1. So 0 is less than 1, condition is 2. So the body will be executed. Temp is equal to temp arrow next. Here temp means 1000, 1000 next means 2000. So temp will be placed at 2000 memory location. Next I plus plus, I becomes 1. 1 less than 1, condition is false. So the control comes out from the for loop. So in this example, our target is we want to delete this second position node. So that's why we place temp at position 1. So what is the deleted node here? This 3000 is nothing but deleted node address. Already temp contains 2000. So with the help of temp arrow next, we will get deleted node address. So D is equal to temp arrow next. So D is equal to temp means 2000. 2000 next means 3000. So D will be placed at 3000 memory location now. Next here we want to display this data also. So display the data. Printf deleted node is %d comma D arrow data. So now 30 will be displayed. Then after that, here there is no need to delete this node physically. In place of this temp arrow next, if you place the last node address, that is 4000, then automatically these connections will be broken. So here we need to store 4000 here. If you store 4000 here, then a link will be formed like this. Okay. So this statement can be written as temp arrow next is equal to. So we know D means 3000. So 3000 next will give 4000. So we can write as D arrow next. So in place of temp next, we have to store D next. So D means 3000. So 3000 next means 4000. So 4000 is stored there. Here we are deleting this node. If you delete this node, then what will happen? This node, previous node will become this temp node. So what is the address of the temp? 2000. So we have to store 2000 here. Then a link will be formed like this. So these links will be broken, as well as these links will be broken. So we can write that statement as so temp arrow, so we need to retrieve 4000. So how to get 4000? D arrow next, arrow, this is nothing but previous field. So arrow pre is equal to, so D means 3000, so 3000 next means 4000. So 4000 pre, in 4000 pre we need to store 2000, so temp. So if you store 2000 here, then link will be formed like this. Here there is no need of this previous field and this next field. So we can write as D arrow pre is equal to null. So here store null, so that this link will be broken. Next D arrow next is equal to null, so that this link will be broken. Now there is no need of this D, so destroy the memory with the help of free of D, so that we can use this memory for allocating the memory for some other variable. So in this way we can perform deletion operation from the double linked list at begin position, at end position, and at space. Now let's see about advantages and disadvantages of double linked list. We know what is a double linked list. A double linked list is a collection of nodes where each node contains three fields: previous field, data field, next field. Previous field contains address of the previous node, data field contains data of the node, next field contains address of the next node. Let's see the advantages of the double linked list. We can traverse in both directions, that is from starting to ending as well as from ending to starting, if you take single linked list, then we can traverse only from left to right. It is not possible to traverse from right to left. Why? Because in a single linked list we can have only next field. So with the help of next field, we can traverse from current node to the next node. We don't have previous field. Whereas if you take double linked list, we can have previous field as well as next field. So with the help of the previous field, we can traverse to its previous node also. So that is the first advantage of the double linked list. We can traverse from left to right as well as from right to left. If you take single linked list, then we can traverse only from left to right. Second advantage, it is easy to reverse the linked list. If you take single linked list, then it is very difficult to reverse the single linked list. Why? Because we know what is the single linked list. Let it be the single linked list. So first we have to place null here. Next we have to establish a connection from second node to the first node. Next we have to establish a connection like this. So it is very difficult to reverse the single linked list, whereas it is very easy to reverse the double linked list. Why? Because we can have previous field as well as next field. Okay. So with the help of the temp, we can easily go to the last node. So while temp is not equal to null, then temp is equal to temp arrow next. So whenever this condition is false, then temp will be at the last node. So simply we can display the data and move to the previous node. So temp is equal to temp arrow previous. So we can write the logic very easily if you take the double linked list. Whereas reversing the single linked list is very complex process. Next advantage, if we are at a particular node, then we can go to any other node. But in single linked list, it is not possible to reach to the previous node. If you take single linked list, then we don't have any previous node. So it is not possible to move from third node to the first node. If we want, we can move from first node to the third node. Why? Because we have next field. Suppose if the temp is at a particular node, then if we want to move to the third node, then we can write as temp arrow next. But let us assume that temp is at third node and I want to move to the first node. Is it possible? No, it's not possible. Why? Because in a single linked list, we don't have previous field. Whereas if we take double linked list, we can have previous field as well as next field. So from the third node, we can move to the first node very easily. Just like writing the statement temp arrow pre. So that is one more advantage of the double linked list. At a particular node, we can move to its next node as well as its previous nodes also. Whereas if you take single linked list or circular linked list, then we can move only to the next node. It is not possible to move to the previous node. Next, let's take the disadvantages of double linked list. The first disadvantage is it requires more space per the node because one extra field is required for pointer to the previous node. So if you take single linked list, then only two fields are sufficient, data field as well as next field. as well as if you take circular linked list, only two fields are sufficient, data field as well as next field. Whereas if you take double linked list, we require totally three fields. We need previous field, next field as well as data field. So we require three fields. So in order to store those three fields, we need to require much amount of memory. So that is the first problem with double linked list. For storing each node, we need to require much amount of memory than single linked list and circular linked list. Let's take the last advantage. Insertion and deletion take more time than single and circular linked list because one more pointer operations are required. So insertion and deletion operations are very complex in double linked list. Whereas if we take single or circular linked list, then we can have only two fields, data field and next field. So if we establish the connections for that means we need to store some value in data field as well as we need to store address in next field. Whereas if you take double linked list, we require three fields. So we have to establish the connections for previous field as well as next field, and we have to store value in data field. So insertion and deletion operations are little complex because more pointer operations are required for previous field as well as next field. Whereas if you take single linked list, then only two operations, storing the value in data field and establishing the connection from that current node to the next node is over. Whereas if you take double linked list, then we have to establish the connection to its previous node and its next node also. So these are the various advantages and disadvantages of double linked list. So the first advantage of the double linked list is we can traverse from left to right as well as from right to left. The second advantage of the double linked list is we can reverse the double linked list very easily. And the third advantage of the double linked list is at a particular node we can move to the first node, we can move to the previous node as well as we can move to the next node very easily. And the drawbacks of the double linked list are, the first drawback is it requires more space per each node. Why? Because we have to store an extra field called next field. And the next advantage is insertion and deletion operations are little bit complex. More number of operations are required because we are using an extra field called next field. In this video, we are going to discuss about create and print function in circular double linked list. First, let's see about what is circular double linked list. Circular double linked list is a combination of double linked list and circular linked list. We know what is double linked list. Each node contains three fields. The first field is previous field, the second field is data field, and the next field is next field. So here we have a circular double linked list which contains totally three nodes. Let the first node is located at the address 1000. Let the second node is located at 2000 address. Let the third node is stored at the address 3000. Here this is nothing but circular double linked list is a combination of double linked list and circular linked list. We know what is a circular linked list. The last node next field contains address of the starting node, but it is double linked list also. So that's why here the previous node contains address of the last node. Here what is the address of the last node? 3000 is the address of the last node. So 3000 is stored in the first node previous field. Let the data of the first node is 10 and the next field contains address of the next node. Next node address is 2000 here. If you store 2000 here, then a link will be formed like this. A link will be formed like this. So likewise, whenever we store 3000 here, then a link will be formed from first node to last node like this. Next, this is nothing but second node. This is previous field. This previous field contains address of its previous node. So what is its previous node? 1000. So 1000 is stored here. If you store 1000 here, then a link will be formed from second node to first node like this. And the data of the second node is 20. And the next field of the third node is 3000. Why? Because the next field contains address of the next node. What is its next node address? 3000. If you store 3000 here, then a link will be formed like this. So this is our last node. Here the first field is previous field. Previous field contains address of the previous node. Its previous node address is 2000. If you store 2000 here, then a link will be formed from third node to second node like this. Let the data of the node is 30. This is nothing but next field. Next field contains address of its next node. But after this node, we don't have any other node. But in a circular double linked list, we can go from last node to the first node. So the next field contains address of the first node. What is the address of the first node? 1000. If we store 1000 here, then a link will be formed from last node to first node like this. First, let us see the node declaration here. So how we can declare a node here? So struct node, let name of the structure is node. Here the node contains three fields. The first field is previous field. So struct node star pre. So previous field contains address of its previous node. And the second field is data field. Here data field contains an integer value 10, 20, 30 like that. And the next field is next field. This is self-referential structure. Struct node star pre, struct node star next, self-referential structures. Next field contains address of its next node. So this is nothing but the node definition here. Each node contains three fields like this. Previous field, data field and next field. And the structure variables are, here we are using star new. Star new for allocating memory for a node. And we have to use one more node called head. Head always points to the beginning of the node. We should not change head here. Let the circular double linked list contains three nodes. So head always points to the starting node. So head always points to the, let the starting node address is 1000. So head always points to the address 1000. And for traversing from one node to another node, we have to use one more node. So for that purpose, we are using temp. So totally, we have to use these three nodes here in creation and print function. First, let's see about create function. So how to create a circular double linked list. So first let's see that function. So void create. So first what we have to do is, with the help of the new node, we have to allocate memory for a node. Let's see that statement. How to allocate memory for a node? How to allocate memory for a node? So void, let name of the function is create. In order to allocate the memory for the node, we are using a structure variable called new. So new is equal to struct node star, why? Because name of the structure is node, malloc of size of struct node. So in this way we can declare, we can allocate memory for a structure variable. So we know all these syntaxes. By default, malloc function doesn't return any value. Malloc function return type is void, but it has to return some address. So that's why we have to perform the typecasting here. So size of allocates memory for the corresponding members of the structure. So whenever this statement is executed, then memory will be allocated like this. So name of the node is new. So node contains how many fields? Totally three fields. Previous field, data field and next field. Let the address is 1000 here. Here there is a possibility that circular double linked list may contains a single node only. So if the list contains only one node, then this node has to become the first node as well as the last node only. We know that in a circular double linked list, the previous field contains address of its next node. But here let us assume that our list contains only one node. So this node, this address has to become the previous field as well as next field also. So here new arrow pre is equal to new. Why? Because this is the first node and last node. So if we store 1000 here, then a link will be formed like this. Next we have to read an integer value and store the value here. Next, the next field also contains 1000 here. Why? Because let the list contains only one node. Now this node has to become the first node and the last node. So till now we have executed the first statement, allocation of memory for the node. Now let's see the next statement. New arrow pre is equal to new. Why? Because let us assume that list contains only one node. Then this node has to become the first node and the last node. So this is nothing but pre field. What is new address? 1000. So 1000 will be stored here. A link will be formed like this. Next we have to read a value. So printf enter a value. Here I am using the C language in order to create the double linked list as well as display the list. So scanf percentage d comma, let the value is value. So next what we have to do, let the value is 10. So we have to insert value in data field. Why? Because already we have declared node structure. Here this field is nothing but data field. So new arrow data is equal to value. Let the value is 10. So 10 will be stored in data field. Next, what is next field? Next field contains new only. So new arrow next is equal to new. So in this way we can allocate memory for a node. Next we can store new in previous field, and we can store value in the data field, and we can store new in the next field. Next, what we have to do? Next we have to check whether the list is empty or not. So when the list is empty, here we know that head will always point to the starting node. So head will always contain starting node address. Let us assume that head is null. If head is null, if head is 0, then we can say that the list is empty. So next we have to check whether the list is empty or not. Initially the list is empty. So initially the head is null value. Initially head is null value. So if the list is empty, then what we have to do? We have to place head as well as template new node. But we should not change head value. Head value will always point to the starting node only. Whereas we have to traverse temp from one node to the another node. So head is equal to new, temp is equal to new, temp is equal to new. So head will be placed at this new, that is 1000, temp will be placed at this new, that is nothing but 1000. Else, if the list is not empty, then what we have to do? Okay, let us assume that we have created one more node like this. We know that here the node contains 3 fields. So a node is created like this. Let the address of the node is 2000. Let name of the node is new. So new is equal to struct node star malloc of size of struct node. Previously new is 1000. Now new is 2000. Now what will happen? This value will be erased and new will be at 2000 memory location. Next statement, new arrow pre is equal to new. So what is new? 2000. So initially 2000 will be stored here. Next, new arrow data is equal to value. Let the value is 20. So 20 will be stored here. Next, new arrow next is equal to new. What is new? 2000. So 2000 will be stored here. So that a link will be formed like this, as well as a link will be formed like this. Okay. But for space constraints, I am not drawing those two links. So else what we have to do? Now we have to establish a connection from first node to the second node, as well as second node to the first node. Here what is the first node? Here the first node means not head. We should always consider temp only. Why? Because after creating the second node, we may create third node. Then we have to establish the connection from second node to the third node. So where is second node now? So temp is at the second node. So temp will always point to the current node. So first here we should not use head here. So first what we have to do? We have to establish a connection from first node to the second node. So what is second node? New. What is new address? 2000. So we have to store 2000 here. In temp next we have to store 2000. If we store 2000 here, then a link will be formed like this. So the first statement is temp arrow next is equal to new. So what is new here? New means 2000. So if we store 2000 in temp next field, a link will be formed like this. So next what we have to do? Here we know that this is nothing but previous field. The previous field should always contain address of its previous node. What is the address of its previous node? 1000. How to get 1000? We can get 1000 with the help of temp as well as head. But we should not use head here. Why? Because after creating the second node, we may create the third node. Then the third node previous field should contain address of its previous node. That is nothing but temp. So what is the statement now? New arrow, this field is nothing but pre. New arrow pre is equal to temp. What is the address here? 1000 here. So new arrow pre is equal to temp. So that a connection will be formed like this. Okay. So next what we have to do? We know that in a circular double linked list, the first node previous field always contains address of the last node. So what is the first node? First node is always denoted with head. So head arrow pre is equal to, we can use temp here. Why? Because here the last node is nothing but allocated memory node. We always allocate the memory using new only. So the next statement is head arrow pre is equal to new. So that what is new here? 2000. So in place of 1000, if you store 2000, then this link will be broken and a new link will be formed like this. And what is the next statement now? So here the last node next field always contains address of the starting node. What is the last node here? Here we can use either new, or if we want we can use either temp also. It is our choice. Okay. Let us assume that we use just new here. So new arrow next is equal to new arrow next is equal to new arrow next is equal to. So the last node next field always contains address of the starting node. What is the address of the starting node? 1000. 1000 means head. So new arrow next is equal to head. So what is new next? In new next, store head. Head means 1000. So if we store 1000 here, then a link will be formed like this. This link will be broken. A link will be formed like this. And if we want, we can move temp to its next node. But here we didn't use any temp here. If we want, we can move temp to its next node, and by using temp also we can perform the operations. Temp arrow, not this operation. Temp arrow next is equal to head. So likewise also we can perform the operations. So temp is equal to new. So next we have to move temp to its next node, so that if we want to establish a connection from second node to the third node, then we can write as this statement, temp arrow next is equal to new, so that a connection will be established from second node to the third node. Okay. So in this way we can create this is if block. This block will be executed when the list is empty, whereas this else block is executed if the list is not empty. Next one is close the function. If we want, here we know that circular double linked list may contains more than one node. Then it is better to place in do while loop. So place this in do while loop. Next close this one. Next let us read a character. Scan of %c comma %c. So we have to enter a character. We need to enter either y or n. So y stands for yes, whereas n stands for no. So if we enter y, then we can create one more node like this. So once again this loop will be repeated. Whereas if we enter n, then this loop won't repeat it. So let us use while condition here. While c double is equal to y. Okay. So let us assume that a first node is created like this. Next if block is executed, so else block won't execute. Next we have to enter the character. Let us assume that we entered y. So y double is equal to y. Condition is true. So once again control goes to the do. So one more node is created. So likewise we can create n number of nodes. In this way we can create a circular double linked list. Now let's see how we can display circular double linked list. Here the list contains totally how many nodes. After that we will see how we can execute this program, whether this code is correct or not. So here what is the output here? 10 arrow, 20 arrow, 30. So likewise I want to display the output. Okay. Let's see how we can perform that operation. So void display. Why? Because now we are displaying the nodes. Here for traversing from one node to the another node we are using temp. So temp is equal to head. So what is head here? Head means 1000. So temp will be placed at 1000 now. So now we have to display 10. Next we have to display 20. Next we have to display 30. What is this next field? This next field is nothing but head. So every time we have to check whether its next field is not head or not. If its next field is not head, then display that value. Okay. So while temp arrow next not equal to head, while temp arrow next is not equal to head, then printf %d. After that I want to display this symbol. So less than, minus, greater than. Why? Because this is double in the list. Display the temp value. So temp arrow data. After that move temp to its next node. So temp is equal to temp arrow next. Next close the value. Now let us check whether our logic is correct or not. So temp is at head location, that is 1000. While temp arrow next is not equal to head. So temp means 1000. 1000 next means 2000. So 2000 is not equal to what is head? 1000. So 2000 is not equal to 1000. Condition is true. So this body will get executed. So printf %d. What is %d? Temp arrow data. What is 1000 data? 10. So 10 will get printed. After that we have the arrow symbol here. This arrow symbol will get printed. Temp is equal to temp arrow next. So temp means 1000. 1000 next means 2000. So now temp will be placed at 2000 memory location. So once again this while condition will be evaluated. So temp means 2000, 2000 next means 3000. So 3000 is not equal to, what is here, 1000. So 3000 is not equal to 1000, condition is true. So temp arrow data, what is temp arrow data? 20 gets printed, temp is equal to temp arrow next. So temp means 2000, 2000 next means 3000. So temp will be placed at 3000 memory location now. So once again condition will be evaluated. What is 3000 next? 1000, 1000 not equal to 1000, 1000 not equal to 1000, condition is 1000 double is equal to 1000, but here the condition is 1000 not equal to 1000, condition is false. So the control comes out from the while loop. But here we didn't printed the last node value, but the temp is at 3000 only. So let us display that value. So printf %d comma temp arrow data. Where is temp now? Temp is at 3000 only. What is 3000 data? 3000 data is nothing but 30. So now 30 will get printed like this. So in this way we can create and display circular double linked list. In the next video we will see about how we can perform insertion operation at begin position, at end position, as well as at specified position in a circular double linked list. Now let's check whether create function and display function works properly or not. Here I am using TurboC compiler. So the first two statements are stdio header file and conio header file. Next here I am using two functions. These are the prototypes, function declarations. First one is create function, second one is display function. These two are the function declarations. Next, name of the structure is node. Here the structure contains three fields: previous field, data field and next field, and these three are the structure variables. New for allocating the memory for the structure, and head always points to the starting node, temp for traversing from one node to the another node. Next here we are using I, value and position. We uses I in the for loop. Next, value for inserting the value. Position is mainly useful while inserting the node at end position, specified position like that. Next, this is our main function. ch specifies the choice while of 1. Here the while loop will execute repeatedly until we entered other than 1 and 2. Here 1 represents create function, 2 specifies display function. So printf enter your choice. Let we have given 1 here. So switch off ch. So control goes to 1 means what? Create function. So control goes to the create function. Here c means a character. The character may be either y or n. So y stands for yes, n stands for no. Already we have seen this code. New for allocating the memory, and we have read a value. Initially prev contains new, as well as value field is stored in data. New contains next field. Next we have to check whether the list is empty or not. If the list is empty, then head and temp are placed at new. Else we need to establish the connection from the first node to the second node. So temp arrow next is equal to new arrow prev is equal to temp. But here what we did is temp is moved to the new. So now with the help of the temp we establish the connections. Or if we want, we can establish the connections with the help of new also. New arrow next is equal to head, new arrow prev is equal to temp. So likewise also we can establish the connections. Next, once the else is closed, we have printed a statement like this. Do you want to enter another value? That means one more node. So y stands for yes, n stands for no. Here I am using TurboC. So if you want to read any character variable as the second variable or third variable like that, we must use a flush function in order to clear the buffer. Whereas when we are working with some code block software or any online compilers or some Linux operating system, then it is not necessary to use a flush function. So we have to perform the repetition as long as we entered y. So we entered, if we entered other than y, then the control comes out from the while loop. If we enter 2, then the control goes to the display function. So temp is equal to head, while temp arrow next not equal to head. Then we displayed some data here. It is circular double linked list. So we can use double arrows like this. So temp is equal to temp arrow next. But here the problem is the last node data won't print it. So we can print the last node data like this. If we want, here also we can display some arrows like this. Now compile the program. So compile, no warnings as well as no errors. Now let us run the program. So Alt R run. Let us create a circular double linked list with 3 nodes. Enter your choice. 1 stands for create. Enter a value. Let the value is 10. Do you want to enter another value? Yes. y, enter a value, let the second node value is 20. Do you want to enter another value? Let the value is entered y. So y stands for yes, enter a value 30. Next, do you want to enter another value? Let us assume that that list is enough for us. So let us enter n. So n stands for no. So that means create list is over. So the control comes out from the while loop. Now let us display the list by entering the choice number 2. So the output is 10 arrow, 20 arrow, 30 arrow, like that. So if you want to come out from the loop, then we have to enter other than 1 and 2. Let us assume that I entered 3. So if we enter 3, then what will happen is this case 1 and case 2 are not true. So default gets executed. In default we have the exit function. So the control comes out from the entire program. So we can say that create and display functions are. Now let's see about inserting a node into a circular double linked list at begin position, end position, as well as specified position. So this is our circular double linked list, which contains totally 3 nodes. Let the first node is stored at 1000 address. Let the second node is stored at 2000 address. Let the third node is stored at 3000 address. Here each node contains 3 fields. The first field is previous field. The second field is data field. Third field is next field. Previous field contains address of the previous node. Here before this node we don't have any other node. So the previous field, the first node previous field contains address of the last node. Last node address is 3000. So the first node previous field contains 3000. If we store 3000 here, then a link will be formed from first node to last node like this. Let the data of the first node is 10. Let the next field, here what is this field? Next field. Next field always contains address of its next node. Its next node address is 2000. If you store 2000 here, then a link will be formed from first node to second node like this. This is nothing but second node previous field. The second node previous field contains address of the first node. If you store 1000 here, a link will be formed like this. Let data of the second node is 20. Next field contains address of the next node. Its next node is 3000. If you store 3000 here, then a link will be formed like this. This is last node. The last node previous field contains address of its previous node, that is 2000. So that a link will be formed like this. Let the data of this node is 30. The last node next field contains address of the first node. What is the first node address? 1000 here. So if you store 1000 here, then a link will be formed like this. So arrow will be towards 1000 because we stored 1000 here. And here we are using 2 variables here, head and temp. Head always points to the starting node. Starting node address is 1000 here. So head always points to 1000, and we have to use temp for traversing from one node to the another node. So initially we need to place temp at head position. Let us write the code parallelly while drawing the diagram. So void, let name of the function is insert underscore. First let us insert the node at beginning position. So this is the beginning position. So here we have to allocate memory for the node. In order to allocate memory for the node, we are using new variable, new structure variable. Here node contains totally 3 fields: previous field, data field, and next field. Let address of the node is 4000. So first allocate memory for the node. In order to allocate memory for the node, the statement is new is equal to struct node star. Name of the structure is node. Malloc of size of struct node. So the memory will be allocated for the members of node structure. In node structure we have 3 members: previous field, data field, and next field. So for those 3 members the memory will be allocated. Okay. So next what we have to do. So after inserting this node has to become the first node. So the output is, let data here is 40. So the output is 40, 10, and 20 and 30 will be the output. But in a circular double linked list, we know that the last node next field always contains address of the first node. So this is the last node. This node next field contains address of the first node. So we have to store 4000 here. So now we have to traverse the temp till we get the last node, so that in temp next field we can store address of the new node. Okay. So how we can traverse temp to its next node? Why? Because we know that here the temp next field, the last node next field is nothing but starting address node. So we have to perform the repetition as long as temp next is not equal to head. Okay, so initially we have to place temp at head location. So temp is placed at head location, that is 1000. Next one is while perform the repetition, while temp arrow next not equal to head. So if this condition is true, then traverse temp to its next node. So whenever this condition is false, then we can say that it is the last node. So what is temp? 1000. 1000 next means 2000. So 2000 is not equal to 1000. Condition is true. So temp is equal to temp arrow next. So temp means 1000. 1000 next means 2000. So now temp will be placed at 2000 memory location. So once again condition will be evaluated. Temp means 2000. 2000 next means 3000. So 3000 is not equal to 1000. Condition is true. So temp is equal to temp arrow next. So temp means 2000. 2000 next means 3000. So temp will be placed at 3000 memory location. So temp means 3000. 3000 next means 1000. So 1000 is not equal to 1000. Condition is false. So the control comes out from the while loop. Now the temp is at the last node. Now we have to establish the connection from the last node to the new node. Why? Because after inserting this node has to become the last node. So in this next field, we have to store this new. What is new here? 4000. Now in place of 1000, we have to store 4000. So if we store 4000, then this link will be broken and a new link will be formed like this. So this dotted lines denotes that this is the new link. This is the new link. Okay. So the statement is temp arrow next is equal to new. So in temp next, store new. Next one is, this is the previous field. The first node previous field always contains address of the last node. What is the last node address? 3000. So if we store 3000 here, then a link will be formed like this. So this is the new link. So that's why we are using some dotted arrows, as well as this link will be broken. So next what we have to do, after inserting this node has to become the first node and this node will become the second node. So we have to establish a connection from first node to the second node. So before that, let us write the statement. New arrow pre is equal to temp. So in new node previous field, this 3000 will be stored. So next node, new arrow next is equal to, what is its next node address? 1000. Where is 1000? 1000 is nothing but head. So if we store 1000 here, then a link will be formed like this. So what is the next statement? New arrow next is equal to head. Head. Next one, here this is the second node. The second node previous field always contains address of the first node. What is the first node address? 4000. So in place of this 3000, we have to store 4000. So that a link will be formed like this. So head arrow pre is equal to new. So that connections are established from first node to the second node, and second node to the first node, as well as first node to the last node and last node to the first node. But we know that in a circular double linked list or in any linked list, head always points to the starting node. So head will be moved to the new position. So head is equal to new. Head is equal to new. So head will be placed at this 4000 location. So now head will be at the 4000, and from the next we can go to the next node. So from this we can go to its next node, like that we can perform the operation. So in this way we can insert a node into circular double linked list at beginning position. Now let's see about inserting a node into circular double linked list at end position. So we have a circular double linked list like this with 4 nodes. Now our target is we have to insert a node at the last position. So what are the values here? 10, 20, 30, 40. Let the last node is 500. So the output should be 10, 20, 30, 40 and 500. So likewise we have to display the output. So here we want to insert the node at the last position. We are allocating the memory with the help of a node name called new. So allocate memory for the new node. Here node contains 3 fields. Let the address is 5000. Let us write the function now. So void insert underscore at underscore end position. So first we have to read a value. So printf enter a value, scan of %d comma ampersand value. Let the value is 500. Next allocate the memory for the node. New is equal to struct node star malloc of size of struct node. So memory is allocated like this. Next let us store the value. New arrow data is equal to value. Here the second field is data field. Let the value is 500. So 500 is stored like that. Okay. So next what we have to do. Here we have a node called head. Head always points to the starting node. And for traversing from one node to the another node, we are using temp here. Here what we have to do. So after inserting this 50 node, this 4000 node has to become the last but one node. So we have to establish connection from this last but one node to this new node. So now this new node has to become the first node. We know that in a circular double linked list, the last node next field contains address of the starting node. So in this next field, in new next, we have to store this head address as well as this previous field. The first node previous field contains address of the last node. So here we have to traverse the temp till we get the last node. So for that the condition is like this: while temp arrow next is not equal to head, temp is equal to temp arrow next. Temp is equal to temp arrow next. Okay. I'm sorry. While temp arrow next, this is enough. While temp arrow next is not equal to head, temp is equal to temp arrow next. Why? Because here our target is we have to traverse the temp till we get the last node. What is the last node next field? 1000. So this is not equal to 1000 head. So likewise we have to perform the repetition. Let us check whether our condition is correct or not. So temp means 1000, 1000 next means 2000. So 2000 is not equal to 1000. Condition is true. So temp is equal to temp arrow next. 1000 next means 2000. So now temp is placed at 2000 location. So once again condition will be evaluated. 2000 next means 3000. So 3000 is not equal to 1000. Condition is true. So temp is equal to temp arrow next. 2000 next means 3000. So temp is at 3000. So once again condition will be evaluated. So temp means 3000. 3000 next means 4000. 4000 is not equal to 1000. Condition is true. So temp will be traversed to the last node. Temp means 4000. 4000 next means 1000. 1000 is not equal to 1000. Condition is false. So the control comes out from the while loop. Now temp is at the last node. Now we have to establish the connection from the last node to its new node. So now here in place of this 1000, we have to store 5000 now. So temp arrow next is equal to what is 5000 new. So if you store 5000 here, then a link will be formed like this. So last but one node to last node, a link will be formed. Temp arrow next is equal to new. Next, after inserting this node has to become its previous node. So what is its previous node address? 4000. If you store 4000 here, then a link will be formed like this. So the statement is new arrow pre is equal to temp. So that connections are established from last node to last but one node to the last node. We know that in a circular double linked list, the last node next field always contains address of the first node. Here the address of the first node is head 1000. If you store 1000 here, then a link will be formed like this. Okay, as well as this link will be broken. And we know that head previous, the starting node previous field always contains address of the last node. So head arrow pre is equal to new. What is new? 5000. In place of 4000, if you store 5000, then this link will be broken and a new link will be established like this. So in this way we can insert a node into circular double linked list at begin position, at end position and at specified position. Now let's see about inserting a node into circular double linked list at specified position. So this is our circular double linked list which contains totally 4 nodes, and let us assume that now our target is we want to insert a node at third position whose value is let the value is 300. Let the first node is nothing but position 1, let the second node is nothing but position 2. So this node will become the third position. So at this position we have to insert 300. So the output is 10, 20, 300, and after 300 we have 30, 40. So that is the output we have to display. Or we can assume this is as position 0, this is as position 1, this is as position 2. So the next one is nothing but this one is nothing but position 3. So 10, 20, 30, after that insert 300 here, and after that the next value is 40. So likewise also we can display. The first node can be considered as either position 0 or position 1. It is our choice. Okay. Let us assume that this is first position, this is second position. So let it be the third position. So we have to insert here. Let name of the node is new. Name of the node is new. Let the address is 4000. 4000 is already there. Let the address is 5000. So let us see the code here. So void insert yet. Let name of the function is position, POS. So first we have to read position as well as value. Here position means 3, value means 300. So first we have to read them. Next allocate the memory. So new is equal to, here for allocation of memory we are using new node. So new is equal to struct node star malloc of size of struct node. Size of struct node. So memory allocation for the node is over. So a memory is allocated like this. Okay. Next here head always points to the starting node. So head always points to the starting node address, that is 1000. Next here we have to use a variable called temp. Here we are using temp for traversing from one node to the another node. Here what is our target? We want to insert the node at third position. So if we want to insert a node at third position, then we have to traverse the temp till we get the second position. Why? Because after the second position we need to insert the node at the third position, so that we can establish the connection from the second position to the third node as well as that new node to the third position node. So likewise let us assume that here the position is 30. If the position is 30, then we have to traverse the temp till we get 29th node. Okay. So likewise we have to perform the traversing. So temp is equal to head. So initially temp is placed at head position. Next for traversing I am using this for loop. For I is equal to 1, I less than position minus 1, I plus plus, temp is equal to temp arrow next. Here our target is we want to insert a node at the third position. This is first position, second position, let it be the third position. So this will become fourth position and this will become the fifth position. So we have to traverse the temp till we get second position. So for that we are using this for loop. So I is equal to 1. So 1 is less than, what is position? Position means 3. 3 minus 1 means 2. So 1 less than 2, condition is true. So temp is equal to temp arrow next. Previously temp is at 1000. Now 1000 next means 2000. So temp will be placed at 2000. Next I plus plus, I will become 2. 2 less than 2, condition is false. So the control comes out from the for loop. Now where is temp? Temp is at the second position. So that means we have traversed the temp till we get the second position. So now what we have to do? We have to establish the connection from temp to new node as well as new node to this 3000 node. This 3000 is nothing but temp next. So which connections we have to establish first now? If we store a new address, if we store 5000 in temp next field, that means in place of this 3000 I stored 5000. Then what will happen? This 3000, this link will be broken. If this link is broken, then it is not possible to get this 3000. Why? Because here we are accessing 3000 with the help of the temp next. So, but we need to establish the connection from temp to new. So if you store new, what is new? 5000. If you store 5000 here, then this link will be broken. So that's why first we have to establish the connection from new to temp next, and after that establish the connection from temp to new. Okay. So now here store 3000. So if you store 3000 here, then a link will be formed like this. So new arrow, what is the statement? New arrow next is equal to. So how to get 3000? Temp means 2000. 2000 next means 3000. Whereas this field is, so this one is nothing but that one. So new arrow next is equal to temp arrow next. So in new next, in 5000 next, we stored temp next. So temp means 2000. 2000 next means this 3000. So that a link will be formed like this. So next what we have to do? So likewise here, before this node we have to store this node. So what is this field? This is nothing but temp means 2000. 2000 next means 3000. What is this field? This field is nothing but previous field. So first space constraints I am writing here. Temp arrow, next arrow, pre is equal to new. So temp means 2000. 2000 next means 3000. What is 3000 previous? So in 3000 previous we have to store this new 5000, so that a link will be formed like this. Okay. So with this, the connections are established from new node to temp next. Now we have to establish the connection from temp to new. So temp arrow next is equal to new. What is new? 5000. If you store 5000 here, then a link will be formed like this. So temp arrow next is equal to new. Next, before this node we have temp node. So this is nothing but previous field. What is this address? 2000. If we store 2000 here, then a link will be formed like this. So how we can access that one? New arrow pre is equal to, this is new node, this is the previous field. So new arrow pre is equal to this 2000 temp. So if we store temp here, then a link will be formed like this. So now the connections are established from temp to new node as well as new node to temp next node. So here this code is similar to double linked list inserting a node at specified position. There are no modifications here. Why? Because the only difference between double and circular double linked list is the last node next field contains address of the first node. The first node next field contains address of the last node. But here we are inserting the node at a specified position. So that means we are not making any changes yet the first position as well as the last position. Let's check whether insert at begin, insert at end and insert at position works properly or not. The first two statements are header files. Next, these are nothing but function declarations. First we need to create a circular double linked list. For that we are using create function, and every time after creating or after insertion we need to display the list. So that's why we use display function. Next, insert at begin, insert at end and insert at position. So these five are the function declarations, and this is nothing but our structure node. It contains three fields: previous field, data field and next field. And these are the structure variable which we use new for allocating the memory, head always points to the starting node, temp for traversing from one node to another node. We use I inside the for loop. Next, value, in order to store a value in a new node we use value. Next, to position, mainly we use position while inserting a node at specified position, and this is main function int ch specifies the choice. Here we use while of 1. This is nothing but infinite loop. Totally there are 5 choices are there: 1 for create, 2 for display, 3 for insert at begin, 4 for insert at end, 5 for insert at specified position. So if we enter other than 5, then if we enter from 1 to 5, then this while loop will get executed. If we don't enter a value from 1 to 5, then the while loop execution will be terminated. So enter your choice: scan of %d comma %ch. Case 1 create, case 2 display, case 3 insert at begin, case 4 insert at end, case 5 insert at position. Default means exit. So if we enter other than 1 to 5, then exit, the entire program will get terminated. Next, end of the switch, end of the while gets h, and end of the main function. And this is nothing but create function code. Already we have seen this in the last class. Still, if there are any doubts, then please go through that function. And this one is nothing but display. Already we have seen this function also in the last video. So if there are any doubts, then please go through that video. Next, insert at begin. Already we have seen this code at the starting of the video. So new for allocating the memory. Next, we have to store value in the data field. Initially we need to place temp at the head location, and we have to traverse the temp till we get the last node. For that we use this while loop. While loop contains only one statement, so that's why curly braces are not compulsory. Next, the last node next field contains address of the first node. So temp arrow next is equal to new. Next, now new becomes the first node, so that previous contains new becomes the first node. So the first node previous field contains address of the last node. The last node previous field as well as the first node previous field contains address of the last node. So head arrow pre is equal to new. Next, head should be traversed to the first node. Head is equal to new. So already we have seen this code at the beginning. Next, in this way we can insert a node at the end position. So new arrow data is equal to value. Initially we need to place temp at head and traverse the temp till we get the last node. Next we have to establish the connection from temp to new like this. So in this way insertion at ending is done. Next one is insert at specified position. This is similar to double linked list insert at specified position. So first we have to establish the connection from new to temp next and temp next to new. Next establish the connection from temp to new. Now let us execute the program. So first compile the program. Two errors. So temp, not temp C, it's temp only. So compile the program. 0 warnings and 0 errors. Next run the program. So first we need to create the circular double linked list. Enter your choice 1, enter a value 10. Now if you want to create one more node, then type Y. So Y stands for yes. Enter a value 2. Next let us assume that we want to have one more node. So enter Y. Y stands for yes. Enter a value 30. If you enter N, if you enter other than Y, then the control comes out from the do while loop. Next to display the circular double linked list, totally we entered 3 values 10, 20, 30. So that is the output there. Next insert at the begin. For insert at the begin the choice is 3. Let the data is 311. Now 311 should be inserted at the beginning position. So the output is 311, 10, 20, 30. Display the output. For displaying the output we have to give the choice number 2. So 311, 10, 20, 30 is the output. Next insert at end. So the choice is 4. Let the value is 222. So 222 should be inserted at end position. So after 30, 222 will be inserted. So enter your choice 2. So 311, 10, 20, 30, 322 will, so that is the output there. Next insert at specified position. Choice is 5. Let the position is 3. Let the position is 3. So at the third position insert the value. So third position means here 311 means first position, 10 means second position. So after 10 we will get the third position. So after 10 we will get that 333. After that 20, 30, 222 will get printed. So after 10 333 gets printed. The remaining nodes 20, 30, 222. So in this way we can perform insertion at begin position, specified position. In this video we are going to discuss about deleting a node from circular double linked list at begin position, end position, as well as specified position. First let's see about how we can delete a node from the circular double linked list at begin position. So this is a circular double linked list which contains totally 4 nodes. We know that each node contains 3 fields. This is previous field, this is data field, and this is next field. For the first node, the previous field is nothing but the last node next field. The last node address, what is the last node address? 4000. So if you store 4000 here, then a link will be formed like this. That the first node data is 20. Here the second node address is 2000. If you store 2000 here, then a link will be formed like this. This is our second node. Second node previous field contains address of the first node, that is 1000. Then the second node data is 20. Third node next field contains address of the third node. Second node next field contains address of the third node, that is 3000. This is third node. This is previous field, data field, and next field. This is fourth node, previous field, data field, and next field. The last node next field contains address of the first node, that is 1000. If you store 1000 here, then a link will be formed like this. Here mainly we uses head and temp. Head always points to the beginning of the node. So here the beginning node address is 1000. So head always points to 1000 address. And we have to use temp for traversing from one node to the another node. Let us write the code parallelly. So void. So here what we are doing, we are deleting a node at begin position. So at the begin position, what is the node which we are having? So at the begin position we have 10. So we need to delete this node. So whenever we call this function, then we have to display the output as deleted node is 10. And after that, if we call the display function, then after deleting the beginning node, then what are the remaining nodes? 20, 30 and 40 are the remaining nodes. So we have to display that output. We know that in a circular double linked list, the last node next field contains address of the first node. But after deleting the first node, the second node has to become the first node. So now the last node next field contains address of the second node. But after deleting the second node, Why? Because here we are deleting this node. So we have to traverse the temp until we get the last node. Until we get the last node. So what is the last node next field? Last node next field is nothing but head address. So every time we have to check whether temp next is not equal to head or not. If it is not equal to head, then traverse the temp one position to its right. So let us write that code. So initially we have to place this temp at head position. So temp is equal to head. So temp will be placed at 1000 memory location. Now let us check the condition. While temp arrow next not equal to head. So every time we have to check whether the corresponding node next field is not head or not. If it is not head, then we can say that it is not the last node. So temp is equal to temp arrow next. So what is temp? 1000. What is 1000 next? 2000. So 2000 is not equal to 1000. Condition is true. So temp is equal to temp arrow next. So temp means 1000. 1000 next means 2000. So now temp will be traversed to 2000 memory location. So once again condition will be evaluated. 2000 next means 3000. 3000 is not equal to 1000. Condition is true. So temp will be traversed to its next node. 3000 next means 4000. So 4000 is not equal to 1000. Condition is true. So temp will be traversed to its next node. 4000 next means 1000. So 1000 is not equal to 1000. Condition is false. So the control comes out from the while loop. Now the temp is at the last node. Okay. Various head points to the starting node. So now what we have to do? So before performing the deleting operation, let us place D at head location. Here D means a structure variable, deleted node. So place D at head location. So D stands for deleting node. So which node we are deleting? Let us display the deleted node. Printf deleted node is, here we are using C language. So percentage D comma D arrow data. So what is D arrow data? 1000 data. 1000 data means 20. 1000 data means 10. So 10 gets printed now. So now what we have to do? We are deleting this node. So if we delete this node, then this node has to become the first node. So we have to traverse head to its next node. So head is 1000. 1000 next is nothing but 2000. So head is equal to head arrow next. Now head points to the second node. Why? Because we are deleting the first node. So now this is our first node after deleting this node. So what is the head previous? Here we are deleting this node. So what will happen? The first node, this node has to become the first node. The first node previous field always contains address of the last node. The last node address is located at the temp. So what is the statement now? Head arrow prev is equal to temp. So in head prev we have to store the temp. So what is temp? 4000. Now in place of this 1000 we have to store the 4000. So then what will happen? Whenever we store the 4000 now this link will be broken and a new link will be established like this. A new link will be established like this. Next, the last node next field always contains address of the first node. After deleting this node, the second node has to become the first node. So now what we have to do? Temp arrow, the last node next field always contains address of the first node. First node address is head. So what is head? 2000. Now in place of this temp next, we have to store the 2000. If we store 2000 now, then a link will be formed like this. Okay. Then what we can do now? We can place in previous field we can place null, as well as in next field we can place null. So D means deleted node. So now there is no need of D. So D arrow prev is equal to null. So D arrow next is equal to null. So we can place null here. Here we can place null. So that these links will be broken. As well as now there is no need of D node. So let us free the memory, free of D. So that this memory will be destroyed. So we can use this memory for allocating some memory for some other node. Now what is our linked list? Head points to the first node and the last node next field contains address of this first node. So in this way we can perform deletion of a node from circular double linked list at begin position. Now let's see about deleting a node from circular double linked list at end position. So at end position we have a node called 40. So we have to delete this node 40. After deleting the last node, the output is 10, 20 and 30 will be the output. So our circular double list totally contains 4 nodes. So after deleting the last node, the output is 10, 20 and 30 will be the output. Head always points to the starting node. So head always points to this 1000 address, and initially we have to place temp at head position. Let us write the code now. So void delete underscore yet underscore end position. So here our target is we want to delete the end node, the last node. So how long we have to traverse temp? Here we are using temp for traversing from one node to another node. So here our target is we want to delete the last node. So if we want to delete the last node, then we have to traverse the temp till we get the last but one node. Why? Because we know that in a circular double linked list, the last node next field always contains address of the first node. Here we are deleting the last node. If we delete the last node, then the last but one node will become the last node. Now this node next field should contains address of the starting node. So if you want to delete the last node, then traverse the temp till we get the last but one node. So here the condition is very simple. So initially we have to place a temp at head. So if you want to traverse to last node, then the condition is temp arrow next not equal to head. Whereas if you want to traverse temp to last but one node, then the condition is temp arrow next is not equal to head. Then we have to check, then we have to traverse temp to its next node. So what is temp? 1000. 1000 next means 2000. So 1000 means, temp means 1000. This 1000 next means 2000. 2000 next means 3000. 3000 is not equal to 1000. Condition is true. So temp will be traversed to its next node. 1000 next means 2000. Now temp is at 2000 address. Next 2000 next means 3000. 3000 next means 4000. So 4000 is not equal to 1000. Condition is true. So temp will be traversed to its next node. 2000 next means 3000. Now temp is at 3000. 3000 next means 4000. 4000 next means 1000. 3000 next means 4000. 4000 next means 1000. So 1000 is not equal to 1000. 1000 is not equal to 1000. Condition is false. So the control comes out from the temp. Now the temp is at the last but one node. Here what is the deleted node? This is the deleted node. Let us use a structure variable called d. And what is d here? D is equal to temp arrow next. Why? Because here the deleted node is the last node. So temp means 3000. 3000 next means 4000. So d will be placed at 4000 address. Okay. We can declare like this: struct to. Let name of the structure is node star d. Likewise we can declare. Okay. So now the deleted node is 4000. So first to display that data. Here we are using C language. So print of deleted node is percentage d comma d arrow data. So now this data will get printed. So after deleting this node has to become the last node. The last node next field always contains address of the starting node. So now this is nothing but last node. This last node next field contains address of the starting node. So in temp next we have to store head. Head means 1000. If you store 1000 here, then what will happen? A link will be formed like this. So this link will be broken. Next, the first node previous field always contains address of the last node. So after deleting this node has to become the last node. So now in first node previous field we have the last node address, that is 3000. If you store 3000 here, then this link will be broken and a new link will be formed like this. So what is the statement? Head arrow. So the first node previous field contains last node address. So the connections from first node to last node and last node to first node is over. So next what we have to do? Now there is no need of these two links. So place null here, place null here. So d arrow prev is equal to null. Next to d arrow next is equal to null. D arrow next is equal to null. So if you place null here, then these links will be broken. Now in order to destroy the memory for the node, we can use free function. So free of d. So whenever we use this free function, then the memory which is allocated for d will be destroyed, so that we can use that memory for allocating some other variable. So in this way we can delete a node from circular double linked list at end position. Now let's see about deleting a node from circular double linked list at specified position. This is our circular double linked list which contains totally 4 nodes. Head points to the starting node. Let here the position is 3. Position is 3. Let the first node is present at first position. Second node is present at second position. Third node is present at third position. So that means here our target is we want to delete this node. Or if you want, we can assume as first node located at 0 position, second node located at first position, this third node located at second position. So likewise also we can assume. So the first node may be 0th position or first position. But in our example we are assuming that the first node is position 1, second node is position 2, third node is position 3. So we have to delete this node. So here it is very simple. So if you want to delete the node at third position, then what we have to do? Then we have to place initially temp at head position and traverse the temp till we get the second position. Why? Because what is our target? We want to delete a node which is located at third position. So traverse the temp till we get the second position. Now this second position next field contains address of the fourth node, and fourth node previous field contains address of this node, so that it will be over. Okay. Now let's see the code. Parallelly we will draw the diagrams. So void delete underscore yet underscore specified position. So first we have to read the position. Let the position is 3. So printf enter position scanf %d comma ampersand pos. Next to temp is equal to head. So initially temp is at head position. Now we have to traverse the temp till we get the second position. So the for loop is like this: for I is equal to 1, I less than position minus 1, I plus plus, temp is equal to temp arrow next. So if we want to delete a node at third position, then we have to traverse the temp till we get the second position. So I is equal to 1, 1 is less than, position means 3, 3 minus 1 means 2. So 1 less than 2, condition is 2. So body gets executed. Temp is equal to temp arrow next. So temp means 1000, 1000 next means 2000. So now temp will be presented at 2000 address. Next I plus plus, now I become 2. 2 less than 2, 2 less than 2, condition is false. So the control comes out from the for loop. Now where is temp? So temp is at the second position. So the first task is over. So now what we have to do? Here this is nothing but the deleted node. Let us declare a variable, a structure variable called D. D stands for the deleted node. So D is equal to temp arrow next. D always points to the deleted node. So what is temp? 2000. 2000 next means 3000. So now D is at the 3000 location. Okay. So now what we have to do? Now here we are deleting this node. So there is no this node after deleting this node. So what we have to do now? Now this node next field should contains the fourth node address. So temp arrow next is equal to, so in this next field we have to store that 4000. So how to get the 4000? Here D means 3000. 3000 next is nothing but 4000. So D arrow next. So D means 3000. 3000 next means 4000. If you store 4000 here, then a link will be formed like this, and this link will be broken. Okay. As well as here we are deleting this node. So this fourth node previous field contains address of this node. So how to get this previous field? We know how to get the 4000. D arrow next. D means 3000. 3000 next is nothing but 4000. We have to store in previous field. Arrow previous equal to. So what we have to store? 2000. So if we store 2000 here, then what will happen? A link will be formed like this, and this links will be broken. So what we can do now? So now we can display the deleted node. So printf deleted node is %d comma d arrow data. So what is d data? 30. So 30 will get printed. Now we can place null here and we can place null here. So d arrow prev is equal to null, d arrow next is equal to null. Next we can use the free function in order to destroy the memory. So this is similar to double linked list deletion operation. Why? Because we are not making any changes in the first node and the last node. So simply we are making some changes in a specified position. Okay. So this specified position deletion is similar to double linked list specified position deletion. So in this way we can delete a node from the circular double linked list at begin position, end position, and specified position. Now let's check whether delete at begin, delete at end, and deleted position is working properly or not. So the first two statements are header files, stdio, call.io. Here we are creating a circular double linked list by using with create function. Next, in order to display the nodes, we are using display function. So here there are three functions are there: delete underscore yet underscore begin, which performs deletion operation at beginning, next end, next at specified position. So these five are nothing but function declarations, and this is our structure. Structure contains three fields: previous field, data field, and next field. Here there is no need of for allocating the memory for the node, we are using new. In create function we will use new. Head always points to the starting node, temp for traversing from one node to the other node. This is main function. Here we are using some infinite while loop. This is our menu: 1 create, 2 display, 3 delete at begin, 4 delete at end, 5 delete at position. So here we need to enter the choice from 1 to 5. So 1 means create, 2 means display, 3 means begin delete, 4 means ending node deletion, 5 means specified position delete. If we enter other than from 1 to 5, then default will get executed. So the control comes out from the switch. Okay. So next, these are the various functions which we have. This is nothing but create function. Already we have seen this function in create in the first video, that is circular double linked list create and display video. We will see this one. We have seen this one. If there are any doubts, then please go through that video. Next one is display. So this is the display function. Already we have seen this in create and display only. Next one is totally we have defined three functions: delete at begin, delete at specified position. So this is nothing but delete at begin. So initially we have to place temp at head. Here we are deleting the starting node. So deleted node is nothing but head. So we have to traverse the temp till we get the last node. And after that, what we have to do? After deleting the first node, the second node has to become the first node. So now head will be traversed to next node. Head arrow previous is equal to last node. Last node next field contains address of the first node. So in this way we can perform deletion operation at the beginning. Next, this is for deletion at the end. So we have to traverse the temp till we get the last node. So for that, this is the condition. So D means the last node. Now the last node next field. Here we are deleting the last node. So we have to traverse the temp till we get the last but one node. This temp is at the last but one node. So the last but one node next field now contains address of the first node. First node address contains the last but one node address. Now we are deleting the last node. So place place null in previous and next field, and then destroy the memory using free function. This is for deletion at end. Now let's see about delete at specified position. So this is nothing but delete at specified position. So first we have to read the position and traverse the temp till we get position -1. So if we want to delete third position node, then we have to traverse the temp till we get the second position and place D at the corresponding third position, and now establish the connections from the second node to the fourth node like this. Let us compile the program. So 0 errors and 0 warnings. Now let us run the program. So 1 for create. First let us create the circular double linked list. Let the value is 10. Then we have to enter either Y or N. So Y stands for yes. So that means we want to add one more node to the list. So 20. Let us add one more node to the list, 30. Let us add one more node to the list, 40. Now let us add one more node to the list, 50. Let us add one more node to the list, that is nothing but 60. No, N stands for no, so that means the list was created now. Let us display the nodes in the circular double linked list. So 10, 20, 30, 40, 50, 60 is nothing but the output. So first let us delete at the begin. So for that the choice is 3. So if we enter 3, then the deleted node is 10. So now if we call the display function, then the output is from 20 to 60. Why? Because the beginning node is deleted. So 20 to 60. So next one is 4. 4 means deleted at the end. So the ending node is 60. So deleted. So now deleted node is 60. So 60 is deleted. Now if we call the function, display function, then we will get the output as from 20 to 50. So 20 to 50. Next one is deleted specified position. So choice number is 5. So now we have to enter the position now. Let us assume that we entered third position. So third position means 20 means first position, 30 means second position. So 40 means third position. So 40 will be deleted now. So deleted node is 40. Now if we call the display function, 40 is deleted now. So now from 20 to 50, 20, 30 and 50 will get printed. Okay. Now if we want to come out from the while loop, then we need to enter either 0. Okay. Then we can come out from the do while loop. Now let's see about advantages and disadvantages of double linked list. We know what is a double linked list. A double linked list is a collection of nodes where each node contains 3 fields: previous field, data field, next field. Previous field contains address of the previous node, data field contains data of the node, next field contains address of the next node. Let's see the advantages of the double linked list. We can traverse in both directions, that is from starting to ending as well as from ending to starting. If you take single linked list, then we can traverse only from left to right. It is not possible to traverse from right to left. Why? Because in a single linked list we can have only next field. So with the help of next field we can traverse from current node to the next node. We don't have previous field. Whereas if you take double linked list, we can have previous field as well as next field. So with the help of the previous field we can traverse to its previous node also. So that is the first advantage of the double linked list. We can traverse from left to right as well as from right to left. If you take single linked list, then we can traverse only from left to right. Second advantage, it is easy to reverse the linked list. If you take single linked list, then it is very difficult to reverse the single linked list. Why? Because we know what is the single linked list. Let it be the single linked list. So first we have to place null here. Next we have to establish a connection from second node to the first node. Next we have to establish a connection like this. So it is very difficult to reverse the single linked list, whereas it is very easy to reverse the double linked list. Why? Because we can have previous field as well as next field. Okay. So with the help of the temp, we can easily go to the last node. So while temp is not equal to null, then temp is equal to temp arrow next. So whenever this condition is false, then temp will be at the last node. So simply we can display the data and move to the previous node. So temp is equal to temp arrow previous. So we can write the logic very easily if you take the double linked list. Whereas reversing the single linked list is very complex process. Next advantage, if we are at a particular node, then we can go to any other node. But in single linked list, it is not possible to reach to the previous node. If you take single linked list, then we don't have any previous node. So it is not possible to move from third node to the first node. If we want, we can move from first node to the third node. Why? Because we have next field. Suppose if the temp is at a particular node, then if we want to move to the third node, then we can write as temp arrow next. But let us assume that temp is at third node and I want to move to the first node. Is it possible? No, it's not possible. Why? Because in a single linked list, we don't have previous field. Whereas if we take double linked list, we can have previous field as well as next field. So from the third node, we can move to the first node very easily. Just like writing the statement temp arrow pre. So that is one more advantage of the double linked list. At a particular node, we can move to its next node as well as its previous nodes also. Whereas if you take single linked list or circular linked list, then we can move only to the next node. It is not possible to move to the previous node. Next, let's take the disadvantages of double linked list. The first disadvantage is it requires more space per the node because one extra field is required for pointer to the previous node. So if you take single linked list, then only 2 fields are sufficient, data field as well as next field. As well as if you take circular linked list, only 2 fields are sufficient, data field as well as next field. Whereas if you take double linked list, we require totally 3 fields. We need previous field, next field as well as data field. So we require 3 fields. So in order to store those 3 fields, we need to require much amount of memory. So that is the first problem with double linked list. For storing each node, we need to require much amount of memory than single linked list and circular linked list. Let's take the last advantage. Insertion and deletion take more time than single and circular linked list because one more pointer operations are required. So insertion and deletion operations are very complex in double linked list. Whereas if we take single or circular linked list, then we can have only two fields, data field and next field. So if we establish the connections for that means we need to store some value in data field as well as we need to store address in next field. Whereas if you take double linked list, we require three fields. So we have to establish the connections for previous field as well as next field, and we have to store value in data field. So insertion and deletion operations are little complex because more pointer operations are required for previous field as well as next field. Whereas if you take single linked list, then only two operations, storing the value in data field and establishing the connection from that current node to the next node is over. Whereas if you take double linked list, then we have to establish the connection to its previous node and its next node also. So these are the various advantages and disadvantages of double linked list. So the first advantage of the double linked list is we can traverse from left to right as well as from right to left. The second advantage of the double linked list is we can reverse the double linked list very easily. And the third advantage of the double linked list is at a particular node we can move to the first node, we can move to the previous node as well as we can move to the next node very easily. And drawbacks of the double linked list are, the first drawback is it requires more space per each node. Why? Because we have to store an extra field called next field. And the next advantage is insertion and deletion operations are little bit complex. More number of operations are required because we are using an extra field called next field. Now let's see about applications of linked list. The first application is polynomials can be represented and various operations can be performed on polynomials using linked list. So by using linked list, we can represent a polynomial as well as we can perform some operations on the polynomial. So we know what is a polynomial. So this is nothing but a polynomial, 8x power 10 plus 4x squared plus 3. So this is nothing but a polynomial, an equation. A polynomial means a collection of terms. So this polynomial contains totally 3 terms, where each term contains some coefficient as well as exponent. Okay. So 4 is coefficient, 2 is exponent, 8 is coefficient, 10 is exponent, 3 is coefficient and some 0 is exponent, like this. So we can represent a polynomial with the help of linked list, and we can perform operations like creating a polynomial, displaying a polynomial, adding 2 polynomials, subtraction of 2 polynomials, multiplication of 2 polynomials, division operations. So we can perform all these operations with the help of linked list. Now let's see the second advantage. Sparse matrix can be represented using linked list. So if we want to have, we can use this sparse matrix mainly in scientific computing as well as numeric analysis. So in scientific computing and numeric analysis, we need this sparse matrix. So in order to represent that sparse matrix, we can use linked list. Now let's see the next applications. Next application, various operations like student details, customer details, product details and so on can be implemented using linked list. So we know that we can have several fields in student like student number, name, marks, gender. So all that information can be represented with the help of linked list, because that is the beauty of linked list. Linked list is a collection of nodes. With the help of linked list, we can store different types of data such as integer data, float data, character data, strings data. So we can store any type of data with the help of the linked list. So if you want to store some customer information or some product information or some student details, so if you want to store anything, then we can go for linked list. Next advantage, linked list can be used to implement stacks, queues, trees and so on. So we know that stack works on the principle of LIFO, queue works on the principle of FIFO, first in first out. Stack and queue can be defined as a collection of items. So we can implement stacks and queues with the help of linked list also. If you implement stacks and queues with the help of arrays, then the problem is, we know what is the problem with array. We must know in advance regarding the size of the array. So it is not possible to change the size during runtime. Whereas with the help of the linked list, we can create as many nodes as we like. Okay, so that is the advantage here. And if you want to implement some binary trees, binary search trees, AVL trees, state block trees, play trees, B trees, B plus trees, then we can use as the linked list for implementation of all those trees. Next advantage, linked list can be used to implement graphs. So we know what is a graph. A graph means a collection of nodes, a collection of vertices, and we can have some edges from one vertex to another vertex. Mainly we can represent graph with the help of two approaches. The first approach is adjacency matrix, and the second approach is adjacency list. So if you want to represent adjacency matrix, then we can use as arrays, whereas for representing adjacency list we can use as linked list. So adjacency list representation of a graph can be implemented with the help of the linked list. So we can use as linked list in order to represent the graph. So next one, to implement hash tables. Okay, so in order to implement hashing, we require some hash table. Hash table is useful in order to store the information. That hash table entries will be implemented with the help of the linked list. Okay, and the last advantage is to implement dynamic memory allocation. So we know what is dynamic memory allocation. The allocation of memory during runtime is known as dynamic memory allocation. Mainly we use dynamic memory allocation in order to overcome the drawbacks of the static memory allocation. So in order to implement the dynamic memory allocation, we use pointers and linked list. So these are the various applications of linked list. Now let's see about polynomial ADT or polynomial addition. A polynomial can be defined as a collection of terms where each term contains coefficient and exponent. This is a polynomial which contains totally 3 terms. This is the first term, second term and third term. First term coefficient 8, exponent 5. Second term coefficient 4, exponent 3. Third term coefficient 2, whereas the exponent is 0. Okay. Polynomial ADT. ADT stands for abstract data type. Abstract data type is nothing but what are the operations which we can perform on polynomial. Mainly we can perform create operation on the polynomial, creating a polynomial, displaying a polynomial, adding 2 polynomials, subtracting 2 polynomials, multiplication of 2 polynomials, and division of 2 polynomials. So in this video we will try to discuss about how we can create some polynomials, how to display polynomial, as well as how to add two polynomials. Okay. Before that, let's see the representation of a polynomial. So how to represent a node in a polynomial? So we can represent a node with the help of struct node, where here we have 2 data fields. The first data field is coefficient and the second data field is exponent. So those are nothing but some integer values. So int coef comma exponent. Next we can have some next field. Why? Because here in order to implement the polynomial we are using a linked list. So this is nothing but a self-referential structure. So structure node star next. So in this program we have to add 2 polynomials. So in order to perform addition operation, we have to create 2 polynomials. In order to perform the operation on the first polynomial, we are using star mu1 structure variables called star head1, star p1, and to perform operations on the second polynomial, we are using star mu2, star head2, and star p2. Here mu1 for allocating memory for a node in the first polynomial. Head1 always points to the first node of the first polynomial. P1 for traversing from one node to another node in the first polynomial. Likewise, mu2 for allocating memory for a node in the second polynomial. Head2 always points to the first node of the second polynomial. P2 for traversing from one node to another node in the second polynomial. So this is nothing but node representation in the polynomial. So let's see the first operation. So here the first operation is create operation. So creating the polynomial. So in this function we have to create 2 polynomials. So creating 2 polynomials. So we have to create 2 polynomials here. First let us create the first polynomial. So printf enter first polynomial. Enter first polynomial. Here we are using do while loop. Do. Here the logic is very simple. First we have to allocate memory for the node. In order to perform operations on the first polynomial, we are using u1, head1 and p1. So allocate the memory for the polynomial with the help of u1 node. This node contains three fields: coefficient field, exponent field and null field. Let us assume that the address is 1000. Okay. So first allocate memory for the node. So u1 is equal to struct node asterisk malloc of size of struct node. Next we have to read the coefficient and exponent. So printf enter coefficient and exponent. Enter coefficient and exponent values. Next, coefficient and exponents are nothing but integer values. So scanf %d comma. We have to store coefficient in this field, coef field, and exponent in this field, expo field. So here the addresses are ampersand u1 arrow coef ampersand u1 arrow expo. So let here the coefficient is, let the first polynomial is like this: 8x power 6 plus 3x power 4 plus 9. So what is the first polynomial here? First polynomial coefficient is 8, exponent is 6. Okay. So 8 is the coefficient value and 6 is the exponent value. Then after that we have to check whether the polynomial is empty or not. We can say that here a polynomial is empty if head1 is null. Why? Because head1 points to the first node of the first polynomial. If head1 is null, then we can say that that polynomial was empty. No node is created in that polynomial. No term is there in that polynomial. Okay. Here this structure was defined on top of the main function. So the default initial values are null only. So the initial value of the head1 is null. So if head1 is null, then we have to place p1 and new1 at new1 location. Head and head1 and p1 at new1 location. What is new1? 1000. So we have to place, if head1 double is equal to null, then place head1 and p1 at new location. So head1 is equal to new1. So what is new1? 1000. So head1 will be placed at 1000 location, as well as p1 will be placed at 1000 location. Here head1 should always point to the first node only, whereas for traversing from one node to the another node we are using p1. Okay. Now let us create one more node now. So for allocating the memory we are using new2. So first we allocate the memory with the help of new1. Okay. Now this is no longer available. So new1, and let the address here is 2000. It has two fields. Next here we have to store null here. In u1 next we have to store null here. So after storing coefficient and exponent value, we have to store null in u1 next field. So u1 arrow next is equal to null. Okay. Now u1 is at 2000 location. Okay. So now what we have to do? Okay. Printf enter coefficient exponent value. So what is the second term coefficient exponent? 3 and 4. So 3 will be stored in coefficient field, 4 will be stored in exponent field. And then we have to store null in next field. So store null in next field. So next check whether the list is empty or not. What is head1 now? 1000. 1000 double is equal to null. So condition is false. So what we have to do now? We have to establish a connection from this node to this node. Here in order to establish the connection we have to use p1. Don't use head1. Why? Because after that we need to create one more node. We may create one more node. Then we have to establish the connection from second node to the third node. But at the second node we have p1. We don't have head1. Head1 always points to the beginning node only. So here in this location we have to store 2000 because this is nothing but next field. Okay. So what is the statement here? Else p1 arrow next is equal to P1 here next is equal to new 1. So what is new 1? 2000. If we store 2000 here, a link will be formed like this. Next we have to place P1 at this location. So P1 is equal to new 1, or we can write as P1 is equal to P1 arrow next. So it is our choice. So P1 is equal to new 1. Okay. So now P1 will be placed at 2000 memory location. Okay. And now let us write one more statement. Printf, do you want to add one more term to the list? Do you want to add one more term to the list? One more term to the list or to the polynomial. To the polynomial. So we have to enter either y or n. So we have, before that, declare a variable called character variable called ch. So scan of %c comma ch. Next, close the do. Here the condition is while ch double is equal to y. So as long as we entered y stands for yes, then we can enter one more node to the corresponding polynomial. Okay. If we enter other than y, that means if we enter n, then the control comes out from the loop. Okay. So these two nodes are created. So this statement will be executed. Do you want to add one more term to the polynomial? Let us assume that we entered y. So scan of %c comma &ch. Now ch contains y double is equal to y. Condition is true. So one more time this body will be executed. So first what will happen? Memory will be allocated for the node. So name of the node is new 1. So no longer this new 1 is available here. So new 1 is available here. So let the address is 3000. It has 3 fields. Next, printf enter coefficient and exponent. Here the coefficient is 9, exponent is 0. So store coefficient in coefficient field, 0 in exponent field. Store 9 in coefficient field, 0 in exponent field. Next new 1 arrow next is equal to null. Here store null here. Okay. Next we have to check whether the list is empty or not. If head 1 double is equal to null, but what is head 1? 1000. 1000 double is equal to null. Condition is false. So else block will be executed. So P1 arrow next is equal to new 1. So in place of this null we have to store 3000. Why? Because this is P1. P1 next. In P1 next store new 1. So that a link will be formed like this. Next P1 is equal to new 1. So store P1 at new one location. Printf, do you want to add one more term to the polynomial? Let us assume that we entered y. Now ch contains n. Let us assume that we entered n. N double is equal to y. Condition is false. So the control comes out from the loop. Okay. Now till now we have created the first polynomial. Next we have to create one more polynomial. Let that polynomial is like this. 10x power 8 plus 7x power 6 plus 7x square plus 10. So let it is that polynomial. Okay. So let this is our first polynomial, this is second polynomial. So here just we need to make some modifications here. In place of first we have to write second. Next in place of new 1, in order to perform operations on the second polynomial, what we are writing? New 2, head 2 and P2 we need to use. So in place of new 1 we have to use new 2. Next in place of head 1 we have to use head 2. In place of P1 we have to use P2. So likewise we have to write the code here. Printf enter the second polynomial, new 2 is equal to struct node star. Next printf enter the coefficient and an exponent. In place of head 1 we have to write head 2. If head 2 double is equal to null, head 2 is equal to new 2, P2 is equal to new 2. So likewise we have to create the second polynomial also. So till now the first polynomial was created as well as second polynomial was created. Next we have to display the polynomials. So let's see display function now. Now let's see the display function. So display. So here we have two polynomials. This is the first polynomial and this is the second polynomial. So display polynomial with the help of linked list. What is the first term of the first polynomial? 10, 6. Address is 1000. It contains address of the next node, that is 2000. Next to second node address 2000. What is the second term of the first polynomial? 3, 4. Let the address is 3000. Next to 3000. 9. Exponent is 0. and the last node next field contains null. So this is our first polynomial. So head 1 will be placed at 1000 location. Now let us write the code for, now let us represent the second polynomial in the form of the linked list. Here we have only two terms. Let address of the first term is 1000, address of the second term is 2000. So coefficient of the first term 10, exponent 8. Here address is 2000, so that a link will be formed like this. Next second term coefficient 7, exponent 6. We know that the last node next field contains null. So here we can have some null feet. Next head 2 will be at 1000 memory location. Okay. So next for traversing, in the first polynomial we use P1. So we have to place P1 at the head 1. Next P2 should be placed at head 2. Here we have to display the output as here what is the first term here, 8x power 6 plus 3x power 4 plus 9, 10x power 8 plus 7x power 6. Okay. Here for the first polynomial the output is 8x cap 6 plus 3x cap 4 plus 9x cap 0. This cap represents power operation. Okay. So initially we have to place P1 at head 1 location. P1 is equal to head 1. Then printf first polynomial is so P1 should be placed at head 1. Next we have to check whether it is not equal to null or not. If it is not equal to null, then display the corresponding coefficient and exponent. Okay. So here the condition is while P1 is not equal to null. So what is P1? 1000. So 1000 is not equal to null. Condition is true. So display the coefficient and exponent. So first to display coefficient. So percentage D. After displaying the coefficient, display x. X. Next cap symbol. Cap. So what is 6? 6 means it is exponent. It is nothing but an integer value. Comma. So P1 arrow coefficient comma P1 arrow expo. So what is P1 coefficient? 8. So 8 will be printed. Next x cap will be printed. Next what is P1 exponent? 6 will be printed. So next we have to place P1 at 2000 location. What is P1? 1000. So 1000 next means 2000. So here the statement is P1 is equal to P1 arrow next. So P1 means 1000 here. 1000 next means 2000. So now P1 will be placed at 2000 location. Okay. Then after that here we have to check whether it is not equal to null or not. If it is not equal to null, then display plus value. If P1 is not equal to null, then printf display plus. Let us assume that here we have a plus only. So printf plus. Okay. So if here P1 is not equal to null, so that's why plus is displayed. So once again control goes to the condition. So condition will be checked. What is P1? 2000. So 2000 is not equal to null. Condition is true. What is P1 coefficient? 3. So 3x cap. What is P1 exponent? 4. So 3x cap 4 will be printed. Next P1 is equal to P1 arrow next. What is 2000 next? 3000. So P1 will be placed at 3000 now. Next if P1 not equal to null. What is P1? 3000. 3000 is not equal to null. Condition is true. So printf plus. So plus will be printed. Next once again control goes to the condition. While P1 not equal to null, 3000 is not equal to null. Condition is true. So printf percentage D x cap percentage D. So what is here? P1 coefficient 9. So 9x cap will be printed. Next what is the exponent? 0. So 9x cap 0 will be printed. Next P1 is equal to P1 arrow next. So what is P1? 3000. So 3000 next means null. So now P1 will be placed at null. P1 will be placed at null now. If P1 not equal to null, but what is P1? Null. So null not equal to null, condition is false. So the control comes out from the if. Okay. So once again control goes to the while loop. Okay. While P1 not equal to null. What is P1? Null. Null not equal to null. Condition is false. So the control comes out from the while loop. So in this way we have to print the second polynomial also. So here the statements are very simple. P2 is equal to P2. Print of second polynomial is while P2 not equal to null. In place of P1 we have to write P2 only. So with this displaying of the polynomials are also over. Next we have to add two polynomials. Now let's see about addition of two polynomials. Here there are three cases. If the exponents are equal, then we have to add the coefficients and the exponent is same only. Suppose if the first polynomial exponent is larger one, then the resultant term will become the first polynomial term. Suppose if the second polynomial exponent is larger one, if second polynomial exponent is larger one, then the resultant term will become that second polynomial term. So let's take this one, 8x power 6 plus 3x power 4 plus 9, 10x power 8 plus 7x power 6. So initially P1 will be at 8x power 6, whereas P2 will be at 10x power 8. So what is the exponent of the first polynomial? 6. Exponent of the second polynomial? 8. So which is the larger one? 10x power 8. This 8 is the larger one. So the resultant term will become this 10x power 8. So we have to display 10x power 8. Next, this is displayed. So we have to move P2 one position to the right. Now P2 will be at the next node. So what is P1 exponent now? 6. What is P2 exponent now? 6. Both are equal. That means exponents are equal. If exponents are equal, then we have to add the coefficients. So what are the coefficients here? 8, 7. 8, 7 means 15. And what is the exponent? Both are equal only. So 15x power 6. And next, so this is over. So we have to move P2 one position to the right as well as P1 one position to the right. But what is P2 now? P2 will become null now. Okay. So that means here so 7x power 6. That means here P2 becomes null now. That means here P2 is completed. So if the second list is completed, if the second polynomial is completed, then we have to check whether the first polynomial is completed or not. But here the first polynomial is not completed. So we need to add the remaining terms of the first polynomial to the resultant polynomial. So what are the remaining terms of the first polynomial? 3x power 4 plus 9. So we have to add those terms to the resultant polynomial. So this is the logic which we have to implement now. Okay. So initially place P1 at head 1 location. So P1 is equal to head 1. So P1 is placed at head 1. Next to P2 is equal to head 2. So P2 is placed at head 2 location. Next we have to repeat the loop as long as P1 is not equal to null, and that means these two conditions should be true only, and P2 double is equal to null. If these two conditions are true, then only we have to execute the body. So here we have three cases. First case, if exponents are equal, if P1 exponent is equals to the P2 exponent, that means both the exponents are equal. If both the exponents are equal, then what we have to do? We have to add the coefficients and print the exponents. So printf percentage d x cap percentage d comma. So what is first percentage d? Coefficient. Here what is the coefficient result? Addition of P1 coefficient plus P2 coefficient comma. What is the second percentage d? Here exponents are equal, so we can write either P1 exponent or P2 exponent. There is no problem. Okay. Next, operations on P1 and P2 are over. So we have to move P1 one position to the right. So P1 is equal to P1 arrow next, and P2 one position to the right. So P2 is equal to P2 arrow next. So next condition, else if P1 arrow expo is greater than P2 arrow expo. That means here P1 exponent is larger one. If P1 exponent is larger one, then P1 term will become the resultant term. So printf percentage d x cap percentage d comma. So what we have to do now? The resultant one is here P1 exponent is larger one. So P1 arrow coefficient comma P1 arrow exponent. Okay. P1 arrow coefficient comma P1 arrow exponent. Why? Because P1 exponent is larger one. Next we have to move only P1 to its next node. Don't move P2 to the next node, because operation on P1 is over. Operation on P2 is not over. Else, so when this else block is executed, if P1 exponent is lesser than P2 exponent, that means P2 exponent is larger one. So if P2 exponent is larger one, then what we have to do? The resultant term will become P2 coefficient and P2 exponent. So P2 arrow coefficient, comma P2 arrow exponent. Here operation on P2 is over. So move P2 to its next node. So P2 is equal to P2 arrow next. Here, after displaying the operation, we have to print plus here. So that's why write one more condition. If P1 is not equal to null or P2 is not equal to null, so then what we have to do? Printf plus. Printf plus. So display plus symbols. So in order to display the plus symbol, we use this condition. Next, we have to add the remaining terms to the polynomial. So while P1 is not equal to null, that means there are some terms in the polynomial. If there are some remaining terms in the polynomial, then we have to add all those terms to the resultant polynomial. So display that. So printf percentage d x cap percentage d comma. Here we are displaying P1 terms. So P1 arrow coefficient comma P1 arrow exponent. So after displaying, move P1 to its next node. So P1 is equal to P1 arrow next. Next one, if P1 is not equal to null, then what we have to do? We have to display plus symbol. So likewise, we have to write the code for P2 also. While P2 is not equal to null, then printf percentage d x percentage d comma P2 arrow coefficient comma P2 arrow exponent. Next, move P2 to its next node. So P2 is equal to P2 arrow next. Next one, if P2 is not equal to null, then display plus symbol. Okay. If P2 is not equal to null, then display plus symbol. Here what is the condition? If P1 is not equal to null, or here we can write as double and also double R. If it is not equal to null, okay, then we can display plus symbol now. Okay. Now let's check whether our logic is correct or not. So P1 is equal to head 1, P2 is equal to head 2. So P1 is at 1000 location, P2 is at 1000 location. Here let us take this one as some 4000 and 5000. So 4000, 5000. So this is nothing but 5000. Okay. Why P1 not equal to null? What is P1? 1000 is not equal to null. Condition is true. And P2 not equal to null. 4000. Condition is true. So both the conditions are true. So the body will be executed. If P1 arrow expo double is equal to P2 arrow expo. What is P1 expo? 6. But what is P2 expo? 8. 6 double is equal to 8. False. So second condition will be executed. Second condition will be evaluated. Else if P1 arrow expo greater than P2 arrow expo. What is P1 expo? 6. P2 expo 8. 6 greater than 8. Condition is false. So this else block will be executed. So printf percentage d x percentage d comma P2 arrow coefficient comma P2 arrow exponent. What is P2 coefficient? 10. So 10 will be printed. Next x power 8. X power 8. So 10 x power 8 will be printed. Okay. Next P2 is equal to P2 arrow next. What is P2 next? 5000. So now P2 will be placed at 5000 location. If P1 not equal to null or P2 not equal to null. So 1000 not equal to null. Condition is true. 5000 not equal to null. Condition is true. So what will happen? Plus symbol will be printed. So once again control goes to the while loop. While P1 not equal to null. What is P1? 1000. 1000 not equal to null. Condition is true. What is P2? 5000. 5000 is not equal to null. Condition is true. Next, first condition will be checked. What is P1 expo? 6. What is P2 expo? 6. 6 double is equal to 6. Condition is true. So what is the resultant coefficient? Addition of the corresponding coefficients. So 8 plus 7 means 15 x cap. What is the exponent value? Both are same only. Okay. So we can write either P1 exponent or P2 exponent. So 15 x power 6. Here this condition is evaluated. So what will happen? The remaining conditions will not be checked. So what is the last one? If P1 not equal to null or P2 not equal to null. So both are true only. So what will happen? Plus symbol will be printed. So once again control goes to the condition. Okay. Once again control goes to the condition. Okay. So here what is the condition here? The operations on P1 and P2 are over. So move P1 one position to the right, as well as move P2 one position to the right. So what is P2 next? 5000 next. What is 5000 next? Null. So now P2 becomes null. So once again control goes to the condition. While P1 not equal to null, double and P2 not equal to null. But what is P2? Null. Null not equal to null. Condition is false. So the control comes out from the while loop. So what is the first condition? While P1 not equal to null. What is P1? 2000. So 2000 is not equal to null. Condition is true. So body will be executed. Okay. So what will happen now? P1 coefficient as well as P2 exponent will be printed. What is P1 coefficient? 3. What is P1 exponent? 4. So 3x cap 4 will be printed. Okay. Next P1 is equal to P1 yellow next. What is 2000 next? 3000. So P1 will be placed at 3000 memory location. If P1 not equal to null, what is P1? 3000. So 3000 is not equal to null. Condition is true. So plus will be printed. So once again control goes to the condition. What is P1? 3000. 3000 is not equal to null. Condition is true. So P1 coefficient and P2 exponent will be printed. So 9x cap will be printed. P1 is equal to P1 yellow next. What is 3000 next? Null. So P1 will be placed at null now. So null not equal to null. Condition is false. So control comes out from the while loop. Okay. Next, while P2 not equal to null. But what is P2? Null. Null not equal to null. Condition is false. So the control comes out from the while loop. So this is nothing but our resultant polynomial. So in this way we can add two polynomials. So like addition, we can also perform subtraction very easily. But what is the code we have to write here? In place of this addition, we have to write the subtraction. In place of plus operator, we have to write minus operator. So this is the only change which we have to do. So this is about polynomial ADT.